Yes, I confirm that's working.
All right, just so that I wasn't on mute, which is okay because I was going to unmute myself. So organizer, can you just double check that my audio is coming through and everything is okay? And then we'll get started.
Yeah, looks good and sounds good.
Fantastic. So, it's a very big welcome for everyone who is connecting from the internet on the YouTube stream, or luckily was able to attend in person, virtually, but in person to the Zoom meeting that we are organizing for Clojure this year. So we are going through a little bit of the logistics, organization, and things that we think are going to be useful for understanding, also for ourselves to understand how a virtual conference is going to work. I've attended many conferences, but I think this is like one of the fewest I've attended online in this way. And not to mention organizing it along with the other organizers. So everything new for us. So bear with us if any, hopefully everything will go as expected with in the live situation. So a very big welcome again. And let me see. So this is like our virtual world. We're going to have a few services that we are using in order to communicate. And as you can see, we are already on Zoom sharing screens. We are going to have a live conversation on Zoom as well. We are going to have the talks, of course, panels and keynotes, all handled in Zoom. When I say live conversation, it means that sometimes we are going to be able to make questions directly on like with the speakers, and those are the panels. Sometimes we're going to use Discord, like chat server that we think we are going to use for most of the questions and communication that anything that can happen offline will probably happen offline on the Discord server. So if you still haven't seen where the Discord server is, the link to it was sent by email to all the attendees and all the speakers. So please refer to that and join us on Discord. YouTube, we are streaming on the Reclojure channel. You can like quickly find it by just searching on Google or YouTube for Reclojure. You will see the stream is probably coming up first on the list of results. So if you have anyone that would like to join but doesn't want necessarily to attend the Zoom or doesn't have the client to attend, you can just refer them to the streaming. On the website, we are keeping the schedule and all the details about the talks that we're going to see today and tomorrow. And of course, also the abstract. If you click on any of the talks, you will see more details and the bio of the speaker. And as usual, we're also having a look at Twitter. If you feel like send a message there or share your love for the conference or anything interesting that is happening there, just please use the hashtag Reclojure, and we'll retweet or make sure that it reaches everywhere if possible. A couple of words about the format. So both days are going to be structured in the same way. We're going to have one intro that you're looking at the moment. We'll see tomorrow exactly what we are going to talk about. We're going to probably to introduce the schedule, but no more. And followed by 2 talks. And every 2 talks, we have what we call a QA panel. So this is a kind of a new thing we are experimenting, or at least I never saw it done it this way. And it's just taking the 2 past speakers, the 2 previous talks, 2 or more, because it depends. Some talks have more than 1 speaker, and it's putting them together in the QA panel. And the idea is that you are going to be able to make questions. Sometimes you can make them on a live talk if the speaker stops and has a minute to answer questions, or they finish early. You can ask questions at the end. That would be the usual classic way. You can send questions always to the relative channel on Discord. We created a channel for each of the talk and for each of the panels, so feel free to use them liberally for comments or questions. We are going to try our best to collect all the questions, put them in a right order if possible, and relay the questions to the speakers if you don't want to if you don't want to attend the panel and ask the question yourself. For the panel, we have a slightly different organization, and I have a slide for that, and I'm going to present that in a second. There's going to be a break. The break probably is the moment you might step up from the keyboard for a second and take a breath, take a short walk. And then we're going to be back again for another slot of 2 talks, 1 QA panel, 2 talks, 1 QA panel. At the end of the day, we're going to have 2 fantastic keynotes. Today, we're going to have a conversation with Dan Friedman and a lot of other surprise guests. I cannot disclose them, but they'll be in the audience, and I think they're going to make very interesting questions. And yes, if you just want to understand who is going next, we're going to put a slide with the next presentation that is going up. But if you want to always check the schedule, feel free to go on our website, reclojure.org, and you'll see all the details of the schedule there to know what is coming next. I know that many of you are not at GMT 0 time zone, and that's fantastic because this is a very nice opportunity for us to get in touch with everyone, or almost everyone in the world, except who is maybe deep asleep at the moment. If you want to know when the next talk will be in your time zone, you're interested in a specific one, if you click on the slot on the website, is on the actual time, is going to bring you to time.is, where that is translated into your time zone, so you can double check. Moving on. You did twice, sorry. So for the interaction, so I specified most of the interaction will happen on Discord, but during talks, you feel free to send any questions to the related Discord channel, and we'll make sure that they are collected. And if there is time during the talk, and the talk is live, of course, we are going to ask the speaker at the end if there is time. But if there is no time, don't worry. We are gonna have questions anyway happening during the QA panel. During the QA panel, the interaction is slightly different. We'd like you to participate if you want. So we're gonna use the raise hand feature of Zoom. So you can raise your hand live during the QA panel to ask a question, and we'll give you the microphone, and then you can ask your question. At the same time, the Discord channel is always open, and we'll look at that to understand understand if there are more questions. The same goes for the keynotes. Raise your hand will be the primary way. During the break, again, yeah, feel free to go take a breath, and we'll be back soon, like in, I think is only half an hour, the break. To contact the organizer, there is a dedicated slide, so I'll go through that in a second anyway. Yeah, it might be worth noticing that we are not going to actively using the Zoom chat for anything. So the Zoom chat will be open during the conference, but we are not asking you to do like anything specific to interact with the conference on the Zoom chat. So we might have a look at that, but we are not always looking at that. So keep that in mind. Discord is probably the best place. Once again, for panels and keynotes, this is just a little bit more details. There is this raise hand feature in Zoom that you can use. I thought it was like interesting now to see if I can open up the chat, if I can see any of the participants raising their hands. Then I'm gonna maybe try to have somebody speak so we can see that everything is working as expected. And at the same time, I'm also understanding if I'm doing things correctly. I just need to see the participants. I don't see any raised hands. Let me see, I'm scrolling down the list of participants. Can anyone raise their hands? So, okay, I can see them now. So let me see. Can I give some of you, oh, you already like turned your hand down. I just wanted to give you the opportunity to speak to somebody. So I gave the opportunity to you one, I think, to speak, or maybe not, because everything is moving fast.
Yeah, I can speak now. Hi, guys.
All right, thanks. So we know that the feature is working properly. So you can ask your question at this point, or maybe you have a comment, and then yeah, we'll probably just switch off your microphone, or please feel free to do yourself. Fantastic. So if for any reason you need the organizers at any point during the conference, the preferred way to contact us is on Discord. Those are our handles. At the same time, it's probably like a good time now to thanks everyone who was involved in the organization of the conference. And these are the people who are mainly responsible for bringing the conference to you today. During or after the conference, you can also use the Clojure channel on Clojure Slack. So the Discord will be closed, and if you want to reach out for anything specific about the conference, or maybe when the videos will be out and questions or any other kind of questions, feel free to find us on Slack. And these are our handles on Discord. So we'll probably post them on general, if it's not already done, on Discord, so everyone can see what the handles are, and you don't forget them. Have a look at the code of conduct. Is also linked on our website. It's pretty much common sense, but we ask everybody to be polite, flexible, accepting everyone's opinions. And I absolutely don't think this will be something we need to reiterate during the conference during any other time over the conference. So we had a fantastic in-person conference last year, and everyone was really friendly, and we hope to just replicate the same experience this year, even virtual. So just relax and enjoy the conference, but feel free to have a look at the code of conduct. Again, this is like everything that we need to say before getting started with the first talk. Thanks everyone for attending. A big thanks to all the speakers who like rushed to put together fantastic talks that we are going to see today, both recorded, both pre-recorded, both live. It's a fantastic experience anyway. The speakers will be here with us to like talk about their topic over the Q&A panel. A big thanks to everyone, organizers, attendees, and speakers. One last thing. So if you noticed, if you had a look at the schedule over the last like few days, we changed a few things, not like huge changes, but May couldn't attend the conference, unfortunately. Mauricio was like flexible and was very flexible and accepted to prepare like a talk very last minute. So many thanks, Mauricio, to stepping up. And now we have a full schedule as expected. So we have a total of 16 talks between the 2 days as expected. And there was a couple of changes in the schedule. So please, if you're interested in a specific talk, just double check if the talk is happening at the time you expected it to be. It might be like slightly later or moved to the previous day. So just keep that in mind. And with this, I'm going to turn like the screen sharing off. We have still a few minutes, so we'll prepare for the next talk, making sure that everything is ready. And we'll be back like in probably 10 minutes. We'll probably start like 2 or 3 minutes ahead because I'm pretty sure that with the talks and the streaming and changing between the different talks, we're gonna waste a little bit of time between those. So we can probably start like vaguely earlier, like 2 or 3 minutes ahead of time. So thanks everyone, and talk to you like in about 10 minutes. So let me open the microphone for a second, and we're just about to start with the next talk. There was the first problem, and now it should be solved. Many of you were not able to enter the conference because we reached the standard 100 meeting participant count. We had we had purchased it like a 500 license, and unfortunately, there was a one last step that had to be done. Not just purchasing it is not enough. You had to assign it to the meeting host. So I'm really sorry for that, and it is part of like using these tools at scale for the first time. So everyone now should be able to like enter, at least for the amount of tickets that were sold. So I don't know if you have, I don't know exactly how to reach out for whoever was unable to enter the Zoom meeting, but I think we'll try to get them in by chat or other ways and tell them that everything is solved. So with that out of the way, hopefully that was the only and last problem for today. Let's hope, and tomorrow. We are going to start with the first talk of the day. I'm very happy that John and the Crux team put together a very nice presentation to open up the conference. They were also, I don't know if you noticed, but they were also running a workshop and on Thursday that went very well, and they'll be running more workshops related to Crux. So in this presentation, we're going to see like a little bit of what Crux is about, but also the internals. And we will see like a few of the people that were involved in the creation and maintenance of Crux. So without further ado, I'm going to start with the first presentation. And I always need like 2 seconds to find where the buttons went.
Hello, my name is John Pither, and I'm the CEO of Juxt. In this talk, we're going to be looking at Crux, the past, the present, and the future. We're going to look at the past. How did Crux come to be? What's the origin of Crux? Why Crux? We'll also look at the present. What challenges are we facing right now? What features are we working on right now? And what does some of the code look like right now? The code that makes Crux tick, including some of the more hairy areas. We'll also look at the future of Crux. Where is Crux going? What does the roadmap look like? What challenges are we facing? And what decisions do we have to make? Crux is still an evolving product. So thank you very much. This is the first talk of Reclojure. We're hugely excited to be here. It's going to be a fantastic conference. So let's get started. So what I want to show is the origins of Crux. Where did Crux come from? We talked about Crux being this unbundled database. So let's dive into the REPL, and I want to start showing you a few things, some of the core concepts. So this namespace here, I have a couple of protocols defined. The event log is like the first thing we want to unbundle. This is a sequenced store of events. It's as we learn facts about our business, as we come across these facts, we ingest them, and then we have them there forevermore in an event log. And we can store our messages, but we can also fetch our messages from a particular offset. This is kind of the way that something like Kafka works. We store our events onto an event log, and then we can say, from this offset, I just want to read all the events in sequence from that point. Then I've also got a KV store. And this is simply a place for me to store my events as I read them off from Kafka. And I want to show how with these two basic parts, we can start to get a semblance of a real working mini kind of database system that can suit some client requirements. This is where Crux came from. But I just want to show you, for the purposes of demonstration, I've created a atom-backed event log. So this is like a fake Kafka. And all this really does is, instead of actually using Kafka for the event log, I'm just using an atom, which is essentially a vector. And I'm just storing my messages into this vector whenever you call store message. And then I've got a function here to say fetch messages with this offset. And as you can see, I've just got a rather cheeky drop while in there. So it derefs this atom, which gives you back a vector of messages. And then it just drops the first ones that are before this offset and then gives you the ones after that offset. So a cheeky little bit of Clojure here. And this, in 5 or 6 lines, is our pretend Kafka. So this is my atom-backed event log. And as you can see, if I go to my main namespace here, I'm creating one of those. And then I'm just storing some messages into it. And what I'm trying to demonstrate here is a sort of timeline of events. We released Crux 2019, so we spent a year, more or less, building it before we released it, about 2,500 commits. We released it at Clojure North, made it go live on GitHub, which was a good moment. James Henderson came in as our tech lead, and this is where we're at, Clojure 2020. So you can see I have a timeline, and I'm storing each one of these messages into my pretend Kafka. Right, so the offset is the date. And you could think about this as transaction time. And now if I wanted to, I could just say, look, you know, we've got our pretend Kafka here. Fetch me all of the messages from a particular point in time. So let's just say 2019. I'm not interested in the 2018 stuff. I want all the events from 2019 onwards. And with any luck, this should give me those. And as you can see, we've got events from 2019. So Crux being released, James Henderson joining, and Clojure. So RocksDB is written by Facebook. It's tremendously scalable, and it's what we use in Crux in the unbundled sense to house our indexes. So we've got Kafka as the event log. When you write a document into Crux, it goes onto Kafka. It's persisted. That's the golden store, this event log. But then we use RocksDB to build up some clever bitemporal and content indexes that really enable you to do this general cross-purpose queries against. So I have my Rocks KV store here, which if I go to the namespace here, this is basically implementing that KV store protocol. I've got seek and I've got store. I've got seek and iterate, which I'll come on to. But just think about seek and store as the main two. So first of all, I'm going to fetch all of the messages from our pretend Kafka from a certain date. Here I'm saying 1500. And then I'm going to write them into our KV store. And that's what I'm doing in these 2 lines here. So now, after these 2 lines have been executed, our Rocks KV store has all of the events inside of our pretend Kafka event log. So now I should be able to seek from at a point in time. And note that here, what I'm doing is I'm storing my keys as longs. So I have a function here to convert a Java instant into a long. And all this really does is that it just calls get time on it. So pretty simple for now. Get time gives you a long. I'm storing longs. Happy days. Now, inside of our KV store, these longs are actually indexed in order. So if I have some keys in here, so imagine we've got a key, which is the long equivalent of 2010, and then the long equivalent of 2011, and the long equivalent of 2012. Because they're stored in order in Rocks, and Rocks is a KV store, I can say, well, I want to seek at a point in time. So if I seek about sort of 2011, and let's say it was a date in there, it's going to seek in between these keys. And in this actual case, I would get 2012 back. And that's kind of what's happening here. So if I do my seek on 2000, then the first event I get back for that is the pre-Crux prototypes, right? Because that's like the next thing on. So I'm seeking, I'm not hitting anything for that precise value, but then in a lexicographic way, it then gives me the next value on from that. And now if I wanted to say, well, I want to seek halfway through these dates, and we can see I've got these dates here. If I want to say, well, give me something around the actual Crux project time, so let's do 2009, let's do 2019, let's do June, then the next event on from that is James starting. James actually joined in September, but that lexicographic range query, that seek operation, is going to give me the next thing on from the date that I asked for, which is when James joined in September. So makes sense so far? So if you think about it, we're building up like a temporal index here. We've got the ability to seek at any point in time, and then it gives us the match closest to the point that we asked for. So we've kind of got a timeline in our KV store here, and we're seeking across, seeking at points in that timeline. Well, I want to pose a question here, right? Which is, but let's imagine that we were searching in a couple of days' time. So let's add in a string. Let's do an instant for 2020. And let's say we're sometime in December and it's 06. We don't get anything back, right? So this is a kind of problem. Imagine you've got like a store of events, or imagine you've got a store of documents like trades or something, and you index them in a time-like way using this. You kind of want the ability to say, find me the latest thing as of now. And this doesn't do that for you. This like will try and find the thing after now, the thing in the future which hasn't happened yet, which we've got no data for. So this index is kind of flawed in a way. We need to do something. One trick that we learned is to reverse the timeline. And we learned this earlier on, and it kind of helps you with this specific use case. So if I now do a bit not, then now, if I search for a date in the future, before we didn't get anything. But now, because we've reversed the whole timeline index, we're actually going to get the next thing, but in the past. So the index actually starts from the most nascent, the most recent bits of data in the timeline index, and then it descends through it as you go through the index in order as it's stored in rocks. So now we're saying, I want to seek at a point in the future, but then the next thing on from that is going to be the next thing in the past, which is this Clojure 2020 event. So now I can seek and iterate. Just whack this in. So I'm seeking and iterating from this point in time, 2019, and then I'm going back through all of the events in the past. So here you can see we've got James, then we're going back into the past more, which is Crux release, then we're going back into the past more, which is Crux development starts, and then we're going back into the past, which is the pre-Crux prototypes. And this is kind of the way Crux still works to this day. We still have an index where we have instants in there serialized as longs, but then they are reversed. So the order is like a reverse order. Crux still works like this today, indexing timestamps as reverse longs that allows us to seek, to scan, and to iterate across the history of our database. Crux very much grew up from these primordial parts of an event log and a KV store, and then building up these timeline indexes. I hope you enjoyed this origin story. Let's move forward with the rest of the talk.
Hi there, I'm James Henderson. I'm the technical lead on Crux. I'm responsible for its day-to-day development and releases. I'm going to talk a little on the indices we keep in the query index store, how we use them in queries, and how they can be adapted for use in speculative transactions. In Crux, we make a distinction between content and bitemporal indices. The content indices keep a track of all the values an entity has ever taken. So if I lived in Scotland but then moved to England, these indices would contain both facts. They don't know anything about what entities had what values and when. The bitemporal indices store what version each entity has at any point in bitemporal time. And so given that Crux is a document database, we do this temporal resolution at the document level, rather than at the level of individual facts. And this version is in fact a content hash of the document's content. In practice, on the assumption that you often query more than one attribute from a document at any one time, this means we only need to do the bitemporal dance once. So let's say we have a query where we're looking for all of the users living in England. We first go to the content indices. We have an index that will efficiently tell us all of the entities that have ever lived in England and their content hashes. And then we check the bitemporal indices. So did that entity have that content hash at the time we're querying for? If so, great, we have a match. And the case where we don't have a value in hand is similar. We have another content index that will efficiently tell us all of the entities that have ever had any value for the attribute lives in. As for how we store these indices as sorted prefix trees. So for the value in hand query, we have an index sorted first by attribute, then by value, and then by entity, an AVE index. In practice, we concatenate together the A, V, and E into one byte array. And when we then search for a value, we create a byte array containing A and V, and then use a byte array prefix seek to navigate through the tree to the first value after our search value. From this point, we can then scan through the tree, yielding different E's for our AV, until we hit a different prefix. So, John talked earlier about the unbundling of Crux. In this case, for the query indices, we're looking for an underlying storage provider that supports both fast seek to a key and then fast scan from that key. We also keep other content indices with various different variable orders to help out in the query engine. The bitemporal indices are ordered first by the entity ID and then by the bitemporal coordinates. The values in the KV for that contain the content hash of the entity at that time. Think about when we index a transaction. We have to update both the content indices and the bitemporal indices. We need to ensure that we update these indices atomically, although thankfully this is mostly handled by our underlying storage. We just need to make sure that we insert any changed keys in the same write batch. The indices themselves are purely additive. With the notable exception of eviction, we only ever insert keys. We don't ever update or delete. There are, however, a couple of cases that involve us needing to query the indices while the transaction is in progress. The bitemporal semantics require us to check the up-to-date history of an entity in order to update the bitemporal indices. Specifically, if a transaction contains multiple writes to the same entity at different points in the timeline. Similarly, during a transaction function authors can request a DB instance and make queries against it, and they expect to see the effect of the transaction so far. Thankfully though, because these indices are all sorted trees, they merge easily using a standard merge sort algorithm. Because we only use a few relatively low-level operations, seek, scan, and get value, it's relatively easier to abstract away the fact that we essentially have two underlying indices. Indeed, we have an implementation of a KV store, which combines a persistent on-disk index with a transient in-memory index. And the query engine doesn't know whether it's querying just the on-disk indices or with an in-memory index on top. This merging also means we can then make one large write to the persistent KV store at the end of the transaction, which turns out to be quite a performance boost over lots of smaller writes. Another fortunate consequence of being able to merge indices in this way is the ability to easily offer speculative transactions. Now, we introduced speculative transactions to Crux after a significant amount of user requests. It seems that to be the sort of feature that once you're aware of it and have used it a few times, you can't live without it. I say fortunate consequence because it turns out that once you have the ability to efficiently merge indices in this way, there's very little that actually needs to change internally to implement speculative transactions. A speculative transaction is simply an in-flight transaction that's never committed. If you're interested in finding out more about how Crux stores its data, you can have a look in the GitHub repo under the Crux core module, starting off with the Crux TX and Crux KV index store namespaces. Thanks.
Hello there, my name is Daniel Mason. I've worked at Juxt for just over a year and I work as an engineer on Crux. So today I'd like to talk about some recent changes that have been made to the HTTP server, and in particular, the addition of JSON. So to give some background, the HTTP server was sat in an alpha state while the other modules had been moved into beta, and it was mostly because we wanted to make some improvements to commit to it as a stable API. To summarize, it was making endpoints more consistently named, handling parameters more consistently, doing errors in a standard way, and so on, and also ensuring that everything on the API was reflected within the HTTP server endpoints. And another element of this was content negotiation, which leads me on to JSON. So when standardizing the content negotiation, we decided to introduce both JSON and transit for input and output. And this was because beforehand, the only way to interact over the HTTP server was with Eden. Eden is and still continues to be very important throughout the rest of Crux, but we realize it's important to not be tied to a single format, And this seemed like a good first step towards JSON in the broader Crux ecosystem. The implementation itself was made much more possible by the addition of string IDs in documents. So now I'm going to give a quick demo using the Crux HTTP server and using JSON for input and output. I'm going to begin by taking a look at the node configuration we're going to use. As you can see, it currently only contains a Crux HTTP server on port 3000. And I start this node using the Clojure CLI tooling. Now that we have a node running, we can begin to send it requests. I'm going to send a request to the status endpoint asking for JSON back. And as you can see, we get a JSON document with some status information about the node. Now we can begin to start sending and requesting some data from the node. I'm going to send a set of documents. As you can see, they contain a first name, a last name, and an age. These documents are now sent successfully, and we get some transaction information back from Crux. Now we submit a query. As you may notice, the query is still in Eden, but we're asking for JSON back out. It's a simple query, and we're just looking for all of the documents whose age is above 40. And we get a set of documents back. Alongside the JSON changes, we added a few new functions to the HTTP server that were on the main API. This included some monitoring functions. So I'm going to have a look at the recent queries in JSON. And we can see some information about the last query that we just ran. Finally, we're going to get some information back about a particular entity. In this case, I'm going to have a look at Ivan and have a look at the history of Ivan. As you can see, only one thing is returned because there's only one piece of history for Ivan, but we get some information about that transaction alongside the document. So I hope that was useful. If you'd like to see more that you can do with the JSON API, please check out the docs and let us know if you have any questions. Thank you.
Hi, I'm Jeremy Taylor. I look after Crux from a product and community perspective, and I'd like to share a few stories from the community about molding and extending Crux to suit different environments. First up is this very unexpected yet very welcome Rust client for our HTTP endpoints by Julia and Ottavio. Of course, getting this to work first required them to get Eden RS off the ground. Impressive stuff. And if that wasn't enough, Julia also wrote up a similar client and Eden library for Elixir. Meanwhile, Severe Overflow has been busy concocting a Redis-backed transaction log and document store for when low latency is critical and RAM is lying spare. But perhaps most interesting is my conversation with Mitchell Kuipers a few days ago. He works for Avisi, a large development organization based in the Netherlands, where he heads up a product engineering team. They are one of our earliest and keenest users, owing to their love of using Datalog to accommodate their diverse schema.
So we are building Atlas CRM, and it's basically a CRM inside of Atlassian products. So we try to be the most integrated CRM inside of Jira, Confluence, etc. So you don't need another CRM system. With Crux, we have been running it for more than a year on server and data center. So that's the versions that customers host themselves. And we're currently in the process of moving to Crux on our cloud product. On the on-premise products of Atlassian, so for Jira and Confluence, if you host it yourself, you can install our plugin by installing a jar file. And that jar file gets deployed in an OCI container. And that has some really unique features. So it can do class loading at runtime and stuff like that. But it also has some issues. And one of the issues we ran into is that RocksDB or LMDB uses a C. It uses some native binaries. And if you reload our plugin, it will try to redeploy that native binary and it just breaks down. It's just not workable on OCI, unfortunately. And we also ran into that to get to a database or somewhere where you can store a transaction log, we have to use a layer that Atlassian has created. So for the key value store, where you normally would use a RocksDB, we changed it to a full Java-based solution called Exodus from JetBrains. And for the transaction log, we created our own active objects implementation that's basically to conform to the abstraction layer that you get from Atlassian to integrate.
My name is Håkan Råberg, and I work with John on and off since 2005, and I also worked on Crux since the start. And during the early months of Crux, it was mainly written by myself and John. I was responsible for the initial architecture, which has now evolved into where Crux is today by James's team. These days, my role is to look at the future technical direction. So I spend most of my time reading papers, looking at various techniques that we can potentially use in Crux. These ideas are fed back into the team via discussions and occasional PRs. I also participate in the day-to-day architectural engineering discussions when needed, and I also code. Currently, I'm investigating 3 main areas for the future of Crux. The first idea is to move Crux towards an append-only column store architecture. This will make the raw data stored in Crux accessible in open formats like Arrow. We also want to remove the assumptions about which index structures are needed up front. The idea is instead to rely on adaptive indexing tuned to different use cases at each node. The second idea is to separate storage from compute. By moving to these static columnar chunks, which we can store elsewhere, like in S3, we will avoid the need to keep all the data at each node all the time. This will make Crux much more elastic. It will also allow us to deal with data which cannot fit on a single node. Finally, there's of course temporality. Currently, Crux answers questions like, last year, what was my salary? Which usually referred to as a time slice or point-in-time query. But we want to unlock the full bitemporal power of data we store inside Crux and allow for temporal queries across ranges, joins, and intervals. This will allow for queries like, when was my salary at a certain level? Or what salary did I have in my previous role? This is related to the columnar and separating store from compute, as this will require new, different ways of accessing the underlying data in efficient ways.
Hello. Types and schemas and tables and structures, these are the things that we build patterns on, patterns that we observe in the real world, patterns that we build our organizational knowledge upon. So if patterns encode organizational knowledge, why is Crux schemaless? Well, because the right schema for your application might not be the right schema for another application that's sharing the same data. Schemas are contextual. But still, in the future, we want to let you add schemas to Crux. So not just one schema, but potentially many. And not just one schema for all time, but the ability to evolve your schema as your understanding of your domain changes and as your requirements change. Not just one schema, but schemas evolving across the timeline. I really love this aspect of Crux. It's just like Clojure, that everything will be modeled as a succession of values across time. So we've been hard at work in our hammock and thinking about what it means to truly unbundle schema from the database. So with schema, we'll be able to add more ways of accessing data in Crux. We have SQL now, but soon we'll have GraphQL and OpenAPI in the future. So stay tuned, and we've got lots of announcements coming next year.
Thanks for watching this talk on Crux, the past, the present and the future from all of the Crux team at Juxt. We hope you enjoyed it. You can get more information on Crux at opencrux.com. We'll be around for some Q&A following on from this session at Reclojure, and we hope you enjoy the rest of the conference.
All right, we are back live. Hope you enjoyed the presentation of Crux from the Juxters, all the Juxters. We are going to prepare for the next talk in a minute. The next talk is Jonathan Hellman. He's going to present about the way they are interacting with Kafka and like a design. The client that they designed to interact with Kafka, called K2. So bear with us for like another 2 or 3 minutes, and we'll start with the next talk.
Hello, everyone.
Okay, we are ready to roll with the next talk. Just remembering everyone that the related channels on Discord are open for questions. We are going to collect them, and if you don't want to make them yourself to the speakers during the panel, after the next talk, we can relay some of them in your behalf. So we're ready with the next talk, the Kafka client we deserve, Jonathan Hellen. So I'm going to screen share it in a second, and hope you enjoy this talk and the next ones.
Hello, everyone. This talk is about Ketu, a Kafka client we wrote in AppsFlyer. We'll talk about why and how it was implemented. I'm Jonathan, a platform engineer at AppsFlyer, and I work in the real-time infrastructure team, where we are responsible for production systems such as Aerospike and Apache Kafka. And I'm also part of the AppsFlyer Clojure community, where Ketu was incubated, and Clojure is my favorite language. In this talk, we're going to do a quick intro to Kafka and the AppsFlyer use case. I'll speak about our guidelines when approaching the creation of a Kafka client, and I'll present Ketu, the resulting client itself, its key features. And lastly, I will discuss some design and implementation choices which you might run into in other contexts. So just to illustrate the mechanics of what we're dealing with, you can picture Kafka as this ordered log of messages going left to right. These messages are actually called records, but I'll use both terms interchangeably. Each record has a numbered position on the log, also known as offset, and when you produce records into Kafka, you append them after that last offset. And so they get their own incremented offset. Of course, Kafka cluster contains multiple logs. These are called partitions, and they contain different data and offsets, which allows Kafka to distribute them and allows us as users to process them in parallel. Partitions are grouped into topics. Each topic has a unique name and will ideally contain messages of the same type. Dealing with a topic instead of individual partitions makes our lives easier, while Kafka does the heavy lifting of distribution and coordination for us. Since we can deal with multiple partitions in parallel, producers which are writing to Kafka can distribute their data and communication. And the same goes for consumers, which read the data. They do it independently of producers, and they do it independently of each other. Let's zoom in on how a consumer works. The bicycle rider represents a consuming service, reading messages from left to right, and doing some processing, then putting results into storage. It keeps consuming and consuming, and from time to time, it will commit the offsets, those that it already processed. Meaning, it actually tells Kafka the latest position in the log that it doesn't want to see again in case it restarts for any reason. And let's see it happening. It goes on and on consuming until suddenly it fails horribly. But Kafka remembers the last committed offset, which allows the consumer to restart at that position. Any of the uncommitted work done by the consumer service might be duplicated at this point, which is part of what we call at least once semantics. If we zoom out, we can see the architecture with Kafka at the center. AppsFlyer is a mobile attribution and analytics platform, and we basically match between ads and the resulting installation of apps on mobile devices. And we need to provide tools to analyze ad campaigns. So each of these boxes represent dozens of services that serves this function. For example, on the upper part, we have our web handlers listening to events from all those devices, and then they produce them into Kafka for further ingestion. Some services just produce into Kafka, like those web handlers. Some will consume messages from Kafka and then push them to other systems. And some will do both. They will consume from Kafka, do some kind of processing, and produce back into Kafka. So we have these services, hundreds of them. They implement basically the same thing. We have duplication and a lot of copy-paste that diverged over time. Configurations were inconsistent. Small things like callbacks and error handling were done a bit differently over time. And we still used an old client and Kafka version. So we wanted to make a big deal out of upgrading both the Kafka clients and brokers together. This called for a library. We had our own thin wrapper already, but it wasn't enough. So we surveyed and studied a bunch of open source libraries and frameworks, as many as we could find. And what we've seen, together with our own experience and usage patterns and industry standards, we saw these repeating essentials that we'd like to have. And whichever library we choose should provide these essentials. First of them is what's known as a source. It is basically a loop that endlessly consumes messages from Kafka and provides these messages for you to process in a continuous manner. Then, in the other direction, there is a sink. It's a producer loop, which you continuously provide with messages, and it will eventually write them into Kafka for as long as it runs. We want consuming, producing, and the processing in between to run concurrently. Obviously, consuming a message will happen before processing that same message and producing a result, but these three processes shouldn't necessarily wait for each other in each individual message, as you can see on the synchronous process on the left. This concurrency requires back pressure. The synchronous process on the left will naturally defer the next operation while the current one is executing, but concurrent processes will have to coordinate somehow, so that slowness downstream will propagate upstream. You can see on the right, if producing to Kafka is slow, there is no point processing messages at full speed. As a consequence, we'd also like to back off consuming from Kafka. Of course, something always fails, but it's not always obvious when it failed or how to handle the situation. What do you do when the consumer throws an exception or when the producer indicates a failure 20 seconds after an async operation started? We need the correct choices implemented and expose them as a consistent API. So our guiding principles for any library we might choose are some ideals and constraints we have as user base on top of these essentials, and they will steer us in the direction of the eventual product. So first and foremost is high throughput. This is our prime directive. We're dealing with mass processing of events, which I've included the numbers previously. So if it's Not a high throughput use case. It has less of a priority for us at this time, and it might even interfere. High throughput requires minimizing interference while processing messages. Unfortunately, features are interference. So any feature that can be optional is optional. Things like data transformations, results handling, serialization, any extra behaviors, these all should be optional. We are embracing channels as an API and specifically core async. This is our opinionated part, and it brings with it a specific execution model. You can still decide not to use core async, of course, but it would leave you with the bare essentials and without streaming behavior. In addition, we already use channels everywhere in AppsFlyer, so this choice will maximize adoption. And because nuances and bugs in core async affect external behavior, those become part of the expected, of what is expected and we rely on, and part of our API. So until we learn more, we will not put core async behind an abstraction, and we will not pretend to be able to replace it. We also embrace the Java client, Kafka client, and we don't hide this implementation detail at all. We'd like to configure this client the same way you would in Java code. And that way, prior experience with the Java API, which is very common, is still relevant. Of course, we get all the improvements and bug fixes it gets from Confluent over time. Metrics and third-party integrations are still relevant. And existing documentation is relevant, which saves us a lot of time. The other side of that coin is that we don't re-implement these things. We don't re-implement core async, and we don't re-implement Kafka delivery semantics. Core async has its known behavior and nuances, which users expect and rely on. And of course, we don't want channels with the do networking, for example, as this will be misleading and against the language of the system and all that. And regarding Kafka, it already has known delivery semantics, like at least once, retries, how it does timeouts, etc. We don't want to introduce things like manual retries or writing to local disk and only then sending to Kafka. It changes semantics, more things can fail, and it complicates the performance model when you want to debug your service. So we surveyed all these libraries, everything we could find at the time, and they just didn't fit our guidelines. It's not to say that they aren't any good, but only that they were not meant for us. Some of the reasons are they were wrapping a very old Java client and we wanted to upgrade. They were poorly maintained or totally abandoned. Some of them declared themselves as not production ready. Some have like other libraries as dependencies, which could be optional, like JSON serialization. We don't necessarily need that. They had hard-coded Java to Clojure transformations, which we would like to have as optional. They had no control over channel creation, no error handling, or they were nice, but they solved a problem that we don't have. So we ended up with Ketu. Let's introduce it with some examples. They will be minimal and syntactically incorrect for presentation purposes. So please bear with me. The first thing you want to do is consume from Kafka. Suppose I have a topic full of names and I want to get and process these names. I don't want any metadata, such as offset or the time it was written, etc., only the name. And names are, of course, strings, so I want them as strings instead of the raw bytes residing in Kafka. Since we use core async, I'd like to get these strings from a channel, so I create one. And then I combine these into a consumer source that continuously provides messages into the channel. All we have left is to take items from this channel. And as you can see, we got exactly what we've asked for, a simple string of a name, Alice. On the other direction, we have exactly the same topic full of names, but this time we'd like to add new names on top of the existing ones. So the configuration is the same, the channel is another channel, but it's the same concept. But this time we will put names into the channel instead of taking from it. So I create a producer sync that continuously sends Kafka whatever I put on the channel. All is left to do is to actually put a name into the channel, and Bob will eventually find its way into Kafka. Essentially, this is it, the essence of the API. This is exactly the point of using core async. We just take and put things on channels. But even this minimal API raises many issues and dilemmas, which I will show later. Let's first see another key feature of Ketu, which is shapes. Let's take, for example, the consumer record object, which we get from the Java client. It has the actual record value and some metadata fields, but it's not necessarily what we want to get, right, from the channel. It's an ugly Java object, and we, as Clojure developers, maybe want something more palatable, like a vector or a map. If you recall, in the first example, we configured shape to be the value only. And indeed, we got a simple value field of the consumer record, which contained the name Alice. So let's focus on that, just on the shape configuration and the resulting value we get from the channel. Instead of just a value, we are not limited to a single one. We can also ask for multiple fields of this record. And in this example, we want a tuple containing the value and offset fields of the record. We use tuple to mean a vector or predefined elements. And this data-oriented style for defining the shape is inspired actually by Mali schemas, where the definition first contains the type of data structure that you want to see in the channel, and then the selected elements you want in that data structure. And you can see the result is exactly that, a vector with the name and the offset in Kafka. Similarly, a shape of map will result in a Clojure map with each selected field translated to a map entry. We can also register custom shapes that accept configuration at runtime. And in this example, we want the cake output. So we configure it with a specific mold. Cake is the name of the shape, and the mold is the parameter configuring the shape. So how it is implemented? At configuration time, Ketu will provide us with the shape parameter. And this is our chance to create a transformation function of the record once at runtime, according to these parameters. Our dynamic function will then be invoked over and over for each record we get from Kafka. We did try to avoid this amount of functional indirection and head scratching, but in this case, it was necessary. This is also how we implemented the built-in shapes, vector and map. We just register the shape with a function that returns a function. In this case, to save some overhead when constructing the data structure, we use eval to create the most direct function that we can get. So ultimately, the function just returns a vector literal or a map literal, which is the fastest option. Again, I'm sorry for the head scratching. I was hacking at it until it worked, and I don't want to look at it ever again. If you don't like any of this, you can just directly configure the shape to be a function of the record, in which case the result will, in the channel will be the result of the function applied to the record. Of course, there's the other direction of the producer, which that uses the Java object of type producer record, but it's everything I've said is applicable there as well, so we will not show it here. We have more features in progress, like managing offsets and providing very detailed results handling. But as you'll see next, each feature creates a lot of questions and things to think about. So this will take time to implement. Dilemmas are the sort of questions we ran into while implementing Ketu. You'll see that you can always dig deeper and suggest more alternatives for each decision. For example, how do we put the things we get from Kafka into the channel? We do this by we get from Kafka messages by polling for more and more messages, which we get in the form of a collection. As you see, the basic Java function is poll, which returns a collection. Earlier, though, you've seen that the channel contains individual messages, but some users might prefer the original collection that we get here for various reasons. Some of them might be performance or the way they are used to do things. So let's see how it looks. On the left side, we are polling for messages from Kafka and get a collection that we put as is into the channel. We can immediately continue to the next loop iteration and get another collection from Kafka, which we put on the channel. And then one last time, we get a third collection. And only then we run into back pressure. On the right side, we again get a collection from Kafka, but this time we iterate over the collection. We put each message individually into the collection, and the back pressure is applied when we can no longer fit more individual messages. And on the right side, it means we read from Kafka only once instead of 3 times. So depending on our decision, the channel will contain different kinds of inputs, and the user will have to process them differently. And also back pressure will mean 2 different things. Then there's also the question of the cat transducer. What is it, and should we use it for optimizations or other reasons? Cat is an expanding transducer, which means when we create a channel with cat and put a collection in the channel, the collection will spread into individual messages inside the channel. On the other hand, on the one hand, it has a performance benefit of acquiring the channel lock just once for the entire collection. Instead, on each individual message go through the barrier. But you can see on the right side, it causes the buffer size to grow and breathe, so to speak, since it also shrinks according to how the user interacts with the channel. This changes back pressure semantics, and also while we were internally discussing it, there was still a bug in core async that made the buffer grow endlessly. So it's not like everything is perfect all the time. You have to read the source code of everything you use, and it's not that simple. Going back to the shape feature, this is another dilemma. The shape option is a function of a single record, as I've explained before. But now we are talking about putting whole collections as is into the channel. So will the shape be a function of the whole collection? How will it play with the transducers? We will probably eventually enable all of the options and let users compose them as they will. Another dilemma was how to handle graceful shutdown. Let's talk about it as defensive programming. We have seen before that the consumer source puts messages into the channel until the buffer is full. Once it's full, we have a pending put, waiting for the user on the other side to take from the channel and relieve some of the back pressure so we can take more and more messages from Kafka. Now suppose the user wants to shut down the service completely. A well-behaving user will first close the consumer source, let it finish consuming, and then drain the channel from inputs. This will release the consumer that was previously stuck on pending put operation and will allow the consumer to close itself gracefully. However, if the user is misbehaving and first stops processing this channel and then tries to close the consumer source, nobody will drain the channel and the consumer will be stuck forever. One way of avoiding this is to use alts with a dedicated release channel. And when the user closes the consumer, we will release the operation ourselves instead of being stuck. And there's more than one way of doing this. We don't have to use alts, perhaps. And there are performance issues to consider with alts because it is much slower than a direct put operation. All of these dilemmas are relevant to this single tiny line of code. And it was very humbling to see how the amount of options just explode on each decision points. Another question was whether we want unqualified or fully qualified namespace keywords. We went for mostly unnamespace keywords. Frankly, it looks better also in JSON, which we use for configuration. It's very minimalistic, and it isn't actually that bad, as bad as you might think. We have more and more dilemmas, a lot of them. I will not go into them right now. And this is a good point to acknowledge all the inspirational libraries and all the alternatives out there. And of course, to thank Clojure itself, Apache Kafka itself, and my employer AppsFlyer for giving me the time to work on Ketu. Thank you very much. Don't forget to check out Ketu on GitHub, and you can always reach out on Twitter or Clojurians. Thank you.
All right, thank you very much, Jonathan. We are preparing for the first of our panels today. So I think we can start it as soon as I know that we are all ready. So I've been monitoring the two Discord channels related to the talks, and I've seen both speakers very active there and replying straight away. Maybe worth noticing that Jonathan just released Ketu, if I'm not wrong. Yay! So it's kind of going live as we speak, and you can access it on GitHub on that link that was presented before. I mean, if the link is, you cannot see the link now, but you can go on the Discord channel to see the link or search it. So let's see. Is John available as well?
Yep.
Okay, cool. I can see Jeremy, I can see John, I can see Jonathan. All right. So yeah. So let's try to kick off the first Q&A panel. So as I explained to some of you while we were discussing like before the conference, I think we have this unique opportunity by doing like a virtual conference to see a little bit of, the personal part of a speaker. We normally see them on a stage, very dry, if you want. The slides are there, so it's nice. But this time we're going to see them maybe in their room, in the kitchen, or in their studios, wherever they are. So that's, I think it's like a great question to start with, just for like the three of you, is to ask, we see your surroundings, but is there anything like interesting or curious, some objects or something interesting around you that you want to show us and to share with us? We can see already something, so maybe there's no need of like turning your monitor or like turning your camera anyway. So let's start from John, who was like the previous speaker.
Me as opposed, yeah. Yes, I guess I have a telescope in the background, which Renzo, you've been threatening to come over for the last year, so we can have like a astronomy night. So it's waiting for you.
Very nice. Very nice piece of equipment. Yeah, looking forward for the next blue sky. It's going to take probably another 2 months, but
Yeah,
we'll try. All right. What about you, Jeremy? Anything behind you that is worth sharing?
Well, yeah, someone spotted it on the chat. So this thing behind me is actually covering up a fuse box. I just needed something to put behind my desk to make the wall a bit more pretty. But it's actually a calendar from Kazakh, which is like this awesome YouTube channel. And the actual calendar is showing like 12,000 years of human history, which is a really good model for valid time. So a good way of explaining bitemporality and how, as we learn more about history, we can update the past and add more pictures. Anyway, yeah, I get a lot of
very nice
about it. Thank you.
Jonathan, I saw a cat. We need to know about the cat now.
The what?
The cat? Oh, there was a cat before. It was your background.
Yeah, that's the
I see.
Epspire standard background.
Oh, anything interesting? Cycling a lot?
No, that's been there for a year like this. Maybe I can show you my Iron Man Iki. That's for pair programming and stuff like that. He's saying, don't do this, don't add this feature. Yeah,
nice. No, that's more than enough. While we're doing this chit chat, I'm gonna ask people on Zoom. Now I lost again the list of the participant to raise their hands if they want to make a live question. We are going to unmute them with the help of the other moderators as well. So is there any raised hands? If there is not, I have a question for our guests. So, all right, I don't see one, but let me know if it's because, yeah, I don't see them. So there's one question for you. So what about the 4 letters names? Did you agree on both projects, or it's just a coincidence?
Well, from a Jux perspective, we always use 4-letter names where possible. It's one of those unwritten rules. Nothing slips out without 4 letters.
And Jonathan, it's coincidence.
Total coincidence. Yeah, we usually use names that ends with Clojure or something like that. Some kind of pun on Clojure.
Okay, so I have a question on Discord that I'm going to send now there. I see a raised hand, so I'll write there. So for Juxt, what are the small scale choices for using Juxt in 100% pure Java?
So what are they? So if you don't want to use rocks or LMDB, so Mitchell in that video mentioned Exodus. So we actually linked to it on our docs. So he wrote it, and we'd be happy to help support people trying to use it. I can post a link to that. So this is this JetBrains key value store, and you can use that for the transaction log, document store, and the indexes.
Thank you. Hope that answered the question. So I have Edward. I'm going to ask to unmute and see if that works.
Can you hear me?
Yes, all good, Edward.
Okay, good. So I had a question for the Jux team about Crux. And this one's more, I guess, about adoption, because you guys are aiming towards the same sort of niche that Datomic was back when it first came out. And Datomic has sort of always had a problem with widespread adoption, and I was wondering if you guys had any sort of reflection on sort of how Crux is doing in that regard.
Yeah, I'll take that. So I guess it's fair to say that, yeah, I mean, more than other databases, Crux looks like Datomic, and we've certainly drawn a lot of inspiration from all that amazing work. But arguably, we're chasing like a different kind of niche. Like from what I'm aware, Datomic is unlikely to ever sort of go down the bitemporal angle, and we've really rethought the whole index structure in light of this temporal query capability. So it is a different niche, but I think we are very keen to move beyond like a Clojure bubble. Like obviously we love Clojure, and we're always going to write Crux in Clojure as a by default. Maybe we'll drop down into Rust if we really need performance at some point. But to like push beyond that, that's why we added JSON support. So like people don't have to think about Clojure or even the JVM in order to benefit from Crux or like have to wrangle with Eden. And we added SQL support in the summer as well, so that places that like aren't ready to learn about data log can still benefit from like a bitemporal model, and they can run SQL queries at a point in time. And that's quite unlike any other SQL like relational database that's out there at the moment. So we're hoping we can strike the right balance between like niche capabilities and like APIs that allow for broad adoption.
Yeah, if I could just add to that as well. Yeah, Crux is also like a document store as well. So Datomic's more like a triple store. So we've made quite different choices, and that has some ramifications and some decisions for the users to make. But we're sort of following the Mongo Elasticsearch route, where you just smash in a document and then Crux can figure it out afterwards. And hence Crux is also schemaless. So rightly or wrongly, we're sort of making those choices because we hope that will broaden out the appeal, especially when you go beyond like the Clojure scene, which Jeremy says we love Clojure. But when you go beyond, it's like having JSON maps and being able to store those maps and make sense of them in a sort of temporal way. We hope that that will get some wider appeal. And we're doing quite a lot of work on the API front. So the Java API, we've got people using it from Kotlin and some .NET users somewhere. And as we do more and more work like Dan has done on the JSON API, then we hope that anyone can use it, JavaScript users. So that's our sort of future. And we're quite excited. Like Crux right now is definitely a bitemporal database. And as Håkan was saying, you've got those point in time bitemporal queries. So you can use business time to query against. But we're kind of excited about what you can do in that direction. So instead of saying, what was my salary in 2015, you could say, when was my salary X? And answer those kind of questions. And then we'll start to appeal to a different sort of cache of people out there that are interested in temporal databases. So I guess that's our long-term plan for accessibility.
Right, I'm going to pull a couple of questions for Ketu as well. They're coming on the Discord channel. Is there a timeline forecasted in regards to production of Ketu, or is it Ketu in production already?
Internally in AppsFlyer, it's in production already for several months. Our use case is very basic. We just consume a lot of messages and produce a lot of messages. So it worked well. Teams that care about performance also approved it in a sense. And just today, I cleaned up everything that's related to AppsFlyer and put only the core stuff on GitHub. So there shouldn't be a difference. You could say it's production ready, except the next question that you're going to ask.
Okay, let's sequel that. I like the idea. I'm reading. I like the idea of hiding the Kafka semantics behind CoreSync, but I can't seem to find how to explicitly commit offsets. If auto commit is true and the channel is large, one failing consumers might lose messages.
Yeah. So this is what I like to call, instead of at least once that Kafka likes to say, I like to call it at least never, because you have a channel, which is a buffer, and the consumer doesn't care what you do with it. From its point of view, it was successful at the minute it put it on the buffer. And then actually the problem is when the consumer is successful and you are not successful processing the messages. So the consumer does another iteration and another iteration, and meanwhile it auto commits the offsets that it just put in memory on the buffer, and then you fail without taking from the buffer or whenever, and you will never see these messages again. So committing asynchronously is not an easy problem to handle. So it's not that hard. It's like a medium medium hard problem, and it's in the works. We can also take inspiration from the new library by actually by Confluent, which is like this experimental parallel consumer that they are working on. And they handle offsets in a way that we thought of doing several months ago, but never had the time. So we might just take that and adapt it into Clojure or something like that.
Okay, another question for Crux is related again to scalability, but in the large, is how scalable is Crux, the platform, and what are the limitations?
So assuming you're using RocksDB as your KV store, like we've seen personally, like firsthand RocksDB instances up to like 2 or 3 terabytes quite comfortably. I've seen anecdotal, Googling around, people having a RocksDB single instance at like 15, 20 terabytes. So as long as you have enough SSD behind it, that can be done. And then when we benchmark query performance versus like the size of the RocksDB instance, like if you're looking for a fixed set of data in RocksDB, the growth is like sublinear. So a query running against 100 gigs of data versus 10 terabytes of data, it should only be maybe 5 or 10% slower, just because Rocks has to do a little bit of extra work to do that seeking. But in general, yeah, we're very much tied to the performance of the KV store, and Rocks is generally the best trade-off. Although LMDB can be faster, it just is a bit slower to ingest. But yeah, the trade-off with these things is that those indexes have to be local to the node. So your node has to have a full fat index of all the data. So if you're spinning up a new node, you're going to have to take a snapshot and replay the delta in between in order to come online. So there's like a limitation in terms of horizontal scaling. We've also spiked out, you can use Redis as a KV store. But that's obviously a more expensive way of holding your indexes. And as Håkan mentioned in that video, we're looking deeply into this adaptive indexing approach, which would mean that the data doesn't have to reside so close to the node.
And sequel to that, maybe how is it going with sharding? There was a story that it was, at least in the past, required all the data to fit in a single node. Is that still the case?
Yeah, so that's basically still the case. It's the same point, I guess, as I was just making, which is that when a node is reading from the transaction log and the document store, it has to index all of the content in there. So let's say you have 10 gigabytes worth of documents and a gigabyte's worth of transaction log data. Your index is going to be a few gigabytes. It's not going to be the whole thing, because actually we can retrieve values and cache them from the documents. So the index is always like a small subset of the overall data size. And of course, RocksDB itself implements compression. But certainly, if you have a node size of up to a terabyte, you're not really going to think too much about the production implications of that unless you're having to horizontally scale a lot. But yeah, in future, we'd like to reduce that reliance on having all the indexes be at all be present for the nodes for every single node instance. And then there's another aspect, which is the transaction log, which ultimately, someone's mentioned Datomic already. Like Datomic, it has that upper limit of throughput ordering. How fast can you write to a single log at its head? And Kafka can certainly scale quite well for a single partition. So you can probably quite comfortably get several thousand inserts into the database. RocksDB will struggle to keep up with that at some point. So actually the bottleneck there is on RocksDB. So some people will still want to shard their data model across multiple instances of Crux.
Thank you, Jeremy. I have another question for Ketu. So the question is, has been any testing been done on the throughput, and how many messages can it handle per second?
Yeah, so in our use case, we have very large messages. I mean, not that large, but 10K bytes messages, which is too much. It's like a big JSON. So counting messages is a bit unfair. We reached 70,000 per second at some point, but We pretty much max out the network cards, so it's not a problem, I guess. Unless you are pushing integers, one integer per message, and then you might get into some bottleneck elsewhere. But we didn't check that yet.
Another question for Crux. So Crux is document oriented, but it can still present triplet facade. Has there been any thought introducing a SparkQL API?
So I've, as you're reading that out, I just posted a link to Sparkle CLJ namespace that's in the Crux repository, which we actually use for testing Sparkle benchmarking test suites. So when we were developing the query engine, rather than sort of relying on our own imagined tests, we took some off-the-shelf Sparkle RDF benchmarking, like graph stress tests, so that they sort of really like have massive graphs, and you're looking for these sort of sub-matching patterns. And so we use that Sparkle endpoint to do that. It doesn't implement the whole Sparkle spec, but certainly, you know, the similarities between Sparkle and Datalog mean that it's possible. It's not been a priority, and I don't think the market for Sparkle is like obviously huge, that we're going to prioritize in the near future. We're much more likely to get GraphQL as a first-class thing before Sparkle, but it's certainly interesting, and we'd like to talk to anyone that's interested in it.
Thank you. I have a more business-oriented question for the Crux crew. No, the normal business trajectory seems to be that, you know, when you create a database, you then are being bought by a Brazilian bank. How do you balance the interest of like paying customers with the open source aims, and what are those open source aims?
I think it's definitely we always want to be open. I think that openness is one of the values of the project. So it's open source. We try and have discussions in the open. We try and be open about it, and we're open to pull requests and people looking at the code, etc. So we always want it to be open source. We genuinely sort of believe that you know, I think Juxt and Crux are going fairly strong, but like, you know, who knows what the future can tell, and like the fact it's open source should give people some reassurance. Sorry, that's my dog in the background going crazy for some delivery. So I just say about the business side of it. Yeah, we want people to use Crux. We do provide enterprise support and also consulting. So we think there's a good sort of revenue mix that should allow us to sort of prosper and be okay commercially, whilst at the same time keeping it open, and anyone that wants to use Crux can use it.
Great. So for the moment, I think we exhausted the list of questions. So I'm asking one more time if there is any hands I didn't see before, if you can raise it again and you can ask your question. If not, if there is no other question, I'll wait like for like a minute or two. Then we can have a slightly longer break in between the, like waiting for the next talk, or we can have any comments that our speakers would like to add to their talk, or any resources or any links or anything that may be useful for the audience. They can post it, of course, on the chat. But if you have any, yeah, you can go ahead. I don't see any other ping. So if there is anything else you want to add, please do it. Comfortable silence it is. So thanks very much for for your talk and your effort you put into it. And we'll be back in about 10 minutes to continue with the rest of the schedule. Thank you very much, everyone.
Thank you.
Bye-bye.
Bye.
Hi, good evening.
All right, I'm reclaiming the slide and about to start with the next talk. So next up we have Tien Zoller. He's going to talk about way of testing based on a Docker containerization. And here we go. I'm going to stop the blathering and start the talk. Oh, and in the meanwhile, just we are looking for finding a nice timer clock to put on the slide. So if we have any other time for waiting, you know when the next talk is due. So keep that in mind.
Hi, good evening and hello to my talk about CLJ test containers here on Reclojure 2020. First up front, thank you very, very much for having me. I am really happy to be here and to be able to talk to you. And yeah, let's just jump right in. So the title of the talk is Dockerize integration tests with test containers. And before I get into that topic, I just want to spend one tiny little minute to talk about myself. So who am I to be here and talk to you this evening? My name is Tim. I'm from Freiburg in Germany. I'm working with the JVM for more than 12 years now. I have been an IT consultant for the last 7 years. I'm the co-founder of the Java user group in Mainz. And recently, I'm the founder of the company Lambda Schmiede GmbH here in Freiburg. So from January on, I'm self-employed and I'm really, really looking forward to that. And what's more about me to say is I like playing guitar, running, often with my dog, and my other hobby is coffee. And you can find 2 links here. On the left side, there's a QR code leading to my Twitter account, and on the right side is the QR code leading to my personal website and blog. Okay. So, what is the problem with integration tests? Why do we need to solve issues with integration tests? We have been doing integration tests for years now, and everything worked fine, didn't it? And I believe that's only partially true. Because the big issue I'm having with integration tests, and many other people are having, is they depend on the things you want to integrate. So of course, if you want to test integration of a database, of a message queue, you need an instance of that service running wherever you're running your tests. So you need an instance of any of these. It can be something assumed simple, like a database, MySQL, Postgres. It can be a message queue like RabbitMQ or a streaming broker like Kafka. It can be a cache like Redis, or it can get even more complicated and you need to test integration of OAuth flows with, for example, Keycloak. And so wherever your integration tests run, you need access to those services. And where do your integration tests run? They run on the local Windows or local Mac or local Linux machines of your developers. They run maybe on your Linux build pipeline you have set up anywhere and maintain yourself. Or they're running in the cloud, GitLab, CircleCI, Travis CI, or GitHub Actions. And so I assume that you want your developers, or you as a developer want to be able to run integration tests locally. So you need a local Oracle database. You need to install it on your machine, and it needs to have the same parameters as all the other developers on all their machines. And maybe you can type line test to start a test run. And then your application connects to the database. And maybe you have a very sophisticated cleanup job. And after the tests are run, you have to clean the database again or beforehand. And then your database model changes and you need to set up your local database again. But maybe last time your tests crashed and now everything is in a kind of strange state and you need to delete the database manually again. And yeah, that's a lot of hassle. And everything we're talking about here is only the simple use case databases. So I believe the fun begins if you need to set up Kafka or even a Keycloak locally, everything on your machine. And this is no easy task. And luckily for us, some years ago, some people were bothered by these facts, and they introduced test containers. Test containers is a Java library that supports JUnit tests, providing lightweight, throwaway instances of common databases, Selenium web browsers, or anything else that can run in a Docker container. So it is a Java library. It has 4,400 stars on GitHub now, over 80 releases, and is active since 2015. And this library has picked up a lot of traction lately. So many of the bigger frameworks started using test containers for their integration tests. You can find it if you're familiar with the Java world. You can find it in Spring Boot now, in Spring. So they are testing their data integrations with test containers. And it is really a great way to Dockerize all the services you depend on. So you Dockerize your Oracle database, your Postgres database, your Kafka broker, your Redis cache, everything that you can run in Docker can be Dockerized with that. And of course, you were able to Dockerize these services beforehand. So if you wanted these services to exist on the developer machines, you could always create Docker images for that. So write the files, Docker files manually, distribute them to the developers, and start them in your tests. But what is really great about test containers is that you don't have to do that. You can just define these containers as code. So before we dive into how to use them with Clojure, I want to show you how to create a test container with Java code. So you would put this into your integration test. And this example creates a Docker image with Postgres. So you are creating an instance of generic container with the Docker image Postgres and the label 12.2. You tell the Docker image container to expose the port 5432, which is the default port for Docker, for Postgres. You assign an environment variable Postgres password, which sets the password for the Postgres DB in the container. And then you start the container. And then you can get the container host and the container port from the resulting instance and use them to connect to a database and run your test code. First, there are two things that might seem strange first. So the host, why can't we just use localhost? Because it is not, we are not sure that the Docker host is our machine. We could connect to a remote Docker host, which will come handy in a build pipeline. So we connect from our machine but the machine executing and running Docker is somewhere else. So in our case, when I run it on my local machine, get hostname always returns localhost, but on a Circle CI pipeline, it might not. Also, get mapped port. We already told test containers that we want to expose the port 5432. Why can't we just use that? Because this is not how Docker is supposed to work. Test containers lets Docker assign a random port from your local machine to the port 5432 from the test containers instance. This makes sure that we don't have port collisions. And this is already a great advantage over running the Docker images or even installing Postgres on your local machine yourself, because you can create 20 Postgres instances in parallel in your tests, and each of them will get assigned a different port. And so you can parallelize your tests to the limit of your RAM and your machine's capabilities. So this is why we need to retrieve the host name and the port from the instance of generic container. And yeah, this helps us a lot already. So I believe you can start to see now, already see what advantages test containers bring us. And it gets even handier. So test containers offers a lot of pre-built containers. In this example, it's the PostgreSQL container. And you see that we now get methods with database name, with username, and with password, because the PostgreSQL container knows that it needs those to start. And even better, once we have started these instances, we can say postgres.getJDBC URL and get the formatted JDBC string to connect to that instance. And this is pretty neat. These specialized containers don't come along the default test containers library. Each of those is a unique library you need to pull into your class path. That's important to remember for the Clojure integration later. Okay, we have seen two simple examples on how to use PostgreSQL in Java and how can we use this in Clojure. So as it is a Java library, obviously, we can use Java interop. So in this case, we can use a threading macro. We create a new instance of generic container, again, with the image name Postgres and the label 12.2. We tell test containers to expose the port 5432. And we set the environment variable and the password again. And then we start the container in a separate command. It's a new line of code. We start the container. And then we can connect to the DB and again retrieve the host name and the map port from the container. So this doesn't look too bad, right? Because test containers likes to use a builder API, a Fluent API, so we can use the thread macro. And this is already readable pretty good. So why do we need a Clojure wrapper? Can't we just use that? And indeed, there are good reasons to just use the Java library and not use the Clojure wrapper, because you will always have access to the latest test containers version. You will not have to wait for the maintainers of the Clojure wrapper to update. And there's already lots of documentation on how to use the Java API, which you can adapt for yourself. On the other hand, this is not very Clojure-y. For example, the start method returns void, and there are a lot of methods on the container that return void. So we can not use the thread macro everywhere. As you see here, start is a separate command. And start mutates the container that we have in the let without returning anything. So that's not very Clojure-y. Also, we need to convert data types. You see it here again with exposed ports, accepts only an array of integer. There might be a more clever way to do that, but you can't just hand in a vector of integers. That doesn't work. And of course, you are having an instance of a Java object that you need to handle. So if you want to work with that, it's always Java interop. So I need test containers for a Clojure project I'm working on. And after some times, I got a little tired of the Java interop. So I decided, why not try and create a small wrapper? And this is what CLJ test containers is. It's a lightweight wrapper around the test containers Java library. It has only 32 stars on GitHub, not 4,400. Only 3 releases, and it's only active since 6 months. So it's a very small project, and yeah, it's just a wrapper. I am in contact with the maintainers of test containers itself, and talk to them about a Clojure integration. There is an official wrapper for Scala. And this official wrapper for Scala is the reason why there won't be an official wrapper for Clojure. Because they ran into a lot of problems maintaining a wrapper for a different language. And they decided they do not want to do that and just recommend Java interop. So this library is unofficial. So let's see how to use the library. We have imported, required everything as TC. So with TC create, we pass a map with an image name, the exposed ports, and a map of environment variables. And then we call start with an exclamation mark, because start mutates state. It creates a Docker instance in the background. And this is definitely not side effect free. And then the create and the start functions return a map with all the important attributes of the Docker container mapped. So we can access the key host, and there's also a mapped ports, and we can get the port that is mapped to 5432, and again connect to EDB in our test. That's a really simple example. So yeah, it's time for some more advanced examples. This is a more complex container. And here we create a container from the image Alpine 3.2. So it's just Linux with nothing installed. We expose the port 80 and set an environment variable magic number 42. Then we add this container to a network, which is somehow created with the function called create network. And we assign an alias to that. So in this network, this image container, is known as API server. Then we add a wait strategy, which is called strategy health. So before we do anything, after starting this container, we are waiting for the container to report itself healthy. There are defined health checks in Docker, and the start function will block until the container is calling itself healthy. So if there is some initialization, we can avoid running into race conditions. And we execute a command on startup. We start a shell with a command while true, do echo magic number on port 80. So if we start this image and it has passed the health check, and we perform an HTTP GET on port 80, we will receive 42. And this is something we could test in an integration test. Another example would be mapping a class path resource from your Clojure project into the container. So there's again a function which mutates state of the container. And we pass in a resource path, test SQL, a container path, opt test SQL. And upon creation, we will map the resource from our class path to /opt/test_SQL. This could be used to set up a database schema in Postgres, for example. And we specify a mode. This is read-only, so the container is not able to manipulate that file. Another way to add a file to your container is to bind a path from your file system to the container. So this would map everything from the working directory I'm running the application from into /opt, also read-only. And this can make sense, but remember in the beginning when I said that we want the tests to behave equally on all environments. So I would prefer mapping a class path resource into the container every time, because this will behave the same way on all the environments, and mapping something from the local file system might not. This is just a small warning. So how to write tests? How do we integrate test containers in our Clojure tests? One way would be to use fixtures. So in your test namespace, you use the macro use fixtures. Once means for all the tests running in that namespace, please only execute this fixture once. This is a function with a parameter f. And then we create the test container. We start the test container. Then on the second line from the bottom, we execute f, which is all our test functions from the test namespace. And in the end, we stop the container, and this will get shut down and removed from the local machine again. So we have everything what fixtures were planned to do. We have a test setup, we have test execution, and after that, we have a cleanup and remove the Docker container again. This is kind of nice, but even better, you don't have to care about cleaning up at all. Because the test container maintainers were also thinking of what if the JVM crashes during tests, then we may have a build server, a build pipeline, or a Jenkins server, build server, which just accumulates Docker images, and they get created and created and created, but they never get removed. And this is why they made sure that when the JVM shuts down, the containers shut down too. There is a special container running in the background. It's called Ryuk. I'm not really familiar with mangas and animes, but I was told it's a reference to Death Note. And when the JVM starts spawning Docker containers, this Ryuk service starts a keep alive ping to the JVM. And as long as the JVM responds, everything is fine. Ryuk doesn't do anything. And as soon as there is no response anymore, it starts removing all the Docker containers that were created by this test run. So you could just initialize a Docker container at the head of your test namespace, or you create an additional file in your test resources that just creates the Docker image and starts the container. And after all the tests are run, the JVM is shut down, and they are shut down along with it. So what's planned for the future for CLJ test containers? Currently, we are not feature complete yet. So there are some wait strategies and some logging mechanisms that we can't use yet in the wrapper. You could use them in your tests anyway, because if we create a new container with create, in the map that is returned, there's also the key container, which just gives you access to the test container Java object. So if there is something that the library cannot do yet, but test container can, you can get to the test container object and execute all the functions and methods yourself. What I'm currently working on is to provide a better support for the REPL. Because I just said it, all the leftover test container instances get cleaned up when the JVM shuts down. The problem is that a REPL session keeps the JVM alive. So last week I was just trying to write some new integration tests in a REPL. And after some time, I realized that I had 30 PostgreSQL instances running on my Mac, which explained why it became very, very slow. So I'm currently working on a function that you just can call from the REPL, which clears all the instances and resets you to 0 again. And also, there's a task for improving the documentation. Currently, all the functions you can use are documented. We have an entry on CLJDoc, which you can access, and with a small tutorial how to use it. But I believe documentation can always be improved, and that's something which is in the making. There are some interesting links here. Don't worry, you don't have to type them all. I will share the presentation, and then you can just click on it. So on the top, obviously, the most important one is the one to our GitHub repository. The second link is to a blog entry where I write a little bit more and a little bit in more detail about the motivation behind the wrapper. And the last one is to a YouTube video where I streamed on Twitch together with Kevin Wittek, one of the maintainers of test containers, and basically showed him how the wrapper works, and he comments on it and gives some good insight into test containers. This was very fun and I liked it a lot. So we're done. Thank you for watching, and also a big thank you to the people who helped me write this library, because there are 5 to 6 maintainers already, some recurring maintainers who solved several features and suggested several features. This is again a great sign how approachable the Clojure community is, and that people just drop in and say, hi, I would like this feature, or this you could do better. May I create a pull request for that? And this is really great and really, really helpful. So thank you.
All right, thank you very much, Tim, for your presentation. So a couple of things I wanted to add is remember that if you have any questions for Tim and the presentation you just watched, please head over to the Discord channel connected to the talk and make your questions there. I will prepare your questions for later. Or if you decide to just attend the Q&A panel with Tim and the next speaker, please do so, and I can make your questions live for additional interaction. We are slightly early, but we are going from now on to try to stay with the schedule, so you know that the talk that is scheduled at some specific time is going to start at the time and not 2 minutes earlier. So apologies for that. And the other thing is we'll make sure that all microphones are switched off. Sorry, I think it was mine. So with this, I'll pause for a second the transmission, and I'll see you in 6 minutes.
Okay. Hello.
Okay, we are ready for the next talk. We have Oliver presenting the first of a few talks that we have that are somehow related or using the REPL, which is a good thing. So here we go. I'm going to start the presentation and I'll talk to you later.
Okay. Hello, everyone. My name is Oliver Caldwell, and I am a software engineer at Viasat within the Lono Cloud team. And I've been there since May this year. It's a wonderful team, mostly based in the US, so I'm working remotely for them, writing Clojure full time. And we are hiring, so if anyone's really interested, please do get in touch, and I can forward you on to the people that you need to talk to. So the goal of my talk is to basically fill in knowledge gaps across all experience levels and to show what's possible with a REPL. So I'm going to be showing tools that you might not have used and might not ever use, but hopefully it will open your eyes to certain ideas through the lens of something unfamiliar. So a little history on the tools I've used and the ways I've interacted with REPLs. I started in Vim because I love Vim and I always loved using Vim with Fireplace, which is a plugin for Clojure support and REPL interaction. Eventually I was coerced into using Spacemacs and Emacs for a couple of years and then moved back to Vim and then to NeoVim, and then I started writing my own tooling. And I've been doing that for about the past 2 years now. And I've reworked the UX and implementation of my Clojure REPL tooling probably 2 or 3 times now. It was written in Rust and then Clojure and then a Lisp that compiles into Lua and executes within NeoVim directly. And that's where I've ended up so far. So that's working really well, and I'll show you a little bit of that. And so far it's a local maximum. So I've explored the space of REPL tooling a fair bit. I've tried a lot of things. A few different extremes, and I've spent a long time working on my own ideals. And I've built up quite a few users for that, I think. Quite a few people like the UX and the way it works, but it's still quite niche. So I hope to spread some of these ideas to you today. So let's get started with what is a REPL? And I know this is very basic, but my goal is to bring something for every level of experience of Clojure developer. So somebody who's just looking into it, somebody who's been working in Clojure for full time for the last 4 years. I want everyone to be able to get something out of this. So a REPL is something that reads source code from a string, so like +1, 2, and it turns that into data. It then evaluates that data, so executes it and turns it into some result. It will then turn it back into a string and print that result, and then loop back to the beginning, ready to read more input. So REPLs deal in strings. Strings go in, strings come out. What's neat about this is that a REPL client and a REPL server can be different languages. Because the medium is strings, they don't need to be the same language. They don't need to understand each other. So this is mostly seen in the standard input or output on the command line REPL. So the standard IO REPL is pretty great for teaching because you can just get into it straight away. You can just type Clojure on the command line and you're in. You can now run code. It's really powerful. You can do anything with it, but it isn't integrated into your workflow. So in the world of a developer relying on a standard I/O REPL in your terminal, editing and evaluating are separate concepts. So your editor environment with all your powerful editing tools is completely separate to your evaluation environment. It might be embedded as a terminal within your editor, but it's not part of your text buffer where you have all of your little mappings and keybinds and whatever you want to use. So there's two different worlds you have to think about there. I know Emacs kind of blurs that line a bit. So we can actually add a bunch of dependencies to make that better. So you can add like Bruce Howman's Rebel read line, makes it much easier to understand and work with and write in. But you're still limited in some ways. It's still separate. You still end up copying and pasting things between these two things. So we can actually show a quick REPL here. So if I type COJ, there you go. We now have a Clojure REPL. Let's make that a bit bigger. And if I do +1, 2, we have a result. That gives us 3. Excellent. So this is very good for teaching people because you can just show them it straight away. The problems start to arise when we try to do something such as println hello. So you get hello and nil back there. What happens if I type hello and nil here? We get the exact same result. So 2 different inputs can lead to the same result. This isn't immediately bad. As humans, we're fine understanding this, but if you're writing a computer program or a plugin or something to understand this output, you're going to have a bad time because we are losing information. We don't know what is a standard out. We don't know what's a result. We can't tell, which is unfortunate. So we lose information. Clojure 1.10, I think, maybe 1.9 to some extent, brought us the socket REPL and PREPL. These don't require any dependencies. They're built in. A socket REPL is just the standard I/O REPL over a socket, so we can talk to this REPL remotely, but it's the same experience. We still lose information. It allows you to access remote machines or Docker containers, so we can evaluate things that aren't like within our terminal. The PREPL adds structure. And PREPL should be all lowercase from what I could find. I think Stu Halloway mentioned it on a mailing list one time, that it's always lowercase PREPL, but I can't find it again. It was on the Google group, I think. But yeah, write it however you want, but I think it's supposed to be lowercase PREPL. It's still string input, but a PREPL outputs results wrapped in Eden. And it allows us to identify whether it's standard out, standard error, a returned value, or a tap value. So you can tell what kind of result you got. So you don't lose that information anymore. It's not all string out, it's Eden out. And that's good for simple things. There's no real way to extend it. There is the unREPL, which is kind of a similar project that is, I think, a bit more extensible and kind of you inject it into a socket REPL and it upgrades that socket REPL into something that behaves a bit like a PREPL. So it adds some structure. So that's not really maintained, but there's some interesting ideas there that we might be able to take into any kind of PREPL development. So we can still learn from unREPL. So yeah, the downside is it's kind of rigid. It gives you some structure, but it doesn't give you some hooks to build upon these ideas. So there's third-party options when it comes to remote REPL execution. We have nREPL, which is the most popular one. You may have heard of this. You may not have, but you may have been using it under the hood of your editor tooling. I actually frowned upon using nREPL at first for my tooling because of some issues I came into with Vim and Fireplace where things would get out of sync and things would stop working some days after an update. And it was just kind of like some things that it was really unfortunate probably and during a time where things were moving fast and different projects couldn't keep up with each other, I think. But I eventually came around to the idea. It's actually really well built, works really well. The general idea is just sound. In this instance, we use structured input and output. So we don't just send code, we send a message. And if we want to evaluate something, we send an evaluation message. And we get output wrapped in the same way, so we know what we got back out and what it came from and what caused it. So we get even more information than a PREPL. We can also add middleware, so you can add the CIDR middleware and a bunch of other different ones. And they add more superpowers to this NREPL. They add more things you can do that just are not possible. They allow you to do things with ClojureScript that are not possible with the PrEPL implementation in ClojureScript. Emacs and Cider rely on this, but they don't expose too much. It's kind of hidden away, which is good because you don't want to be worrying about these things under the hood. And they work over Ben code by default, or B encode, which I think was written for a torrent client originally. So the encoding of messages we send and receive to an MREPL are B encoded, which is kind of language agnostic, and you can find implementations in every language basically. Pretty easy to write an encoder or decoder for, so you can write plugins for this quite easily in any language. Because if it was using Eden as a transport, I would struggle to find a good Eden parser in Lua, for example, or VimScript. So I think newer versions do support Eden as well as a transport. If you did want to use that, then you can do. And Propel there is another option. That's what I wrote when I was building PrEPL-based tooling. It makes it as easy as the nREPL command line to start a PrEPL server. So it kind of wraps up a bunch of obscure options that you need to configure for PrEPLs, and makes it as easy to start as an nREPL, and it creates like a .prepl port file, just like a .nREPL port file. So it's just a convenience wrapper that makes it feel a bit more nREPL-y. So sockets are good. Sockets allow us to evaluate stuff remotely. That's great. And there's different ways we can do it. But they are only as good as the client, because there's two sides to REPL development. There's the encoding and the medium, and whether it's strings in, strings out. And then there's also the clients and their UX and usability and how you interact with them. So let's explore my personal UX, the one I designed and built through multiple iterations, and show you different ways of looking at these ideas. So this here is the Conjure school script. This will, as long as you have an up-to-date NeoVim, like 0.4 plus, drop you into the Conjure school and clean up after itself when it's done. I already have this installed, so I'm just going to do Conjure school. And now we're in the school, and I'm not going to read everything in the interest of time, but it basically explains to us how we can evaluate things. So this is Fennel, which compiles to Lua and runs within NeoVim. So we are running a Lisp within NeoVim. It's a very Clojure Lisp. Conjure supports multiple Lisps. It supports Clojure, Racket, Janet, Fennel, and that's it so far, but I have a bunch of other plans like Common Lisp down the road. All with the same mapping. So I can evaluate this whole buffer with (EB). So that evaluated the buffer. And in the top right there, the heads-up display has appeared and shown us the latest result. And the result was lesson 1 of 7 complete. And then we get told about the log, and we can open this log. So that HUD was a little view into the log buffer. I can do (LV) and open the log buffer in a vertical split, which is an editable buffer. I can put more things in here and evaluate, and then the results appear down here. And this will auto scroll if you've got your cursor on the last line, just like a terminal. I can go into this form here and I can do (EE). I'm going to zip through this. So I've evaluated this form here and it printed out more. So we're moved on to the next step. It's explaining how we can evaluate the root form, which is this form. So from anywhere within here, we can evaluate the root form. So the outermost parentheses, so (ER), evaluated the root. And then we move on to the next step. And you can see the log is proceeding here. We're getting through the lessons. I can open a tab if I want to, or open a horizontal split if I need to. So there's a few different ways to open splits there. So the other thing we can do is paste the results of evaluation. So my evaluations are stored in my clipboard. So I can actually paste, and the previous evaluation was stored in a register automatically for me, and you can configure what register that goes to. The next one I can show is eval and replace form. So (E!). It evaluated this form and replaced it with its result. So you can see we've done 3 out of 7 and then 4 out of 7. So we're slowly making our way through. This is talking about marks. So Vim has a concept of marks. So I can do MF, and then I can go somewhere else and I can do backtick F, and it takes me to that mark. What Keynotes allows me to do is comma EMF, that evaluated the mark F. So that moved my cursor to this form, ran the evaluation, and moved back without ever updating the screen. This will work cross-file if you use an uppercase mark as well, because uppercase marks are cross-file in Vim. So you can do M capital F, go to another part of your project, and still be able to evaluate that form with comma M or EM capital F. There's a lot of mappings here, so it's all going to be very confusing, but the general idea is that you can evaluate things at a distance, which is very useful sometimes. We can also evaluate a word under the cursor, comma EW, and you can see in the top right there, this is the contents of school.lesson5 message. Yes, it is indeed. And we can do general like visual selections as well, which is very useful. I can do a motion. I can do comma EIW. That did similar to comma EW. I evaluated in the word, but I did it through a motion. And the same here. Evaluate a form by specifying parentheses. And that's all the school has to show. So you can go through this at your own pace and get a feel for some of the messages and read my help a bit more. And speaking of help, we can also evaluate this little thing here, which evaluates the vim help command for Keynotes. And it drops us into Keynotes help text. And then you can scroll through here and have a read of all the mappings and configuration, and everything's documented. So hopefully that will be fairly insightful. Okay, let's keep moving. I hope that was a good little taste and you're interested to find out more. Yeah, feel free to go and check out the school, give me some feedback on that. I have a Discord for Keynotes as well. Anyone that loves Lisps and Vim, you're more than welcome. I'm trying to join all of our Lispy worlds together through Keynotes as a conduit or a bridge. So anyone that is interested in that area, please swing by. So REPLs are language agnostic. Like that was Fennel I was showing you there. But Clojure has some specific magic because all languages are different. Even if we can evaluate them, everyone has different strengths. Clojure has a particularly powerful REPL experience, and that's all thanks to the community, really. So we have like change namespace refreshing with tools namespace refresh. We have completions via complement in Clojure and ClojureScript. So you get full IntelliSense completion from your editor connected to your browser through ClojureScript. And that's fantastic. It works amazingly. In MREPL 0.8 and above, we get completions and symbol information lookup without any middleware. So we require less dependencies. So the base NREPL experience has got far more powerful, which is fantastic. I still need to integrate that, but not much to do there. We get go to definition, which is such a good, powerful feature that normally requires a huge IDE and indexing and searching. We get that off the bat, and it's updated live because we talk to a real running application and say, hey, where is this code found? We get documentation lookup, which we could do as we type. We get function argument hints as you type in most editors. We can view the source of a function without moving the cursor. In Conjure, I can do comma VS, and it will view source. We can run all the tests in a namespace or on an individual form. We get MREPL sessions, which I'll touch on just a second. And we get editor plugins to allow us to jack in. So Vim, there's one for Vim and there's one for Emacs. I think Cider has it built in actually, that allow you to start a REPL from within your editor while you're working on your project. And they are really useful for quickly getting a REPL open and being able to evaluate something within a file on a whim without having to remember to go set up a REPL. So MREPL sessions that I just mentioned. MREPL gives us sessions, and they allow us to have multiple processes running and even multiple languages running. And Cider has its own concept of sessions, but they're completely unrelated. So I don't think it exposes this concept of sessions. I think Conjure exposes them and allows that is a first-class concept, but I don't think Cider does. They're a great tool that is hidden away in most cases. They allow you to hop between different languages. They allow you to perform long-running executions in one session, hop to another session, perform some evaluations, and then see the result of your long-running one at some point, and maybe go back to that session and perform some more evaluations. And you can see the screenshot from Conjure here. You can hop between your sessions, and rather than displaying a UID, which is kind of unfriendly, I've replaced them all with cat and dog breed names. So it's a bit easier to understand what they are and relate to them a bit. So every time you open up a new REPL session with Clojure, every time you connect to a server, you get a new little like connected to Greyhound, connected to Corgi. So that adds a little bit of readability to it, I think. But yeah, they're a really cool feature. Definitely check those out. I don't think they're very well known, but I use them all the time. So namespace refreshing. What is namespace refreshing? I mentioned it on the Clojure superpower slide. It's basically a concept of loading namespaces from disk that have changed since the last time you did this refresh. And it loads them in the right order, so in dependency order. And it integrates with component systems like Stuart Sierra's component. And you can set it up to start and stop your system at the right times. So you've got to make sure that you have a 0 argument stop function for your system and a 0 argument start function for your system. So something that will say Stuart Sierra component stop and start needs to have a 0 argument function to do that. And then you can hook up your editor tooling to those functions in Emacs or Cider or whatever you use, so that when you refresh, it cleanly shuts down the system and then turns it back on when it's done refreshing. So you should configure your editor to be able to do that. Make sure you get this working from day one. If not, I highly recommend you getting your editor working with your system as soon as possible, because it allows you to work within a real running system. I work inside Docker containers, and I edit the files on disk that are mounted into the containers, and then I use refresh to refresh those changed files and restart my system and reload the handlers as and when I change them. Because restarting your REPL is a red flag. Ideally, you want to be reloading from just a file or a buffer. So just evaluating the file is enough to see your changes reflected in your running application. But if that's not enough, if you can't just evaluate a form or a file, you should be ensuring you can do so through refresh tooling. Because restarting your REPL is a last resort, and you should always try to avoid it if you can. It's just wasted time, really. So we can type Clojure into a REPL. We can send it from an editor, but we can also send code from Bash to an existing REPL. So I use this in my blog to send a refresh call into my blog's running process to rebuild the ASCII doc into HTML. And I watch files for changes with a program called ENTR and send a rebuild call to my REPL whenever I need to. And this can be used in development to trigger or configure things while they're running. So let me just show you quickly a REPL. Let's just start this REPL. I need another REPL. So let's start a socket REPL. Here you go, you got a REPL, and run send code. And here you go, it started a REPL over on my right-hand side, connected to it, sent some code to it, and we got the result. And I can do the same with a prepl. So let's start a prepl and send some code to that. And you can see we got some results, and they are wrapped in data. So we know what kind of result we got, which is really useful. And we can take this whole idea a bit further. So we could do Clojure executing Clojure. And we start to get a bit Erlang-y at that point. It could be used to offload work elsewhere. So we could send code to another system and have it evaluated and get the results back. But it would also potentially allow remote code execution. So you'd want to be careful with these ports and where you're exposing them. But this kind of like this sending Clojure idea doesn't need to be program to program. It can also be human to program. So because you don't need any dependencies here, you don't need mREPL in prod, you can use prepl to write your kind of own custom debuggers and connect them to your prod servers through a VPN or whatever, so you are connecting to a port that nobody else can access, and be able to debug your live running application without any extra dependencies in your running app. So prepl is really good for simple tools like this that have one purpose. Not so good for IDE-like features where you want multiple evaluations happening at the same time, because as we saw, nREPL is really good for that. We have sessions and we can hop between things and cancel things. But yeah, PREPL is a really interesting idea that I don't think anyone is really using in practice yet. But I think it's, definitely opens up some really interesting ideas for sending code to things that are already running, because startup time is pretty horrendous for us. And if we can avoid that and just send the right code at the right time, it might help you solve some really interesting problems. You could potentially upload new code to your server, and then send a refresh call to your server. And there you go, you've deployed. I'm not sure if I'd recommend it, but it could be a fun experiment. And I should wrap up now. I'm getting into my last minute. But we're going to have questions during the Q&A in a little while. I hope you found this interesting. There's a bunch of links here. Check out my blog, OllyMe UK. If you're interested in more PREPL-related things, I have a bunch of writings on there. There's a lot of information about how PREPLs work and all of my findings about them. And there's a few links to plugins and tools that I recommend. Definitely check out Conjure if you are a lover of Lisps and quite like Vim. Thank you very much for listening. I hope you've enjoyed and learned something. I look forward to your questions. Thank you.
All right, welcome back to the main stage. Thanks, Oliver, for your talk, and thanks, Tim, before Oliver for his talk. We are going to prepare for the Q&A panel. We are just 4 minutes short of the beginning of the session, so I'll see you back there in 4 minutes. All right, I'm starting to collect questions and thoughts regarding the two talks by Tim and Oliver. Just want to double check that the setup is okay. I can see Tim. I think you can also talk if you want, right? You can unmute yourself. Everything is fine, right?
I hope you understand me.
Yes. Yeah, all good. Oliver, is all good for the Q&A session? We cannot hear you if you're talking, Oliver.
Oh, that's because I was muted.
Yeah.
That will do it.
Yes. Yeah. Now it's coming. Now it's coming through.
Excellent.
So I'm started looking at the chat for questions, but in the meanwhile, I'm going to ask the same question. Well, first of all, thank you very much for your effort and talks. Very appreciated. I'm going to ask you the same question I asked other speakers as well. Anything like surrounding you, interesting that we should know about you that like maybe it's a secret? Oliver, you're going first, I think.
I don't know about a secret. I just thought I'd grab my snowboard. Sadly, I haven't got to use it for a while, and I don't know when I'll get to use it next. But yeah, I dream of being able to go back to the Alps and fall down it, hopefully getting to the bottom in one piece so I can have a beer and collapse again. That's my my favorite place to be. I was going to get my my Go board, but that is over on the other side of the room covered in stones, which I'm playing a correspondence game on right now. With somebody in Ireland. I'm not very good at the game, but I do love playing it.
Fantastic, yeah. I COVID should be like a finger crossed, touching wood, should be end 2021 with the vaccination and everything. So I hope if it's not this winter, will be the next. But yeah, well hoping for that.
I hope so.
Tim, anything interesting in your room that you want to share?
Yeah, not sure if it's interesting as I'm sitting in the kitchen, as the office is a mess and I couldn't possibly show that to you. But I have my guitars in the background. Planned on showing you the dog, but it's sleeping, so don't disturb it. And yeah, I'm not a snowboarder, but we're into cross skiing. And here it's started to snow last week. And it's just a discussion if the ski resort's open. So if I'm lucky, next week it's decided. And yeah, Oliver doesn't help you, but I'm happy for us.
Good. Well, yeah, I saw like it's not snowing here, but yeah, close to that. It just needs to be a little bit colder. But I hope for the Christmas to be white. That would be like a nice touch for once. Okay, so there are a few questions coming through. I'm also asking people live connected via Zoom to raise their hands if they want to make the question themselves. So I'm going to start with the first one I see on the channel, and it's about test containers. So it's for Tim. Let me see. Wrapping an extensive Java library of objects upon objects poses the challenges of complete feature coverage and then keeping up with the new versions of the wrapped library. Is it necessarily a matter of thoughtful labor, or did you find the wrapping could be partly automated? Were there patterns in the test container such that a macro could live wrap a given minor update of the library?
Yeah, that's a good question. I like to think of it as thoughtful labor myself, because the biggest challenge is to make sure that the future updates on test containers don't break our API. So we don't want to bring an update and suddenly everybody who uses the library needs to adapt changes or have breaking changes in their code. So it is currently a really defensive, I believe it's the right word, and we are carrying the test containers Java object along through all the calls. So all the return values, all the results always contain that object. So we can build new functions upon this Java object. And we do not convert everything into a Clojure data format and adapt this if test containers get updated. So we try to work pretty close to the original library. And we try not to do anything that the test containers library cannot do for itself. So yeah, in my opinion, there's no way to automate that, as we don't know what side effects or what return types new functions, new methods in the API will bring for us.
Good. I have so there's a question. Yes, this is for Oliver as well. Interesting. So somebody in the Ivory Tower, in the Clojure Ivory Tower, commented that in REPL, being message-based was contrary to nature. Lisp is stream-based, but editor developers all seem to lean strongly toward nREPL. Why is that?
That's a really interesting question. Yeah, and I wonder how big this ivory tower is and how we all fit in it. So I think it comes down to a question of puritanism versus pragmatism, and it's kind of why you would lean towards Clojure or Common Lisp. So on one side of it, you could say, oh, it's just a stream. Like, it's so simple. There's like it's so easy to describe and implement, which is great, like Scheme. But I wouldn't ever pick Scheme to do a real world job. I would pick Clojure. And the reason is because it's made those trade-offs towards pragmatism. And I think message-based REPLs and structured input and output REPLs, they fit that same idea of, well, I'm a jobbing programmer. I've got to like do these things for my boss. And I don't want to be like telling my end user, yeah, it's taking me a while longer because I'm using this like stream-based REPL. It's really beautiful. They don't care. I want to be able to do multiple evals at the same time. I want to be able to cancel evals. I want to be able to talk to multiple languages. I want to be practical because I'm trying to do real world things. So I'm sure there's arguments for simpler REPL experiences, simpler on the technical level. But that's going to limit what you can do at the UX level. And I feel like that's what matters when you're trying to solve real world problems. You don't want something beautiful code-wise to get in the way of solving a real world problem in a good way. So yeah, I think it's a puritanism sort of thing.
Yeah. So I don't see at the moment any other question. I don't see raised hands. So I had a question for you. It's a little bit more general. So it's a little bit about editors. Yeah. But yeah, I wanted to know your opinion because I'm not in these things and as I used to be. So I went from Vim to NeoVim, and then back into Vim again, like believing that the only feature that I was missing in the pure Vim was this asynchronous mode. And then when that came into Vim, I went back to Vim. So then I didn't follow what is happening in the NeoVim community. Do you think that? So my perception is that there's still way more happening in NeoVim than in the basic Vim, maybe for like by design. I wanted to know, am I missing a lot by not going back to NeoVim, and should I pick NeoVim for my Clojure development these days?
Well, I'm biased there because my tooling only works in NeoVim. So of course you should pick NeoVim and use my tools. I personally lean towards NeoVim because I want Lua as a first-class language. So they are moving away from VimScript and towards Lua. I'm not a huge fan of Lua, but I'm a pretty big fan of Fennel now because I get macros, but also the portability and speed of Lua. So Lua is probably my main reason. And then there's the way they do like layering of windows and floating windows. So that HUD that I can pop up in the corner of the screen. I think Vim has solutions for that now, but NeoVim was there first. So I was leaning on their features beforehand. And I like the ethos of let's not support something where the physical machine for it doesn't even exist anymore. There are no machines that run like this old machine doesn't exist anymore. Vim still has support for these old machines. and NeoVim doesn't. So there's a kind of philosophical difference of let's drop things. It's pragmatic again. It's dropping old code. The other thing that I've kind of bet on NeoVim for is tree sitter support, which is something that I think VS Code pioneered, or Atom potentially, which is coming in the next version of NeoVim in 0.5 plus, and it will allow us to traverse the syntax tree in memory without parsing, which is going to allow us to write plugins that manipulate the syntax tree really easily, which I will lean on a lot, but it's also going to make your syntax highlighting a lot smarter. So Vim will be stuck with regex-based, line-based highlighting and understanding of the code, whereas NeoVim's going to move into this world that all of the modern editors are leaning into, where you have constant understanding of the code going on as you modify it. And I feel like that's just going to be so powerful, and we're going to be able to build so many great tools with that. And I can't see Vim getting that really. So it's, again, ideological difference. Are you happy with how it is? Stick with it. If you want to lean towards where these modern editors are going, then go with NeoVim. They want to be part of the future and be able to have these features that these modern editors have. Because we can't just be stuck in the past and go, no, we're definitely correct. Things change, people learn, and we should definitely learn from other people.
Agree. Thanks, Oliver. We have a raised hand, so I'm going to ask Elena to unmute and make her question.
Hi, so I think I'm a part of your audience, as in I use Clojure, but I don't use it on a daily basis in commercial environment, so I kind of have to figure out a lot of things on my own. So I was wondering if you have any resources for integrating REPL and upload or automatically updating specs. And just a link would be good. I need to do a lot of reading, so I don't expect you to answer that fully. And thank you. I really appreciate the talk.
Oh, thank you. That's a good question. I don't have a answer, like an exact answer, a specific one. But I think using tools namespace refresh reloading is probably the way to go. So if you Google tools namespace refresh or Clojure REPL refreshing, there's lots of guides on how to do this action depending on what tools you use. And you can always do it just at the REPL as well. It's just like a function you execute. And that will probably reload all of your specs as well. I'm pretty sure it clears the namespace and reloads it all. So that would probably do the job. And as far as just like learning these things and learning how, like these workflow things, I can't recommend Practically enough. So the Practically YouTube and blog and everything that John puts out is an amazing resource for people that are trying to learn Clojure and the ecosystem and the tools. So I would definitely recommend giving those videos and blog posts a view and read. But yeah, tools namespace refresh is probably what you want to lean on there.
Sounds good. Thank you. Could you send the link to what you just mentioned in chat?
Yeah, sure thing. Yeah, I'll
Thank
drop
you.
something in.
Appreciate it.
Okay, we have another question for you, Oliver, again.
Oh my.
Yeah, I'd like to find like I'm checking if there's anything with the team, but it seems to be Vim specific even. For a non-Vim user, what is the role of Lua? Is NeoVim going to be the next Emacs?
Well, that's a very tough question. No, I think they're always gonna serve different camps. That's for sure. Like different ideas and ideologies. Like Vim is not my OS. It's just something that I launch and kill 1,000 times a day because it starts really quickly and it's really lightweight. And when I break it, I turn it off and on again, which you can do with Emacs too, I guess. And I did end up doing, which I was told I probably shouldn't be doing, I guess. So Lua is significant for me because it is a better designed general language than VimScript. Like that's objectively true. VimScript isn't a great language. They're making it better, but in the newer versions of Vim, with some faster VimScript versions, there's breaking changes in the syntax. So they will not be compatible with older versions of Vim, which seems like a pretty dangerous choice for me. So I think leaning on a language such as Lua, which is running in Lua JIT, which is the fastest JIT implementation, I think, out there. It's like on par with C for a lot of algorithms. It's incredibly fast. Having that as a kind of underlying almost bytecode, and then being able to choose other languages like I'm doing, I choose fennel and I compile that to Lua and I get Lisp and macros. So I write macros for my Vim plugins. Is just great. Like by basing things on Lua and by the community beginning to be drawn to it, we're ending up with all of these Lua tools and libraries that suddenly we get access to. So there's a lot more Lua out there than there is VimScript. So I think the bet on Lua won't overtake Emacs at all. It won't be some like paradigm shift. But for the people that really want that kind of like modern editor feel while still being Vim fundamentally, NeoVim is the place to be for that line of balance, I guess, between pragmatism and old Vim feel. Hope that answers the question.
Hopefully. So I don't see at the moment any more questions, unless you see them somewhere else. I don't. So I'm going to just give it like a last nudge for questions. If not, we are going to have a little break, including like a proper break. And we'll be back in, let's see, about 45 minutes, if I'm not wrong. Yes. So once again, any more raised hands? Or if not, we're just going to we're just going to thank Tim and Oliver once again, and Tim also for being flexible. He moved his talk from Saturday into today. So thanks a lot for that flexibility as well. And yeah, I think that's all. So see you soon in 45 minutes. Thanks, everyone. Bye-bye.
Thank you, Renzo.
Okie dokie. Okie dokie. Hello? Hello?
Yeah, you're getting feedback through Reborg.
Report. Reboard, reboard, reboard.
Hello, everyone. So we are like about a minute or two away from the beginning of the next talk. Since this is our first live speaker, so kudos to Santi and the next speaker too. So we're going to have 2 live talks coming up. There's going to be a little bit of setup to do on our side. So I'm going to ask Santi to quickly check if he can share his screen, microphone is working. And as suggested in the chat, what is it? Give me a sec. Yeah, as suggested in the chat by Jordan, feel free to switch on your videos if you don't mind, like the camera pointing at you. It will just make the interaction a little bit more live, especially for live speakers, so they can see they're not talking like against the wall. Just like a nice touch, I think. Thanks, Jordan, for raising that. Sandy, can you try to share your screen and see if that is working fine? And your microphone as well. You're muted. You're muted.
Can you hear me?
Yes, can hear you. Cool. Can see you.
Yes, let me figure out which window I want to share.
Yeah, go ahead. We'll take our time. It's like this is a stage like when you are at a conference and the next speaker is coming up, we are doing exactly the same things.
Can you see Emacs window?
Yes. Yeah. Fonts are pretty good as well, the font size.
Cool.
So it's, I guess, everything that you need. Like you can share, you can talk.
Cool. Thanks, Renzo.
Fantastic.
So yeah. Yeah, go on.
Sorry, I just need to like mute myself and go away, and then I'll let you run. Yeah, the time is 6 like GMT. So we are all ready for the next talk. As I was saying, it's a live talk, which adds to maybe to the complexity of the setup. We'll see. Maybe it's easier. And this one and the next one will be live talks. And so Santi is a colleague of mine, so we work in the same company. And so I'm very happy that he proposed this talk and is here tonight to share with us what he has been doing with this library called Piggy, all about Clojure specs. So Santi, it's all yours. Thanks.
Thanks, Renzo. So yeah, welcome everybody. Hope you're having a good conference so far. Since this is live, I'm happy to do kind of live feedback with people. So in the Discord, there's the welcome to this little piggy, how I learned to relax and refine my specs channel. So if you have any questions, I'll kind of peek up and see if I can answer those in real time. Otherwise, yeah, let's begin. So I'm really happy Oliver, the talk before me covered a lot of introduction to REPL stuff, so I don't have to, this isn't scary to anyone of this entire talk just being the REPL. So for the meantime, I'm just gonna kind of riff off, some stuff I prepared before and the kind of central problems that I at least want to cover here tonight. So yeah, so what was the title of my talk? I'm forgetting already. So let me just, oh, that's wrong. Let me just see what the title is. Okay, yes, it's This Little Piggy, or How I Learned to Relax and Refine My Spec. I'm using some terminology here that I'll explain later. But yeah, I could also introduce myself, I guess. So I'm Santi. Hi, everyone. And a little about me, as Renzo mentioned, we work together. We work together at a place called Dwa. Well, actually, I'm a software developer, and my employer is Dwa. We're hiring, so feel free to reach out or go to the website to talk more. I'm also an alum of the Recurse Center. It's a self-directed retreat in New York, but in the last few months has gone virtual, so open to anyone worldwide. And a lot of the initial work I did on Piggy, I did there. So I thought it'd be nice to mention those folks. So, as Renzo hinted at, I want to talk kind of about Clojure spec and kind of how it really has affected how I end up developing software at Clojure. It was when I started to learn Clojure, it was around the 1.9 release when Clojure spec was introduced, and the kind of things that was showing up really caught my imagination. So if you're not aware of Clojure spec, it does a lot of things. I have some list. It does validation, it does parsing, instrumentation, can provide some documentation, has given us new ways to interact with error messages, and particularly I'm interested in is automatic generative testing. So the crux of this talk will mainly focus on that. So a lot of, I think the magic of, for me at least, developing Clojure or developing with spec is I could start to draw the shapes around my data structures and whatnot. I gave an introduction to Piggy around this time last year, and that talk mainly focused on how Piggy provides specs for break-in changes, and but it hand waves kind of the important part of generation. How do you end up generating these specs for your functions that allow you to have a bunch of valid inputs and outputs that could test in a very thorough way break-in changes. So in this talk, I want to kind of delve deeper into that half, of the equation. So if you never used Clojure spec before, it's mainly around predicates. You could write a spec for, let's say, an integer. It'll give you this kind of opaque object, but we could ask for its form back and see what we wrote. Cool. So that's what it initially looked like. But we could also validate against specs. So I could say 10 is an int, and I could say Santi is not an int. But the coolest part to me is how you exercise functions. I think this should work. For the record, I am running on a branch of spec called spec alpha 2, not because it's particularly any better, it's just that to develop the break-in changes, the thing I wanted to show off was it could find break-in changes across spec 1 and spec 2, and I just forgot to switch back to an old branch before I developed a bunch of these features. So this is in spec 1, you wouldn't need to wrap that, but in spec 2, there's a difference between symbolic specs and the kind of opaque spec object that I showed earlier. So the cool part is here we could generate a bunch of valid values that conform to this predicate. And this works for other things. If I just wanted positive integers, I could do that too. If I wanted negative, I believe this is the predicate. Yeah, negative would do that. I use other predicates. Let's say I'm interested in vectors. Awesome. So this is great. The problem, I guess, starts to happen when you move outside of the kind of core functionality. So if I, write my own spec, let's say yes, what's the word I want? Exercise. What did I want to do? Let's just say it's a function. I want to, I guess I know the predicate is greater than 5, right? I want to exercise that. I get errors because there's no built-in spec for this, and you learn that through practice that there is a limit to how much the generators can infer. So this is a problem. Oops. So this is a problem. So what do people end up doing? Well, a lot of the time, the advice is to wrap it in something called SN, which is a combinator. It takes one spec and kind of like left to right, kind of flows those values through. And as long as like they all are true, the entire spec would be true. So I could start it. I could start off, give it a generator that I know works, int, and then pass it this the predicate, the arbitrary predicate I gave it before. So that gives me a spec object. Exercise this, and cool. So I get a bunch of things over 5. That's great. But what if I want more specific kind of functions? Like this works well because underneath the hood, it's doing something called like such that, which is a combinator in the test check library, which it takes every generator and just filters out all the things that filters all the things that are truthy for it. So it just has a bunch of generators and it finds out all the valid things. So if I had a very specific one, like, I don't know, equals 5, I would probably get, you might run into this error. You probably will run into this error, like couldn't satisfy such that predicate after 100 tries. So can we do better? Maybe. Similarly, if you wanted to do like regular expressions, or like if I know, what do you call this? I'll move off that. So what I wanted to introduce is you have to find the right spec is a kind of interactive process that I think is really suited for kind of solving at the REPL, but we just don't have the tools for it. You sort of end up needing to know like the domain knowledge in a way that, I need to, refine this generator such that this predicate will be satisfied. But similarly, if so that's one big problem I think a lot of people run into. But also when you're trying to find the right spec, sometimes you have to also worry about over specifying, because in trying to generate or get this kind of I'm blanking on the word, but the joy of like seeing values and like poking at them, in a lot of ways, like seeing is believing, but seeing can also be deceiving in a way that if I ask you what kind, if we're writing a spec for the map function, right? Map, right? Usually you say you map over, you take a function and you map over some collection in like the very simplest case, right? What predicate would you put here for function? FN, does FN sound good? What do people think? I mean, it's pretty good. You'll definitely find, definitely capture a good chunk of what you want. But what if a common thing is, you know, you have a collection of maps, name, Santi, name, Renzo. You have a collection of maps, but you just want to use a keyword. A keyword implements the IFN interface, which allows it to be used like a function. And that works. But if we asked is name a function, it'll be false, right? So the right predicate here would be IFN. And that's, at that point, you're sort of like knowing some Clojure internals, which maybe are useful. Similarly, sets would all, you could map over with a set, right? You know, to check for predicate truthiness. So finding the right spec sort of is like difficult without the tooling. You know, you have to read a lot of the, for me at least, I had to read a lot of blog posts to get to it. So the thing I wanted to introduce is this process I'm calling whittling, or whittle rather. So to look back at the title, let's look back at the title. That's the kind of pun I put there. Why the whittle term? So I think, you know, a lot of people know the term in the sense that, you know, you whittle down something, right? You whittle down the definition, you know, you shape a form by pairing or cutting, you know, yada, yada, you know, yawn. I'm not really interested in it. Oh, I spelled yawn wrong. Oh, well. Oops. So there's that. You know, it's not a Clojure talk without, you know, bringing out some definitions. So actually, I also looked at a 1913 edition of the Webster's Dictionary. It turns out there's another definition, you know, to edge, to sharpen, to render eager or excited, especially to excite with liquor, to inebriate. And so this kind of caught my interest because in Rishiki's talk about breaking changes, I believe the talk was speculation, he described the process of relaxing a spec or a predicate, you know, relaxing constraints to make them more general. And this is the process of going from that FN to the IFN thing I mentioned earlier. So in a sense, you know, whittling can also be relaxing. And so, you know, to not confuse it with the common usage of whittling down, I called this whittling up. And for this reason, you know, I developed a bunch of functions around this abstract process I've been describing. So how do I get that? Let's see, NS aliases. So yeah, I have a whittle namespace, piggy.alpha.whittle, and I define, you know, a few functions as whittle up, which does what we said here. It has, and I could ask the question of it, right? I want IFN. If I want to whittle up, what I would get IFN. That's great. Similarly, if I want to whittle down, IFN, I'd see, actually IFN does a bunch of the things I mentioned. Maps can be used as functions, function can be used as functions, sets. So, I'm missing keywords, so I guess I had to fix that implementation. So there's that. behind the scenes, I'm using some functionality I developed around registering registering WDLs in a hierarchy or a registry, really, where you can take an arbitrary, predicate or fully qualified predicate, fully qualified symbol or keyword, as in like Clojure specs, and define these parent-child relationships out of that. So in the kind of cases we saw earlier, we would say FN is IFN. I'm doing that kind of, an FN is a IFN. So what does this get us? Why would you bother, doing this additional thing, this other registry? You're already dealing with specs. Yeah. So the reason I wanted to do this was to kind of have something separate from specs. Specs are doing like a lot of things, as I showed earlier. Oops, that's not it. A lot of things. Oh, lots of things. Sorry, I forget the var I used. Oh, lots. Cool. It does quite a few things, and when you're doing an SDEF, you want to get as much as you can out of it without doing much work. But when, as you saw, things can get complex pretty quickly, and I wanted a tool where I could at least reason about these kind of things programmatically at the REPL. It's a lot of good work, I think, is done away from the computer. But when I'm at the computer, I want the most power I can get. So why do we want to do this? One thing I think is really valuable is if I think I show this exercise. If you try to exercise FN earlier, right? We get a lot of problems. We can't even see the kind of thing we're working with. I think the benefit of like exercise is you get a lot of examples really quickly. Same thing with IFN. But I implemented this function called WDL registry, and I could pass it. So exercise has a few arities. You could, give it a spec, generate it, and you could give it an n, generate that number of things. And you can also give it overrides. Registry targets these overrides, which is similar to overrides in the test check functions. So here I could turn overrides, and I'll use the exercise style, and I'll turn on children, which means it'll use all the generators. If any of its children have generators, so maps have generators built in, sets have generators built in, it could use that to generate instead. So, oops, one cannot pick. Oops, no. Well, this is what I get for poking at it before this call. But yeah, the idea is you're defining all of these relationships. You could see the kind of maps built in. Oops. You're defining all these relationships anyway. So you want to get the most out of it. Let's see, what's the last part? The way, so this does simply for, this is nice for a few things. There's also facilities in WDL reg to, let's say if I define some spec and I want to say it's an integer spec, I could give it options map where I could pass it combinators from test check. So fmap is a nice one, and I could just simply pass it a function that takes a value from the int generator and produces and it will return like a new generator. So in the case here, I could make a, I guess, strings string of x, and then if I want to sgen, or I could get gen WDL / get gen of some spec, and then I want to sample, I think. Sample some spec. I would be able to generate some things. I'm running a bit on time, but hopefully it shows how much work in progress this library is, and I'm looking forward to continue on working on it and develop it further, especially kind of the ideas I talked about here. Hopefully will be helpful to people who are, I guess, who might be struggling with taking their Clojure specs and making their own generators. I think a big success for this, for my library, I think would be if it's a gateway drug to use in test check more. So I believe that's my time. So thanks to the organizers of Reclojure, and hope everyone has a great rest of the conference.
Thank you, Santi. So I'm going to claim back the spotlight. Since we have like 2 or 3 minutes, I guess, while I'm contacting the next speaker, if there is any question, please raise your hand and we'll unmute you, and then you can ask your questions. If there is none, then no problem. Remember that there's a channel on Discord for any questions for Santi and his talk. Having said so, we have Sam coming up next. So it's another live talk. So I'll have to find, so bear with me. I find Sam is here. I don't see any questions, so I'm just going ahead and prepare for the next talk. And yeah, I can see Sam. And hi, Sam.
Hey, how's it going?
Is it going good? I think. Is it like looks like it's apart from a couple of things at the beginning that didn't work exactly as expected, but yeah, no, we fixed them, I guess, and now I think it's going good. All right, so shall we just give it a quick go and see if you can share your screen and your setup is fine?
Yes, here we go. I'm gonna go ahead and share desktop, and then.
Yeah, okay. We can see if we can, yeah, it's also going full screen, so looks like everything is working okay. So you can
amazing, and I can actually see everyone over the. This is, I still haven't broken into the world of remote presentations, so this is wonderful. This is great.
Yeah. Cool. I was just conscious of people might connect thinking that is like a 30. It's gonna start at 1/2 the hour. I just want to wait a little before starting, but that's it. Maybe you can tell us a little bit about yourself while we wait. Or
sure, I'll get.
Maybe, or you can give us like an introduction that you are going to do later on at the QA panel. Is there anything interesting surrounding you?
Oh, this will be like the little pre-session for those of us so excited we got to the talk early. What's going on? Okay, so I'm not going to mess with my monitor because I've got everything pointed well. Yeah, I'm here in beautiful Boulder, Colorado. It's gorgeous and sunny outside. We still have snow on the ground. Winter started. This is my bookshelf of mostly unread books. I don't know how you all feel about libraries, but I sort of cycle books off that I've read. So if I need to be inspired or shown how much I don't know, I can just go stare at this thing and feel awe at the masters.
Yeah, I have a bit of that myself as well. Like I have a little like bookshelf. I'm mostly buying electronic books, but I have a few that I really like to read in paper, and sometimes I buy a few more than I have the capacity to read, and I think we end up in the same situation. But every once in a while there is a nice long flight. I mean, used to be when we used to travel, and then I can grab one of those.
Yeah, I've been going down that. Well, we're close to time, but the other objects to share are these 3 books by Gerald Sussman that I see Jordan nodding. We had a nice meetup on Wednesday where my friend Colin was throwing these in the air and having them spin.
Is that the new one?
The new one? No, the new one I have pre-ordered, but that one's coming out in March, I think. There's the newest one is from 2014. It's his differential geometry book, which, I mean, he's just so off the deep end. It's unbelievable. Like, we'll get into that a little bit during this talk.
Okay. Well, all right, let's get it started. I'm just giving out a hint about the potential guests we are having later on when Dan is on. It might be connected to what you just showed there. Excellent. So thanks, Sam. So you're up next. It's time to get it started. And thank you everyone for connecting back. If you were not connected, Sam is all yours. Thank you.
Okay. Yeah, thanks everyone. Okay, so my name is Sam Ritchie. I've modified the title of my talk a bit to make it more extreme sounding. So we're going to talk about Clojure, functional programming in physics, and the preservation of society. I think society is in a fine place, but we're at the beginning of everything, and our methods of communication of ideas are not what they're going to be in 500 years. So this talk will be about one twitch of an attempt to start working on that problem. Okay, so I have to start with the grandiose framing, and then we'll get into the weeds a little bit. A quick introduction to my name's Sam Ritchie. I've been in the Clojure world for a long time in various sub-communities. I spent a lot of time doing large-scale data streaming work. I was the maintainer of Cascalog for a few years, and have always loved this language and found it to be one of the best tools for me for thinking. It's something about this language just helps me work through ideas at the REPL. So I'm a sucker for anything Clojure related. So I've been working in this research lab in the last year and trying to get my physics ability up to speed. And I've come to a belief that all is not well with scientific communication. And by this, I mean the standard format of PDF publication that is really backwards compatible to the 1700s. We have tools that allow us to communicate mathematical and scientific ideas. We have mathematical notation, we have symbols, we have words, but they do okay, but you have to believe that there's something better that we'll get to. So one take on this is code for the serialization of ideas. There's a lot of history here. This has been something people have attempted. It's not taken off terribly well. And I'll get into some reasons for that. But I think that is just an accident of the time. I think people realized early on that code was a particularly unique vehicle for serializing scientific ideas. As a taste of what I mean here, unlike mathematical notation, if I get something into code, it can communicate, it can also run itself, and I can play with it and actually make this thing work. So there's this glimmer of something powerful that people realized back in the 40s. when computers are coming online, or Babbage even earlier than that. But it hasn't really played out. I think its time has come. I think we need to wake this idea up again. And I think Lisp and Clojure are a particularly amazing vehicle for the serialization of scientific ideas. And I'm going to show you why I think this, both the trouble and the solution, through some detective work I went through over the past few months. So here's Sussman. We just looked at his textbooks. He's kind of gleefully nerdy and is one of the best among us. He gave this talk, I forget which conference it was at, but called Programming for the Expression of Ideas. And it's an amazing talk. He goes through examples from differential geometry and classical mechanics and physics. It's amazing because he shows these powerful ideas that, in fact, do encode the math he's talking about. So you can see that he's accomplished his goal, but the talk is like totally impenetrable. It's really, really hard because the ideas he has are from a culture that I certainly don't share, this culture of general relativists and differential geometers. So he's really existing between these cultures. He has these symbols that he says represent a thing, but he doesn't run them in the talk. And the people from those communities aren't familiar with the code. So still, this is in line with his character. In the classic book, SICP, that maybe you all, I can hold it up here. This wizard book, there's this beautiful line: programs must be written for people to read and only incidentally for machines to execute. More of this belief in the air that code might be the way forward. He has written a couple books that, as an aspiring physics student, I mean, again, like the bait had just piled up by this point. I'm a sucker for Lisp. I want to learn physics. He gives this talk. It's impenetrable. Here are the keys to the kingdom. So I picked these books up, and what's inside is a fascinating take on physics. Physics is presented here as like a software API. And this is a huge manual to the API of classical mechanics or differential geometry in the case of the second book. And the promise is if you get these books, if you understand the API, you've learned the subject. And it's full of equations like this. There's math on the top. There's a Lisp rendering of what's on the bottom. And it's beautiful, but it still remains kind of impenetrable. It was written in the 80s when you couldn't run this stuff. So I took it on myself to learn how this library worked and filter it through my brain and turn around and share it with people in a way that was more absorbable and runnable. Some of the barriers in the way of code as communication are, again, where do you run this line? How do you set your machine up? All of these things that we're used to as software engineers are not okay if you just want to get across to a family member the beauty of these couple lines, which there's too little time to go into what this means here. So I'll leave you in the same state Sussman left me. So I took a stab at this book in the original scheme. I realized that the artifacts I was producing were going to be just as impenetrable to everybody else as they were to me originally. So I found this work. There's this guy, Colin Smith, had taken on this Herculean effort to port the book, the library backing the book, over into Clojure. And this is like a monumental effort. And I said, okay, we have Clojure here. I love this language. Clojure has something that older languages don't, older Lisps don't. Clojure can compile to JavaScript, and JavaScript can run in the browser. So maybe this will solve my problem. If I can just take this library and port it over to ClojureScript, then I can take these things I'm learning, I can get them running in the browser, and I can just share links with people. And everybody's going to love physics. Physics is going to spread through the world. It's going to be amazing. My 2-year-old's going to be talking about Lagrangians. Let's see. I did this, and I found that I was lured. Let's say the book cuts through classical mechanics and physics, but of course, physics builds on this immense amount of other work. You've got comments in the book, like this one here. Let's see what I can pick out from this. There's a piece of code that needs to rely on something called a minimizer. We've got a function. I just want to find the point, the x point where the y is minimal. or the input where the function will give me the lowest possible output value. And so you get this wall of words that I'm not expecting you all to understand. Like the minimizer is the Nelder-Mead downhill simplex method. So the experience you get reading this book is that you're moving through like one path on a graph, this massive graph of physics. And it's bewildering. Like you're getting cut left and right with footnotes and references and things like this. And there's no one there to structure it for you. So Sussman has done this beautiful thing, but the more and more I read, the more and more I tried to port, like I just kept having to pull in threads that really weren't explained in this beautiful style that Sussman was claiming code is all about. So I started digging into the library deeper and deeper into the guts to figure out, okay, the goal here is to embrace this idea of code as communication. Surely the code that backs the library will be beautiful artifacts of communication. And I dug into the reference manual for that, this thing called Brent's algorithm. It's a different minimizer than the one we just looked at. And I find quotes like this. We personally like Brent's algorithm. It's pretty reliable and pretty fast, but we can't explain how it works. So here we go. This is my first place where I can contribute to the field. I can embrace kind of code as communication. So I dig into the code and I find this, which again, there's no need to understand what we're looking at here, but let me paint for you. This is the beginning of my detective story. So this is a minimizer for a single, you have a function. I'm going to give A and B these kind of bounds. And within those bounds, I'd like you to find me the minimum value, or the point that will return the minimum value from the function. And really the code is not understandable. I mean, this here was written in 1987. Let's see if we can see my pointer. I stared at this for a long time. It's full of things like tall, too tall. If you scroll farther down, we see these variables like P and Q and T1, T2, T3, T4. There's mutation going on, these cryptic comments. So, okay, that's fine. Like not all code needs to be literate and amazing, but I'm still hanging on to this promise that there's a beautiful way to present things with code. So I go deeper. I find this Python code from 2001. This is SciPy, and it's really similar. If I flip back and forth, like we've got T1 here, we've got temp1 here. Like this kind of looks like it's the same code, just ported from different places. You see this comment, Sussman says he took this from a book back in page 79 through 80 of this old textbook. Python looks the same. This here, let's see, this is C++, this is Boost. We've got effectively the same code with the same temp variables, the same kind of mutation magic happening. There's a little more color to these comments. We see, parabolic fit here at the bottom, and nope, try golden section instead. So someone was kind of trying to absorb this. Like you can see someone tried to understand this and add comments and some information, but it's not, for me, this doesn't really teach me. It took a long time to decode what was happening here. I got back to 1986. This is, I believe, Fortran. This is in this book, Numerical Recipes. The code still looks the same. We have slightly different variable names. And then finally, I bought the book. So we're back to 1973 now, and we find this Algol 60 code that has encoded this, idea of a function minimizer that everyone finds so cryptic. And it helps a bit more, but it's still cryptic. But what I found is the text around the book was beautiful. There was this incredible description just in English of what all this stuff meant. I'll sketch quickly how this works. We don't have too much time, but basically the idea is, okay, one way to find the minimum of this solid black curve, if points 1 and 3 are your edges. One way is just try a bunch of points, like randomly sample. Okay, that might work. Another way is to inch the sides in. That's pretty slow. A better way is to pick 2 points somewhere in the middle, kind of evenly spaced. Pick whichever one's lower, and whichever one's lower, just move the outside bound in a little bit to one of the new kind of left and right. So he says in the textbook, you're hunting down the minimum like a frightened rabbit on a chase. Like it's bizarre phrasing, but it's colorful and amazing. And like, this is how humans actually talk. So his method is a way of every once in a while injecting these steps where you fit a parabola to 3 of the points and attempt to just leap directly to the bottom. And if the function's smooth enough or kind of looks like a parabola, that's going to get you a lot farther. And there's a couple conditions for just cutting off the jump. So I took a stab at converting this. This isn't, I still wasn't on this like bandwagon I'll get to about code as really amazing communication. So I took a stab at it. I filtered it. I have a lot of great comments. Like what I produced is better. It's a lot more understandable than what came before, but it's not great yet. It's still source code and someone's still going to copy it. And it's not going to do the job of code as communication. So I came out of this, kind of bummed out. Like code is communication. What seems to be happening though, is people serialize their ideas into code. And because the code can run the idea, the whole literate side of things, the fact that this is communication, you don't have to bring that along for the ride. So the code turns into this alien thing, this like black box artifact that works, but is not really available for introspection. And I think what's so beautiful about these fields is that they can teach us how they work. And the ideas here are quite simple, this jumping to the bottom and hunting like a scared rabbit. And when you get them, they teach you new ways of looking at the world that you can branch out from. So I left a little discouraged, but hopeful about the larger program. Okay, so another example of this sort of thing, you go another page later, and I was baited again by, the definite integral function. SCM utils includes a variety of numerical integration procedures with buzzwords all through. And this is just a tool you need to do the physics. It's not addressed in its own way as something really powerful. So I got baited again. We'll skim through this next thing because this absorbed much more time. This is much, much harder. But at this point, I was kind of like a warrior. I became a spiritual warrior for code should be able to communicate itself well. And I know it's possible. And I want to figure out how to do a better job of this. So I found, again, just a beautiful paper by Sussman again, where he goes through this idea of definite integrals. I'll say what this is in the next page. And sketches out this amazing functional Lispy approach to this. It's incredible. Like using the Streams API, you get this thing where the ideas are so clear, but it's not, because he didn't have to. This paper is not baked into the library that has survived. So I guess very shortly, the idea here of a definite integral is I want to find the area under some curve. I can do this by chopping the area up, the x-axis up into rectangles, and picking some point on the curve to anchor the heights of the rectangles to, and then adding all these up. And I can go subdivide and take more and more rectangles. And the more rectangles I take, the more accurate I'm going to be. So, fast forward through a month of my life. It's kicked off an incredible detective hunt where I took Sussman's paper. I went a lot farther with it. I can't show all these Wikipedia references, just sort of cryptic things that were out there, describing little hints of how things related. It turns out that all these ideas really are linked by this one simple idea of a tableau, let's call it. So again, like I may be committing the same sin that Sussman did, but let me sketch out for you quickly just this unifying idea. The idea is these indices here refer to guesses at the integral. So the integral here, let's say one guess is I cut this curve into 2 or 4 blocks, just like in the blue. That would be my first guess. My second guess, I cut into 8 blocks. Let's say I cut the size of the block in half. So it takes 8 to fill up the range. I go 16, I go 32. Each doubling is going to get me a better estimate. There's this beautiful thing you can do where if you take those estimates, if they don't have to cut in half, like I said, but if they just get a little better each time, you can make this tableau. And what the tableau is P0 would be the first thing. P0 and 1 is I'm going to fit a line between the estimates for my first 2 values. So a polynomial with 2 points. P0, 1, 2 is I'm going to fit a cubic between those 3. P 0, 1, 2, 3, I'm going to fit a quartic and so on. And if your values that you're putting into this function of the estimate, like the width of the cell, gets smaller and smaller, it turns out if you fit a curve to them, you can do this magical trick where you just say, what would happen if the width was 0? You can just extrapolate forward and you'll get a pretty good estimate. This is called the sequence acceleration method. So he shows this in the paper with a very specialized thing called Richardson extrapolation. It turns out there's like all sorts of extrapolation methods that fit this tableau. So if you get them into this form, then what happens is all these Wikipedia articles, there's all these methods for definite integrals. There's Simpson's method, there's Simpson's 3/8 method, there's Milne's method, Boole's rule. Let's keep going. Romberg acceleration, the midpoint method, the trapezoid method. And they are all just this idea. The Milne, Simpson, Simpson's 3/8, they're just columns of this tableau. So what that means is as I go from P01 to P12 and so on, I'm getting successively better accelerated estimates. Remember, 0, 1, 2, 3, 4 is my take 4 slices, take 8 slices, take 16. So if you go down the first column, you get the trapezoid method. If you go down the second column, you get one level of acceleration of the trapezoid method. That's called Simpson's method. And what that means visually, geometrically, is instead of fitting like a flat little, instead of fitting a trapezoid, which is a line, you fit a quadratic. And Simpson's 3/8 is a little better. And then Boole, I think, is the next one. It's the second column here. I'm going to get the, Boole's the second column here, and so on. So Romberg integration, this other thing you find is just the first row of this. And so all this knowledge that collapses to these simple little ideas. And what we have here is at the end of my like big journey for this, and at the end of Sussman's paper in a small level, the goal I had was to create sort of a workbench where the workbench is covered in little tools and the tools can combine in powerful ways. We're already all sold on that from the Lisp and Clojure world. But these are the tools of numerical methods in physics and science. And the thing I wanted to add was that the tools should be able to tell you how they work and explain themselves in a way that is like intimately tied to their implementation. Here, physics happens to be this area full of beautiful, like visually representable things. So I'm not quite there yet with this work, but the goal here is to have each of these methods just as you scroll through these successively better estimates down one of the columns across, just show you what they're doing and teach you. And so I'll say more about that in a moment. But you know, the beauty of breaking stuff into components is, I mean, there's no name for the fourth column. You know, I wonder, is that it's Jordan's method? Who knows? Like, there's no name for another obvious idea is, what if I go across a row and then when I hit something pretty good, like once I hit my first 4 points, I go down. Like, these ways of just walking around like you're cruising around a maze. There's reasons you can't go too far right. But it's all just so obvious to play with. It's incredibly difficult with the original Fortran implementations to play like this. Like, I can go write this at the REPL now and just mess around. But the original stuff is very, very tightly hard-coded in the name of performance. But performance is really, really good now, just out of the box. And so I think we need to ditch this idea a little bit and really package our ideas in a way where they have their own life support systems. So this got really turbo. Like, I effectively wrote a book on functional numerical methods. The book is the source code library. It can't animate itself yet. It's still a separate thing from the code. So we'll talk about what to do next about that. Okay, so I think this is like really messed up and troubling that I had to do this. And the reason why is code really is its own communication vehicle. But someone else had already figured this work out and serialized it into code. And following this trail was possible. I think it was easier than just following math and just following, there's a lot more culture associated with mathematical notation. It was easier, but there's no incentive to do the work to really package things in a way where the ideas can live on their own. And I was just struck by the sense as I did this work that there's very few people that really understand how a lot of these core numerical methods that a lot of our physics runs on are implemented. And it's an even bigger story with a full computer algebra system, like what Sussman's built underneath these 2 textbooks. There are very few of these. They're not explained well. And the most recent work on them is decades ago, but we still rely on them for all our work. So, okay. Jonathan Blow gave this talk called Preventing the Collapse of Civilization. He's the one who pushed me to take this far. His talk is about how you can look at many complex societies in the past that just get to a stage where things are just a little hard to do. It's a little hard to build the canals. We forget how to do it. And that knowledge does not keep itself alive. Up till now, and it's been better, of course, in the past century, but this knowledge of physics and numerical methods, these are things we keep alive as a culture by communicating them. We're still almost in like an oral society where if we were to stop teaching this stuff for a decade or 2 decades, the question is, could it bring itself back to life? I think it could, but it would take far more work than it needed to. And only because we have machines that can run the executable implementations of things that we've tried to get locked down so far. So I think I still believe in code as communication more than ever. The reason why now is a particularly amazing time for this is that code in the past, in Sussman's pitch in the 80s, was just an alternate communication vehicle that you could execute on a machine. But in 2020, the code can show itself in these incredible visual environments. JavaScript has just off the charts, unbelievable rendering engines. There's 3D animation libraries everywhere that are just begging for physics. Like, I think we have this chance to sew in a lot of our scientific knowledge, like rather than emitting these things as PDFs that are about humans talking to other humans that could have lived 300 years ago. I think we need to be in a world more where we focus on emitting ideas in a form where they have their own life support. These things need to make it across time. And we don't need to last forever, but they need to have a longer half-life so that while we figure out how to talk to each other about this stuff and how to encode things for a long term, the ideas can explain themselves when we do cover them again. So I think Lisp and Clojure, just in closing, like a little hint of the stuff I'm working on. Lisp and Clojure are super powerful here. This is like an impenetrable physics thing written in Lisp. Totally works, but understanding this is still really hard. It's a little easier when you realize that Lisp can generate its own other representations. So we can have Lisp showing off math. What's even more powerful is the Lisp generating math, but also powering a simulation like this. Like, this is actually what this code means. These are the equations to go tick time forward in this thing. And this right now this is like a setup you have now with Jupyter notebooks. What Lisp and Clojure give us through this unique ability to run on JavaScript and the JVM is I can have a software package that when I open a browser page, this is all just happening. Other pages can depend on these elements here, like code elements, and one page is another, just a dependency as if it was in the library. We have a base here in our language we all love where we can build something closer to Wikipedia, but full of executable, beautiful things that know how to both explain themselves and run themselves and represent themselves in a way that is shareable and is not just trapped in particular notebooks. So I'm working on this project called the Dynamics Notebook Project. Like, we're trying to modify this, this website you may know called maria.cloud to host all of the stuff that makes those books work. It works now. We're going to try to get it out in the next couple of weeks, actually running, so that you can play with some of these ideas. But again, this metaphor of the metaphor I'm aiming at here is imagine that when you go to learn something or you're exploring physics with these textbooks, you're in a workshop full of tools, beautiful planes or things like this. These tools are hundreds of years old. A lot of this stuff has settled as far as the ideas go. But when you pick one of these things up, it can teach you about itself, tell you about its history, tell you how to use it, or you can ignore all that and just get to work. So I think that's my pitch now is, yes, literate programming has had a lot of trouble in the past. yes, not everything needs this sort of archival treatment, but I think we need to invest in tools that will allow our ideas serialized as code to bring their own life support systems along. Yeah, we hang out in the Zulip or the Clojurians channel. This work's pretty young, but and we didn't have much of a chance to cover like actual physics examples here. So if you're curious about this and if this has sparked anything in you, like please come chat and write me. And yeah, thank you.
Many thanks, Sam, for the talk. We essentially we are. You can remain online. I'm going to call Santi back on. I believe he can unmute and control. Maybe we stop sharing. Thank you. And let's see if I can. Yeah, fantastic. Santi, can you try to speak for a second, just because I'm not sure.
Testing. Can you hear me?
Yeah. Thank you very much. Fantastic. So that is working too. So this is like the little session that we have after two talks, where we give the opportunity to people to answer questions. As usual, like a few channels to do that. Raise your hands here in Zoom, and you're gonna get the microphone and ask the question yourself, or put it on Discord. We have a specific channel for the Q&A. So because the other two, probably there are questions already, but I'm not able to filter them out easily. So if you have any questions from like the specific speakers chat, please bring them over into the other channel so I see like a clean situation if possible. All right, so I have a first question for Santi coming up. You touched on the problem of generating test cases beyond the trivially simple. Realistically, you have records of dozen fields, each of which has an obstruse composition. Is there a quick and easy generation?
I'm reading the message in
go ahead.
Discord. The quick and easy generation is more or less what spec does out of the box. It's such that where you have a generator and it tries to filter out the ones that satisfy that predicate. The thing that my that Piggy Whittle Piggy introduces is kind of a small, not necessarily DSL, but make it a little easier to include the higher order combinators like fmap or bind. Because most of the time fmap will probably do, you don't need to go as complicated as bind, but it allows that kind of interaction like at hand, rather than having to potentially like write a generator separately, then remember to always add it in your overrides or to attach to the spec. It tries to do the easy part rather than while the simple parts have been covered by test check or spec.
Thank you. I'm gonna give the microphone to Edward here on Zoom for another question live.
This one's for Sam. I just wanted to head off by saying thanks for the talk, because it's really heartening to sort of see people take Sussman's thesis and sort of take it to the next level, so to speak. I've sort of managed to abstract the sort of the sort of takeaway that you've gotten from Sussman's work, and I've been trying to push it on my physics friends who work in computational physics. But my question for you is that I've gotten some pushback in the sense that they don't think that their programs are complex enough to justify the benefits of an immutable language, or what Clojure can bring to the table. And you kind of sort of hinted at that with the sort of interactive elements of Clojure that could make developing these mathematical models more sort of explorative and easier. But I was thinking if you had to like sit down with a Fortran person, right, and actually sell them on this, like what tack would you take?
Yeah. Okay. So correct me if I get the interpretation wrong a little bit, but I've heard the same pushback. Of course, I think there's people really like their tools, and I think this promise of, okay, oh, yeah, hey, just get your stuff in code and it's going to make life so much better has been around for a long time. So we're not selling to an audience that has not heard this before in different ways. Yeah. So I mean, big prior art in the physics community, these physicists I work with, is Mathematica. And Mathematica, it's interesting to hear you say your comment about, I mean, Mathematica has a position as a thing it's Lispy, it's functional, and it really sits as a workhorse in a lot of theoretical physicists' lives. But I don't think I think it's quite relevant that Wolfram wants this to be a closed ecosystem. I think that I have tried to write Mathematica libraries that you can share, and it's exquisitely difficult, or I'm exquisitely bad at it. I mean, I think friction is really powerful here. The reason you bowl through is if you know something great is waiting on the other side. My hope is that if we have a few like examples that are truly shareable and composable, and you can be reading someone's paper and actually just, I mean, imagine a paper was a dependency in another paper instead of just a reference that you have to serialize through a Google search. I think there's going to be a small group of people that are very into this at first. Folks writing textbooks who just feel the pain of footnotes. I think it's going to take a bit of critical demo mass to convince someone who just has not played with this stuff before.
Yeah, it's kind of funny you mentioned that actually, because the second I started trying to sell Clojure, he came back at me with, "Oh yeah, my dad works in chicken scheme, so I've been hit with this for the past 25 years."
Yeah. So, and maybe we're early, but like it's gotta. I'm going to pretend and be an optimist and get something running.
Well, I mean, yeah, like there's a historical perspective, right? Because, like physics as a field has existed for 500, 2,000 years, whereas lambda calculus is 80 years old, maybe.
Mm-hmm. Yeah, that's right. I don't want to take up too much time I want to pass it back in a moment, but I think that's right. Like these are both very young subjects, but they also like, for things that are settled and things that have this beautiful, like composable nature behind them, I think these are the areas where it's possible to make a good sell with great tools. Like what Sussman's built for classical mechanics, you have this functional language, you have this incredible automatic differentiation. There's amazing stuff in there. And it all just works beautifully. And so he can show off as a demo to someone who's familiar with the math, how you can just encode the math and theorems pop out. It takes a long time to get at. And they're beautiful and visual, and people remember distinctly the like years it took to get up to speed to run those simulations in their brain. It's a much harder sell with a newer field where everything is kind of vague and muddy anyway. So the contrast is not as stark. That's how I've been thinking about it anyway as a pitch.
Thank you, Edward. Thank you, Sam. I'm gonna take another question for Santi, and which is one I would probably expect, given that we are talking about spec. So for several years, we have delicately put one toe into Clojure spec alpha, while Reach worked on replacing it with a permanent programming interface for specs. Alpha being alpha, is any investment in spec alpha going to turn to dust when spec 2 comes out? What are your thoughts on spec alpha versus spec 2?
Yeah, I think that's a great question. I think, I'm also kind of wondering a lot, but, the thing I look at, there's a lot of, an ecosystem has been built around spec, projects like Spectrum, spec inference, spell spec, and a bunch of other spec tools and whatnot. A lot of that has been like synthesized to like a project like Molly. So I don't think, a lot of people in the code bases have spec 1, lurking in there. So I don't think it's going to go away anytime soon. And when spec 2 does come out, I think there's an intention to have a kind of transition process, some sort of layer to move those spec 1s to spec 2. Where Piggy sits, I think, could be helpful in that you could test break-in changes across spec 1 and spec 2. So hopefully it will give you some confidence moving off those specs. I think waiting for spec 2 to like use any specs, I think you're missing out on a lot of cool, interesting things. And the process to move into spec 2, hopefully, I'd like Piggy to make that at least a little less painful.
Cool, thank you. Another question for Sam. OrgBabel was supposed to enable so-called reproducible research, academic papers with embedded code that you could rerun to generate the paper's chart and graphs. But civilization is collapsing anyway. What went wrong? Can we blame the culture of science to slow embrace technologies that could make science easier for the masses to understand?
Yeah, this is a great question. I'm a big Emacs user, major fan of org mode. The first thing and there's so much history here. I'm of course sensitive that I know I'm going to give a very limited perspective on this. But when I build tools for myself, org mode feels amazing and really gave me my first taste of like literate programming. I've done all that work I showed. Well, I didn't show, but with functional numerical methods was built in org mode. And I've studied a lot of libraries that have used this. So if people don't know, Emacs is full of amazing stuff. It's kind of you write in what feels like a notebook. You can embed source blocks. You can write things out of order from how they're implemented and embed things. It's really beautiful, but for me, at least, it encourages this style of I'm writing a finished product and it emits code. And that's not really how we like explore and work. So I find that a lot of these notebook solutions that are out there, they allow you to produce beautiful stuff, but people tend to make a discovery. And then finally, it's like making a notebook is like publishing a paper. You sit down with a blank page and you figure out how to make this artifact that shows off your idea. But the thing isn't like, you can't play with it. You can't take it and rip it apart and remix it. And libraries I've put out with org mode, people don't want to mess with the file. It feels like they're editing a book. They want to mess with the code and then have that come back. So I think one conceptual flip here that I'm not sure org mode gives me the tools to work with is I just want code and I'd like to be able to tell different stories about the same code. That picture I showed of all the graph of physics. I think what an ideal book or presentation is just one particular journey through this dense brain graph. And behind each of these function names is like a whole story, but a field or a course in numerical methods is just a path through that. And so my experience with org mode anyway has been, it's really beautiful. It lets you do amazing stuff. But the mindset is I already am kind of making a linear thing and producing it. And I really want like just a networked thing of tools that I can assemble and have writing and comments share around. And Wikipedia allows that to happen. Roam Research allows that to happen in tools like this for text. They're really beautiful at just ad hoc slicing and dicing and mixing. And so one way to frame this is I just want code to be able to play in with those same abstractions, to be first class in an environment like that. I think that would be a fundamentally different thing. I just want to find out. And it may not be though. It may that this may all be just a new org mode that is interesting to some people. So I can't tell. So I'm just going to try to figure it out.
Well, I see another question for Sam is regarding his potential inspiration of your work from Brad Victor. Anything about like influential in that?
Yeah, totally. Brad Victor is just so. If you haven't seen Brad Victor's work, Brett Victor is this exquisitely sensitive, wonderful man who has he as in his words, he lives his life based on this principle of, let's see, I'm going to flake on distilling it exactly like he would. But his principle is that there should be effectively no delay between the feedback from some creative person's interactions with an environment and what they get back. So you go in and you can just be like densely connected at the brain level. And if you look around, like we're dealing with tools all over the place that don't let that happen. So he has this thread of work for explorable explanations. He's got this lab in Oakland called Dynamic Land, where he's turned like an entire physical room into a space where you put down a piece of paper and that just becomes a display. I'm totally inspired by his stuff. One thought when I ported this to JavaScript was that like this little notebook could be a front end for like animations that get projected by his system. I think a big takeaway from his thing is whether you think his room is great or not, or his particular things he's doing. And Sussman says this too. Like we don't have that many takes on how we can use code as communication and how we can interact with machines. And we're so early at this that he's inspiring because I find it really hard to come up with new ideas. Like I'm so in the rut of the way we think now that I had like one or two new ones, and I think he's got 10. And ideally, our kids are going to have dozens and hundreds. And I think computing is a really special thing. And someone like Brett Victor shows through his work that there's powerful magic out here that is, and it's easy to lateral over if you just kind of ignore all the noise happening in the field.
So I think I don't see more questions. Just pointing out that Alex Miller is with us in the chat, and he commented on the transition, like the possible process for the transition from Spec 1 to Spec 2. Just nice that he's around and he can comment on things. Yes, I don't think, unless you guys saw some other questions coming through the channel in the other two chats, I don't see raised hands. Is there? Oh, one thing I didn't ask, and sorry if I asked this at the end, but I gave Sam the opportunity to, and I forgot to do the same with Santi. Santi, is there anything interesting surrounding you that you want to share with us?
Oh yeah, I'm not sure if people saw the profile picture I posted for the Reclosure thing, but it's a picture of me at my favorite K-pop group's in-person concert, and it's K-pop groups tend to have these things called like light sticks, which you kind of turn on and shake around in the crowd, and it's just something that makes me happy and kind of wishes for concerts again.
Just post a link because I have no idea what's that about. I'll have to understand. All right, let me. I'll check once more, and to see if anyone has any more questions, and if not, we're going into like a pause mode for about 50 minutes until the next one. Okay. Please ping me if that is not true, but I don't see any other questions. So thank you very much, Sam. Thank you very much, Santi, also for like being brave, going live. It's more interactive, it's more risky probably, but thank you very much for your effort in making this conference a nice conference. Thanks everyone
for joining us for our time.
Yeah, see you for the next talk. Bye.
Hello, everyone. I am Jacob O'Brien, and today we're going to talk about BIF. So I've described BIF as a self-hosted Firebase alternative, but what
Hello, welcome back, everyone. So we are preparing for the next talk. Jacob is about to be on, and yeah, I can see him.
Hey,
Fantastic.
how's it going?
Hey, nice to meet you, Jacob. We just, with many of the speakers, I exchanged a few words, but it's, yeah, we didn't. And we never met, or we meet virtually now, which is, yeah, sad,
Pleasure
but
to have your acquaintance.
Yeah, it's good. Like, it's good. So, Jacob also had a workshop today, right?
Yes, for me it was last night, but yeah.
Oh yes, okay. Right, sorry. Yeah, I
for
see.
most of you, it would have been today. Yes.
All right. So how did it go?
It was pretty good. It was a little frazzled just because BIF is such a young project, and so when you get a bunch of people who all try it for the first time at once, bugs just come out of nowhere. So we got to do some debugging, so that was fun. But we did get a BIF app deployed in production. So that
Okay.
was fun.
All right. So now we are going to go backward for people who don't know about BIF and see what he's all about. And then maybe they will ask a few questions. Fantastic. All right, I'm going to share the screen and we'll talk later.
Hello, everyone. I am Jacob O'Brien, and today we're going to talk about BIF. So I've described BIF as a self-hosted Firebase alternative, but what exactly does that mean, especially if you're not familiar with Firebase already? So first of all, BIF is just a web framework, right? So it has all the parts you need to build a fully functioning web application, and those parts have been pre-assembled for you. On top of that, there are some kind of fancy features that I have implemented, which have been inspired by Firebase, and we'll get to that later. But then the third thing is also that BIF scope includes deployment. So after you've developed your web app, we want BIF to also, well, I want BIF to also help you get it into production so people can use it. So we want the whole process to be nice and easy. So the overall vision for BIF is that if you have some idea for a web application you want to make, BIF should help you get to the MVP stage as quickly and as easily as possible. But on top of that, as you continue to grow your application, BIF should not get in the way. We want to keep it simple. And later, in the last part of the presentation, we'll dig into how exactly BIF is designed to facilitate that. Anyway, now that you have kind of a general idea of BIF, I want to give you some historical background. So I have been doing a lot of Clojure web development for the past 2 years, and I've had a lot of opportunities to make lots of different little web applications, which has allowed me to experiment with different things, try different things out, find, what do I like, what do I don't like, blah, blah, blah. And by the beginning of, it was around the beginning of 2020, so almost a year ago, I had kind of bounced around all these different things and ended up on Firebase. So I was using Firebase for everything, authentication, backend, database, and found it to actually be quite nice. It was especially deployment and setting up, it's just so easy to get an application started, and I really appreciated the experience there. However, it is, a platform, and if you run into something, then you don't necessarily have a lot of leeway for changing the way Firebase works. And I found I was running into things. So it felt like this, like an 85% solution where, it helped me a lot to, get started and do a lot of things. But every once in a while, there's still just something that I run into and I have to kind of work around it. So by that time, I'd been using Firebase for a few months, and I had figured out this idea of what I want my ideal web solution to look like. And so that ended up getting encoded into BIF. So I decided to move off of Firebase, move off of platforms, and just use plain, boring VMs and kind of set everything up myself. And so here we are with BIF. And so BIF is intended to take as much of that work as possible and make it reusable. So a critical part is that with BIF, I'm not trying to make this, big, fancy, complete framework that solves every problem you're going to run into. All I'm trying to do is just make it so the work I've already done on my own applications is reusable. So if you want to start using BIF, this is taken from the Getting Started section of the documentation. And so all you have to do to get started is run this single shell command. And that will download the latest version of BIF and then run a little setup wizard thing to make a new project on your computer. And the main thing you have to decide is what project type you want. So BIF has two project types. So there's a single page application, and this includes ClojureScript, React, and all the fancy, Firebase features. And so this is kind of the full BIF experience. That being said, not every application needs to be a complicated single page application. So we also have a multi-page application template, and this is actually what my startup is using currently. And so this just uses plain old server-side rendering, so no React, no ClojureScript or anything. And there are a couple other questions you answered, but once you get through the setup wizard, it'll give you some instructions for running the application in development. And so once you start it in development and you go to it, this is what it will look like. So the demo application is pretty simple, but it also includes pretty much all the main features of BIF. So it's a very good tour of BIF to figure out, what features does it have and how do you use those features and experiment, but then also be able to then grow from there and change it into whatever web application you're actually trying to make. So let's just go through some of these and I'll describe BIF's features, some of them anyway. So first of all, we got authentication. So you can sign in, you can sign out, pretty simple. It works via email link. So there's no password. You just type in your email address, hit send, hit sign in, and then you get an email and you click on the link, and then you're signed in. Boom. Now past that, under here, we have a bunch of read and write stuff. And so this first box, foo, so you got a text box, you can type some stuff in, you can click update, and when you click that button, it will set the foo attribute on a certain document to the value that you typed in here. Excuse me. But it does this in a somewhat fancy way. So it uses what I call a BIF transaction. And the way this works, it's very similar to what Firebase does. So in BIF, you can actually submit transactions and queries directly from the front end. So you don't have to set up a custom endpoint to handle these kinds of things, to handle CRUD operations. What you do have to do is you have to define a set of authorization rules on the back end. So it's, for the most part, this is a list of functions, and they kind of define, what kind of data is allowed to be written to the database and who is allowed to write it and who's allowed to read it, those kinds of things. But once you set up all those rules, then you can submit any transaction from the front end that you want, and BIF will check it against the rules for you to see if it passes or not. And so it's very handy for, kind of tedious CRUD operations that normally you'd have to, set up a bunch of repetitive stuff. You can just eliminate all that boilerplate, and it's quite nice. Now, this next section here demonstrates a different way to write information, because you can also kind of go the traditional route and use a custom event handler instead. Or, you could also use a HTTP endpoint. But BIF sets up a WebSocket connection for you anyway, so might as well use that. But anyway, so the way this does the same thing. You click the button and it sets the bar attribute on some other document. And it does that by triggering a WebSocket event, and then on the back end, you take the data and you authorize it. You check who is this user who submitted this data, and then you craft the transaction and submit it to Crux, which is the database that BIF uses. So anyway, so the demo app demonstrates both ways, and so you can look at how that is done. Now, the last main feature that the example app demonstrates is query subscriptions. And this was kind of Firebase's original big feature. So as I mentioned a second ago, you can submit queries directly from the front end, but on top of that, BIF will notify you whenever the results of those queries change. So here we've got two different users who have signed into this BIF application. And so they have subscribed to all the messages that are sent. So whenever someone types a message and hits send, that will pop up immediately for everyone. And this feature is actually it was one of the big impetuses for creating BIF in the first place, because I was using Firebase, and then one day I had an epiphany, and I realized how I could re-implement Firebase's query subscription feature, but do it in BIF in a way that is efficient. And so it doesn't, as your app scales and things, you're not going to hit a wall, right? The trade-off of this is that the queries you can subscribe to are somewhat limited. They have about the same power that Firebase queries have, but they're not as powerful as like SQL or Datalog or anything. In practice, so they're still quite handy and useful. So once you have checked out the demo application a little bit, it has some pointers for files in your project that are good starting points. So you can look through the files, and I've put a lot of in-code documentation. So you can explore and see how things work. But the code also has links to the reference documentation, and that's what this is. So you can kind of go back and forth between experimenting with the code hands-on and then reading this page to get a deeper understanding of how everything is working. And once you have a web application set up and you want to try deploying it, we have a section right here at the end for doing that. So the first time you deploy, there are a number of steps you'll have to go through. Like, for example, you have to set up a DigitalOcean account. Again, if you want to use something other than DigitalOcean, that's not too hard. However, for the sake of the documentation, I just assume you're using DigitalOcean. So you have to set that up and set some config like your DigitalOcean API key, and there are a short list of other things you'll have to do. But once you go through all that the first time, deploying is exactly 2 steps. You push your code to Git, and then you run this command, and this command will execute some stuff on your server, which will download the latest commit from your Git repository, and then run that. And the whole process takes about like 30 to 60 seconds to run, and it can all be done on a $5 DigitalOcean droplet. So now you have an idea of what BIF is, what does it do, how can you use it. So I want to dig into this question of how do we make sure that BIF doesn't get in your way as your application grows, because that's kind of the hard thing about frameworks, right? Because frameworks, in my opinion, are not inherently bad. They're just extremely hard to get right. To contrast them to libraries. So libraries are easier to keep simple because they're all, they're separated from each other. So they naturally stay untangled. The downside is that now the work of putting those libraries together falls on you. Frameworks, on the other hand, we take all those parts, the little parts, and we put them together. And so there's more opportunity to make things easy. But now the downside is it's kind of like the same problem with, Apple iPod headphones before we had AirPods, right? Like imagine you have a nice untangled pair of headphones and you put them in your pocket and they just magically become this tangled ball of spaghetti. Like you don't even do anything, it just happens. And code is the same way. So you make a framework and you're not trying to make it complicated, it just happens like without you even noticing. And so the big question is how can you make a framework simple? How can you prevent it from getting tangled so that you can have the best of both worlds, simple and easy? And I think a big part of the answer is decomposability. When you're making a framework, you need to think about not just how are you going to put it together, but you have to think about how are you going to take it apart. Because sooner or later, someone is going to try to do something that you didn't think of. And when that happens, either they will be able to take it apart and do what they need to do, or they will have to fork the framework. And if they fork it, that is a failure. So we want to prevent that from happening. And so the question is, how do we make sure that BIF is easy to take apart without forking? And so we're going to dive into the code a little bit so you can understand how that works. So here's an example application. We've got a main function. So this is what will run when your application starts. And the main thing we do is we call this BIF start system function. So this is the main entry point for BIF. And so this function takes two things. So first of all, it takes a system map. And this mainly contains the rest of the code in your application. So we've got HTTP routes, and we have the authorization rules that we were just talking about a minute ago. And the second thing we pass in is a list of components. So a component is a function. And let's go to this next slide. Okay, so yeah, so here's the implementation of start system. So again, we pass in that system map and we pass in a list of components, and these are the default components that we pass in. And each component is a function. We take the system map, we pass it to the component, and then that modified map gets passed down to the next function. So each component function takes the map and does something to it and passes it to the next one, kind of like Ring middleware. Like if you imagine a Ring request, you're passing it through this list of functions before you get to the handler. It's conceptually, kind of like that, just threading a value through a bunch of functions. But once we have the final system map, we stick it in this atom so you can get to it if you need. And we also have this refresh function, which handles some things for REPL-driven development. So to give you an idea of what a particular component function looks like, this is the one to start the web server. So again, we pass a map. And since all of our configuration is in a single map, we need to use namespaced keys so that they don't collide. So we get the config that's relevant for this component, and we use it to start a Jetty server, and we return the system map. And we include a function that will clean up any resources that we started. And so to answer the original question of how do you take BIF apart, the answer is you just pass in a different list of components. It's just functional composition, or in this case, functional decomposition. Right, so you can add more, you can add your own components, you can take some components out, you can modify some components that we provide for you, whatever you want to do. And so that is BIF's main method of decomposability. However, that alone does not guarantee that BIF will actually be simple, because the components still have to communicate with each other. And so there's still an opportunity for them to become tangled. So in my opinion, on top of that, I think you have to have people who actually use the framework and who try to take it apart. Because when people try to take it apart, they will naturally run into the parts that are complicated. And then once those parts are identified, they can be fixed. And so I think it's to have a framework that is simple, I think it's those two things: a focus on decomposability and constant vigilance to actually make sure it really is simple. And so BIF is basically an experiment to find out, is that going to work? And I actually think Clojure is the perfect language to have a framework like this, because the community understands simplicity and it values simplicity. So I hope you all have enjoyed this as much as I have. And I also hope if you have an idea for some web application you want to make, that BIF can help that happen. Bye-bye.
Fantastic. Thank you very much, Jacob. So since we are like a little bit early in time, I wanted to see if there is anyone who wants to ask a question, either on the channel or raising their hands. We have a little bit of time, and Jacob is here online. Anyone? Apparently not, or I don't see any for now. Well, okay, prepare your questions for like the session later on. If nothing else, then yeah, I'll ping you back in about 9 minutes for the next talk with Robert and serverless full stack with amplified Clojure script. Thanks again, Jacob. I'll see you later on.
Yep, thanks.
Welcome to a talk on how a very back-end oriented Clojure team pivoted to building a sophisticated but very front-end UI-centric set of web apps and services. I'm Rob Berger, the CTO and SVP.
Okay, welcome back. So let's see, we are at time, so we can go ahead and start the next talk. So the next talk is by Robert Berger and Isaac Praveen, and is about like a story. It's one of those battlefield stories of like taking Clojure and creating an awesome application in production in a with very tight deadlines. So I'm curious to see what this all about, and I'm going to push it up live right now. And I hope I can keep my video on. So before, for some reason, it was over impressing on the talk. So let's see if I can this time without disturbing the talk. All right.
Welcome to a talk on how a very back-end oriented Clojure team pivoted to building a sophisticated but very front-end UI-centric set of web apps and services. I'm Rob Berger, the CTO and SVP of engineering at Omniway, and now an accidental UI lead as well. My co-author is Isaac Praveen, more commonly known as Icy. He's done much of the work that made this project viable, and is the one who really made the Clojure script and AWS Amplify sing together. So Omniway has been around for about 5 years now. We've developed several services with a focus on brick and mortar retailers. They all have in common the goal to allow these retailers to become more competitive to the online onslaught that they've been facing. Our most recent service was having great success by attracting international tourists to luxury retail stores. We did this by enabling US payments and promotions through WeChat and similar e-wallet ecosystems and applications. But then earlier this year, it all came to a screeching halt with the age of coronavirus. Our customers, the retailers, lost their customers and all the related foot traffic. So we had to come up with a whole new business model that would make sense in this kind of environment. The idea we consolidated around was to enable the retailers to reach out to their customers, sell to them, and fulfill orders from their stores via a live streaming commerce platform that we would build. A key goal was to make the adoption of the service as frictionless as possible. It had to be a pure web app, no app downloads, and our ability to bridge e-wallets like PayPal, WeChat, and others to retailer point of sale without any change to their point of sale would be a key to making this frictionless to the retailers. The one minor speed bump was that our team had no video experience and no front-end UI development experience. But we had to get this MVP out and start gaining customers before we ran out of money and would have to shut down ourselves. Because we had a very solid, experienced, and cohesive team, we did feel that it was possible. We have great sales, marketing, and customer support teams, and we have established relationships with some great retailers who were telling us that this kind of a service would be a great help to them. And of course, we had a very experienced and mature Clojure development team who were willing to take up the challenge. We'd all been working together before Omniway at several different companies, and we all worked together at Runa, one of the first companies to adopt Clojure way back in 2008. So how hard could it be to doing a couple of front-end centric web video apps? We came up with a design where there would be one web app as the dashboard for the retailers, and would run primarily on laptops and tablets for administrative functions, and on phones or tablets for the video production. And then we'd have another app that would be for the shoppers and would run primarily on phones. Again, the one requirement is that they have to be web apps and not downloadable native apps, with the reason being that we wanted to not have any friction for the people to adopt this. So the dashboard has two main functions. It has the event production side, which is where we create the production upstream video. This would take the webcam of the device, usually a phone, and allow the store associate to produce the live stream. This means that, on a software point of view, we had to get all the video stuff to work, handling all the video audio source, setup, formats, etc. We ended up doing this with a web RTC client. There also is event management during the event, like things like selecting the current showcase product and chatting with the shoppers. So that all happens while they're doing the live event. And then the other major component of the dashboard app is the retail management. This is all the stuff that happens after or before the event, including things like setting up the event, and then after the event doing the order fulfillment, payment, product catalog, and inventory management. Because we actually have to keep track of the inventory during the event so that we don't sell more than what they have in the store. The shopper app is used by the shopper or consumer. This is where we really had to make the app MVP look like a quality piece of software. The UI had to not suck, as consumers are pretty used to having a rather sophisticated UI experiences. The first several iterations that we did pretty much suck. But we're now at a point where our retailers are telling us it looks pretty good. So we really went from not really knowing how to do things to really starting to get the feel for doing UI. The shopper app has to present the live stream, chat with the retailer, spew hearts when they like an item. This seems to be fundamental to live streaming events. And most importantly, it must show the products that are part of the event, including showing the current showcase item, and then allowing the shopper to buy the products either while they're viewing the live stream or afterwards. Again, we try to minimize friction and make it as easy as possible so that they can select the product, select the size and color, and then either add it to the bag to buy a little bit later and add more things, or they can immediately purchase with PayPal. Again, trying to do that in a way that's as frictionless as possible. So this is a relatively complex set of web apps, and we need a backend to support this as well. Though we had experience with a lot of e-commerce implementations, backends, machine learning, all that kind of good stuff, we had no real front-end experience, and we needed to get the first alpha release out as soon as possible, like in 2 months, so we can get some customer validation and get an MVP out within 3 or 4 months. How can we do this? So the first thing is we decided we had to choose our tools wisely. Fortunately, Icy and myself had been experimenting with Clojure Script, Reframe, and AWS Amplify. We saw that there was something there that could give us a lot of leverage with Amplify. We assumed that the Clojure Script Reframe reagent world would make the UI stuff bearable, and we could avoid becoming JavaScript developers. Being able to stick to Clojure Script was the only way that we could take this team, which is really a Clojure team, and cope with this kind of challenge. Hopefully the folks in the audience knows about Reframe and Reagent. I'm not going to really go into too much detail there. Reagent is the Clojure Script library that makes it pretty easy to use React components for UI. It has its own state management compared to React, though. It uses kind of a reactive atoms approach. And it generally lets you think in Clojure Script and not JavaScript. And it uses a hiccup syntax to create the reagent components and interactions. Reframe is a more app-centric state management library, but it really works well with Reagent. You generally use the Reframe for all the state management instead of using the reagent reactive atoms. You still get the core reagent react mechanism that when updates happen to the database, to the Reframe data behind your subscriptions, only the UI views associated with that state update as well. So, the main tool we talked about is Clojure. This is a Clojure conference, so we figured it's appropriate. Clojure has been the foundation of everything we've been doing for a very long time, even before OmniWay. The big problem is that we were not familiar with Clojure Script itself or the JavaScript ecosystem, particularly for UI. We had looked at Clojure Script several times over the years for dashboards, lambdas, and scripting, but it always seemed like the ease of use was poor and the JS library interop was pretty hard. CLJS JS just seemed like a dependency hell. Didn't seem like a good way to go. But then as we were exploring the current landscape, we discovered Shadow CLJS. And this was a major breakthrough once we figured out that we should be really using this over Figwheel and CLJS JS. The easy ability to import node libraries completely changed the game, and the kind of support the author of Shadow CLJS, Thomas Heller, gives on the Clojurian's Shadow CLJS channel is incredible. Sometimes I wonder if he's an AI. I just don't know how he has so much time to answer a huge range of questions and keep putting together this pretty amazing software, which he does updates very regularly. I also put together a template repo that has all the basics to get CLJS, Shadow CLJS, reagent, and dev cards to work if you want to use that for experimenting or just getting started. So we got the ClojureScript basic tooling and the JS library integration down, but what do we use for UI components? In our early experiments, we had played with Recom, a component library that came from the folks who brought us Reframe. But even they say in their documentation, they don't recommend it for anything but desktop apps, and it's kind of got its own thing. And we knew we had to do stuff that was pretty fancy with incorporating JavaScript libraries, and it had to be mobile first. So we had to find something else. When you just start looking around, there's a lot of different ClojureScript libraries attempting different wrappers on different libraries and different UI approaches, but either they were like really old, like from 2016 or something, or they seemed like kind of one-off experiments, or we just couldn't really tell if they're going to really have traction. It seemed that Reagent and Reframe were pretty solid, and we felt very comfortable, but we were just kind of surprised that there wasn't any clear way to, in the ClojureScript world, to do UI components, and there really wasn't that many great examples that we could find. And then there's the whole CSS world, which seemed really kind of scary in a lot of ways. It seems like that was the key to a lot of stuff, yet that's its own whole world. So after looking at a lot of different GitHub repos and reading lots of blogs and going through some tutorials and doing several experiments, we decided to adapt React Bootstrapped as our primary UI component library. The main reasons were that it had pretty comprehensive library of components. It's based on top of Bootstrap, so it has most of the CSS working, and we could kind of start out ignoring the CSS. And we figured that if we really needed non-ClojureScript people for styling and things, we could get Bootstrap people. Though it turned out we couldn't really afford any UI people within the time frame we're looking at. So we slowly learned more and more about CSS and Bootstrap, enough so that we were able to evolve the Shopper app to look good enough, and to keep improving it at a rapidly accelerating rate along with our learning curve. There still would be some things that required getting dirty with JavaScript interop. For those times when we were stumped, these two tools that I have links at the bottom here really help. They allow you to supply a JavaScript block and get some form of ClojureScript back that would work. It wouldn't usually be code you'd want to put in production, but it would show you how to make something work, and then you can refine it to make it more Clojure-y. So the other major superpower that we discovered was AWS Amplify and AppSync. It has been the other major thing that's really enabled us to compress the development time and get out an early alpha and beta and then the MVP. I think it wouldn't have been really possible if we had done this in a more traditional, even a Docker kind of a thing. We've been using AWS for as long as we've been using Clojure, and we've done a lot of amazing things with it. But Amplify and AppSync has really been a breakthrough in terms of being able to rapidly create integrated front-end and back-end services with as close to serverless and no ops that I've ever seen. The first thing we discovered in our early testing is that Amplify gives you a complete and sophisticated authorization system where you do almost no code and get a full suite of state-of-the-art features, including all the UI So not just the back end, but also the UI components for doing all the things like sign up, sign in, sign out, password reset, even MFA and social sign-ons. And it's not just the back end using Cognito, but like I said, it generates the UI for you as well, with just very simple, almost no code at all on your part. And when coupled with AppSync, this kind of authorization can be used to drive a role-based and fine-grained down to the fields of the model of the GraphQL DB. So you get, just totally amazing authentication control or authorization control. And the other nice thing is that the Amplify AppSync toolkit does all the work of configuring your backend automatically. It does all the deploying and configuring of your DynamoDB services, which are the backing stores for your GraphQL, builds the tables that match your GraphQL schema. And it also supplies the GraphQL front end to handle all the API requests and do the subscriptions, the WebSockets, all that kind of stuff. You don't do anything to make that all happen. Same thing with the API gateway if you're doing any REST type stuff. And it also handles all the hosting of your static assets. And all this is deployed in a way that will automatically scale as your load increases. Yeah, when you're starting out, you can have a really small system that's very affordable. And it would be really hard to build something that affordable out of EC2 or even containers and Fargate. So those are the services that we're using. Amplify offers even more that we hope to eventually utilize. The list is here. I'm not going to go into them, but it's just some amazing stuff. And just this week, they made a major announcement of adding an admin UI GUI where you can do all these operations that today you have to do in CLI. You can do in the UI, in the web app, and they've also made it so it's a lot easier to do that for people that are not AWS centric. But we've been using the Amplify CLI to get things set up and then move that all into our CI, which handles keeping everything synchronized and up to date based on Git pushes. So that's fully automated as well. So Amplify is mostly about setting up all the services. AppSync is really an enhanced GraphQL service that allows you to specify the fine-grained authentication, lets you wire up Lambda resolvers to handle all the mutations, and of course, it drives the configuration of the DynamoDB tables that supports the basics of the GraphQL models, queries, and subscriptions. Subscriptions turn out to be fabulous to use with the Reframe, Reagent, React world. AppSync implements subscriptions primarily through WebSockets, so you have a permanent connection between the client and the backend. It also can use MQTT for other situations, more for embedded stuff. All this, though, is transparent to your apps and to your code. You don't have to worry about any WebSocket code or anything like that. You just specify what the client is subscribed to, and I'll show you some examples of the code shortly. For us, there was, though, still a pretty significant learning curve, as all of this was new, especially the GraphQL stuff. We'd always wanted to kind of start using that, but this is the first time we've dove into GraphQL. The nice thing was that we were able to get some great, but maybe not so efficient or scalable functionality very rapidly, like almost instantly. And then as we learned and ran into issues, like things like we weren't doing filtering properly, so we were getting very large GraphQL responses back. But once we kind of figured all that stuff up, we would learn incrementally, refactor, and improve. And the environment really enabled and allowed us to do that. So I won't go into too much detail here, but one of the great things is Amplify really is nearly no ops. I just want to show that you can go from nothing to a GraphQL backend with Lambdas just using the Amplify CLI. It easily supports multiple environments, like you can spin up dev, QA, prod, or even many dev environments. And you can easily move all this kind of configuration stuff to CI for automatic deploys and updates. As mentioned earlier, Amplify Auth gives you a complete set of login capabilities, including UI, that would normally be an incredible pain for you to do on your own. So after you set up the Amplify Auth using the CLI, just getting the Cognito stuff set up, this code shows you how by just importing this higher order component with Authenticator, you can wrap your Clojure application and have Amplify handle all the sign up, sign in, sign out, and lost password. It'll actually generate all the UI for you as well as the backend. So this block of code is the normal initialization code of a reagent app with just the addition of the with authenticator wrapper calling your top level reagent component. So it's that easy. Here's a quick look on how we put all together all the pieces. The front ends are just a single page apps running on the browser of the clients. It's authenticated via the API gateway Cognito, and we also have a custom Lambda that does the logic of the authentication. The rest of the app's backend is all through the AppSync GraphQL service. Clients send queries and mutation requests, and some of which result in subscriptions. Subscriptions feed right in as dispatched events in the reframe in the single page apps, updating the reframe app state, which of course then triggers the UI view updates as needed. External services may trigger webhooks, sort of like the PayPal backend or the Marqeta backends, as well as updates to the S3 bucket can trigger webhooks. And the results update the GraphQL DB, and any client subscriptions to that data cause appropriate UI updates as well. So it's reactive end-to-end. AWS Amplify AppSync supports several targets, mainly for mobile. It doesn't natively support Clojure and ClojureScript, so we had to create our own libraries to allow us to use ClojureScript with the AWS Amplify and AppSync. ICE did most of this work and came up with several libraries that not just wrap Amplify and AppSync, but create meaningful abstractions around them. The primary library is Amplitude. The GraphQL client component is the one that does the most abstraction. It makes it easy to combine queries, mutations, and subscriptions in ways that make sense to a reframe reagent application. Amplify also wraps some of the other Amplify services to make them easy to use from ClojureScript. We are expecting to open source Amplitude soon, so please stay tuned. It'll show up in Omniway Labs GitHub account. Ambrosia is an internal library that we use for dealing mostly with the GraphQL schemas. Refund is another primary library that we're hoping to open source soon as well. And this helps us deal with a lot of the boilerplate code we found when using Reframe. It also has some features that make it a bit easier to use Amplitude's GraphQL queries with Reframe. We'll describe a few of those features in more detail in the coming slide. Another library that we came up with that's still internal is the Clojure Lambda runtime. It's an internal library that makes it easier to use Clojure builds with Growl VM as the functions that we run on the AWS Lambdas as the AppSync GraphQL resolvers. So that's a major component for us. And then finally, Review was our attempt to create our own reagent component library. The original goal was to come up with a library where we could plug in different React components, with React Bootstrap just being the first. We're still using it, but it was not quite as successful as we hoped in terms of coming up with the right abstractions. I think a lot of that's because we just didn't know what the right abstractions were, and we're just still learning. In many cases, it ended up being easier just to use the adapted React Bootstrap components directly. So this is an area we're still exploring, and we're looking at maybe some higher level components that are more application specific. So I wanted to show some examples of Amplitude in action. We're showing some snippets of how an e-commerce shopping cart payment might work using Amplitude and AppSync GraphQL. On the left side is a snippet of a GraphQL schema. You can see the use of connection for forming the equivalent of joins between models. And in the mutation, we show how it gets tied to a Lambda function, in this case, the payment processor. And then we have an example of a subscription that shows how the changes in the cart flows back to a shopper's bag. Next slide shows in more detail. The front-end app calls this function, which will create the cart. Amplitude gets enough info from these parameters to form the actual AppSync GraphQL query. So Amplitude actually writes the query that will be sent to AppSync. The callback of the create sets up a subscription for the client to get updated when the cart is updated. notice that its action is to update the reframe state, which is associated with the appropriate UI views in the client app. Those UI views will update when the card is updated because of the subscription. If you remember, the schema defined a mutation called pay. This GQL resolve function we're showing here triggers that schema model's mutation, which has the mapping to the Lambda resolver function pay. The callback of this GQL resolve updates the client's reframe state, and which then, of course, causes the update of the cart view. The second function on this page, also called pay, is what's actually run in the Lambda resolver. So this is called by the Lambda resolver, and it can be it can have arbitrary business logic, like trigger or participate in the actual payment process, and then update or mutate the appropriate model record in the GraphQL DB. Any subscription to that model would get an update and thus update its appropriate UI views. And then finally, here's an example from the refund library that helps tie GraphQL operations with reframe operations. A very repetitive pattern is that GraphQL queries or updates will want to end up updating the matching state in the reframe appdb. So this function refin eliminates that repetitive boilerplate by using the keys passed in as its first argument as keys under a result set key in the appdb. So these first two functions take the result of the GraphQL operation, and their callbacks update the reframe appdb result set cart. Views in the client will know to subscribe to that path to get the updates, as we show here in the subscription. Refin has some other arguments that allow it to be used for a range of operations, cutting down several lines, extra lines that would have to be repeated for many GraphQL operations otherwise. So that about covers it for what we've been through. We'll be having questions and answers afterwards. Look forward to any that you might have.
All right, thanks, Robert. Thanks.
Thank you.
Is that?
Thank you.
I think that's an office, or like that's a room with a lot of stuff you can share there.
It's the IT crowd.
Well, it looks like a good place to work. Is there like Isaac as well on the line?
Yes.
Oh, cool. Let me see if I can just understand if I can connect, answer to questions, or I don't see him at the moment. I don't know if that should be the case. Yeah, I don't see his name, but I saw him before, so I'm not sure. Well, we'll wait for a second or two. But yeah, it's 30, like it's half the hour past the hour, so we can start with the Q&A. So this is between the past two talks. So Jacob with Biff and Robert and Isaac with how do you call it? Like it's a very long title. Do you have a name for the product that you built?
Visix, VISX.
VISX, okay, Visix, very good. So I'll start just with the starting questions about is there anything interesting in your surroundings? I think you're gonna find something, something curious.
Well, let's see. I have to turn this off here. So it's not my background as much as it, can it see? It's looking outside, which is not. Hold on.
There are mountain lions though.
Here we go. You don't see the birds that are normally there, but
oh wow,
I get to look out at this. So
oh wow, okay.
It's nice to not have to leave.
Yeah, you don't need any fake background there. You just
I was thinking of being outside, but
yeah, it's really nice.
Yeah.
Considering that
Yeah.
I'm sitting here the entire day, and you show me that. Very nice view. So you're quite on top of like a mountain. What is that?
So that's actually San Jose in the distance. Let's see, can I? Oop. Can't really see it too good, but usually we get some birds coming. We feed them stuff and get to watch the birds and bobcats, and saw a mountain lion once. A lot of deer. Well, that's Silicon Valley. I mean, we're right above Silicon Valley.
Okay.
So it's pretty nice.
Good. Nice. That's a very nice view. What about you, Jacob? Is there anything interesting you want to share with us?
Sure. Just a second. Let's see. So over here in my office, let's see if the webcam cord reaches. We have a little cat shrine. Let's see. You can't see. A little cat shrine. So we got a couple puzzles. Now, I myself hate puzzles, but other people in my family like them. So we got a couple of those. And we have, this is a little cat that I bought when I was living in, so I lived in Malaysia and Singapore for 2 years as an LDS missionary. And so in one of the little shops there, I bought this cat. This one's a little out of place, but we also have a cow.
Don't have a cow, man.
Yeah, other than that, let me show you my setup too. So I just recently, a couple days ago, got a nice new fancy microphone. I even have a little lighting set up so my face isn't super dark.
Nice.
And then of course, my beloved ergonomic keyboard, which you should all go in.
That looks like a keyboard you shredded into pieces. But if it works for you. So do I understand correctly? Icy is that Isaac?
That is correct. Yes.
Oh, okay. All right. I connected the name. All right. So you co-authored the talk with Robert, if I understand correctly.
We
all right.
Colleagues.
Okay. Same question for you then. Anything interesting you want to share? You don't have to, but if you want.
Oh well. So Rob is on top of the mountains. I'm down somewhere. So yeah, you could have seen me. It's right there. Nothing exciting.
All right.
Here.
Okay. No problem. So let me see. I'm gonna pull a few questions. Yeah, I saw them in both chats, so I'll try to compress them in a single place for you. The first one is for Jacob. Is BIF purely a matter of integration, or does it also provide unique actual features?
Yeah, so there are some additional features. On top of integration, there's mainly two things. So first of all is what I call the Firebase features. And so these are like being able to submit queries and transactions from the front end and using the authorization rules to enable that. And then also query subscription, so you can subscribe to data. To give a little bit of a deeper background into those like Firebase features, if you have read the article, The Web After Tomorrow, by Nikita Prokopov, it's kind of in that kind of vein of like trying to make it feel as if there is actually no backend, as if it's just the front end and you can interact directly with the database. Of course, there is still a backend and you'll still have to do backend code, but that's kind of the vein that those features are in. And the other thing is deployment, again, and that mainly takes a form of configuration for Packer and Terraform. Yep.
Okay, thank you. I mean, probably those questions, they've already been answered by you in the other chat, so sorry if you have to repeat yourself, but also for the benefits of everyone else, I think is useful and good. So Next one is about Amplify. So I guess Robert or Isaac. Great experience report. Sometimes the higher level AWS offerings feel a bit thrown out there, as if they might be withdrawn without too much notice. Unlike the core services like S3, EC2, and so on. Did you worry just before you bet on like the farm of Unamplify that it might not be around for long, like those services?
Well, so we haven't really had too much issue with. So let me step back, because when we first looked at Amplify, I looked at it over time, and it was very confusing for quite a few years, even really. I think that it had been out for a couple of years before we adopted it, and went through a couple mutations of its own. But it seemed like it really had hit a threshold where it was much more mature than right around the time we adopted it. And so I felt pretty confident that this looked like a major way that they were moving forward to. I mean, you can see from their point of view, this is like pretty fabulous, right? I mean, it really does lock you in. So you have to really adopt, Alexa's your friend kind of a philosophy. So, but other than that, I feel like the team, that I've met from there and stuff just online seems pretty into it. You never really know with any of these big companies, but I would say that this is going to end up being probably one of their main thrusts, because even like, in another way, this is another perspective of the web after tomorrow, right? I mean, this is like similar kind of a thing where it's designed for front-end developers. And that was one thing actually that kind of, since we weren't front-end developers, who wants to use that? But, it really is designed to make it so that you can concentrate on your front end and build a back end. So I think from AWS's even selfish point of view, they'll probably keep it pretty big.
Right.
Who knows?
And they also have a pretty active community. We're responsive.
Okay. So there's another question for Robert, but there's another one for Jacob. So I'm going to alternate between you two. So for Jacob, when you curate a framework absorbing N libraries, you also mesh their N respective update cycles. Yet people who choose a framework may be change adverse. How do you balance the interest of new users who want new stuff and all users who want stability?
Yeah. So I've got two answers. One is a theoretical answer and one is a practical answer. I'll do the practical answer first since it's easier. And the answer is I have not dealt with this problem very much at all since Biff is so young, and so it hasn't been a huge issue yet. But to give a more interesting answer, in general, I think that's kind of a strength of having a framework too, is because the work of updating libraries and seeing if there are any breaking changes and making sure that the work of integrating them, making sure they all still work together, then that kind of falls on the framework owner. So if you are a user who wants stability, then you basically don't have to do anything. You can just keep using Biff, and when you upgrade, we'll have figured those problems out for you. Now, on the other side, if you do want something newer, like there's a new version of some library that come out and it has a new feature you want, all you would really have to do is just in your project dependencies, just bump the version. So like if you're using deps.udn, it'll just use whichever version is newer. And fortunately, since in Clojure land, we have such a large focus on...
Your muffs are on. How loud is it?
Sorry?
I think this is Dan testing the microphone.
Okay, sorry about that. Okay, so let's see what. So yes, if you want the new versions, you can put the new version of the library, and that'll be upgraded. And since in Clojure, we have a focus on not doing breaking changes most of the time, I'm guessing that shouldn't be a huge issue. But if it is, well, then hopefully you can deal with it.
Okay, so have that next question for either Robert or Isaac. Very solid work on the new product. I'm curious, why did you focus on the mobile web app? Was it a better fit compared to a more native app, such as React Native? Or is it Clojure tooling less well configured for more native mobile development?
Well, one reason was a part of it was actually a top-level design goal for it to be a web app to minimize the friction of adoption by both the retailers and, more importantly, by the shoppers. One of the things that we learned throughout our kind of life cycle of working with e-commerce and stuff is if they have to download an app, you already lost like 40% of your audience. So that's the main reason. But I would say that we probably know even less about native apps than we would about the web apps in terms of a Clojure mobile type situation. I mean, another big win is, it relatively easily got, able to support Android and iOS with the web app without too much work. That's the probably main reason.
Got another.
Go ahead.
I've got another question for Jacob. Is it possible to use BIF with code that already uses a state management library like Sierra components or Mount?
Okay, so yes, it's totally possible. And it shouldn't be too much work either, because, so like I mentioned, BIF is structured into a list of component functions. So if you wanted to use some other library, all you have to do is just go through the list of those components and then, just do kind of a mechanical translation into either like a Mount component or a Stuart Sierra component. Now, I do like the way that BIF has set up its lifecycle management, because I think that makes it easier to compose and decompose different things. That being said, obviously, the other libraries for lifecycle management have a lot more features, whereas BIF says about 2 functions and 10 lines. So you totally could do it.
All right, cool. I have another question for Robert. You were backend developers. Did you choose serverless on purpose, or did you just fall into the serverless as a side effect of adopting AWS labor-saving features?
Do you want to talk that, IC?
Right. So I think it was a combination of both. So we wanted to keep components really lean, right? So the AWS serverless Lambda kind of allowed us to kind of build these backend services which are lean and just does one thing, right? And it fit in very well with the Amplify framework as well. I think it was, to answer your question, it was a combination of both. As backend developers, we felt kind of breaking up these into smaller lambdas was the way to go. It fit in nicely with the front-end framework.
That was one area where we were already attempting, even before the Amplify stuff with our other, we were kind of poking our toe in the serverless. One of the big issues is the, Clojure. If you want to use Clojure, is the startup times. And there's now been a lot of mechanisms that have, particularly GraalVM, has made that much more viable as well. So there was sort of a confluence of factors that have made this much easier to do with Clojure.
An additional question about testing for you. How did you manage to test all the components in a short time? Was it that like a challenge?
Yeah, so that's an area that I think we're weak on. Again, having kind of this rush approach and learning at the same time, I would say testing has been a sacrifice. And also, again, we just didn't have a UI, deep experience with UI testing. So that's something actually is a major effort to do next. Hopefully you'll have a talk on that sometime so we can learn.
Yes, I mean, there was like a testing talk, and there is another one tomorrow as well. Just general testing. There's one more question, I think, for Jacob. That was, and like he answered already, but it's probably interesting to relay on the wider audience. And it is regarding like the use of BIF of like a specific database, and if it's possible to decompose BIF using a different database, and how does it work? If I understand the question correctly.
Yeah, sure. So it is possible to replace Crux. So Crux is the database that BIF uses, right? And Crux, like every other part of it, is just it's just included via a component. However, Crux, obviously the database layer is used by a lot of other components too, and so you can replace it, but the work will be significant. Hopefully. I wouldn't say it's too much work in terms of like untangling per se, but more just re-implementing new features that I've added on top of Crux. The most significant one is query subscriptions, because you have to write a transaction listener, which will take a batch of transactions that have been committed and then convert them to some other format and do some things so that we can send the data to the clients. And it's doable, but it'll take more than 20 minutes, you know. So it's like, I want to make BIF, like BIF should be decomposable enough so that you can do that if you want to, although specifically replacing the database is not a huge priority for me personally. But if you want to, you're totally welcome to do it, and maybe even send a PR.
As a follow-up to that, are you able to use PouchDB, CouchDB? Would you be able to?
I have no idea, because I have not used those two databases myself, but you're welcome to try it, and I'd love to hear how it goes.
Okay, so unless I don't see like all of the chats I have available, there might be something in the Zoom chat, but that is the most difficult for me to keep an eye on. I don't see other questions.
There was one question in the Zoom chat that I think could be good to answer. It was, let's see, let me scroll up really quick. Okay, so. Okay, sorry, I lost it. All right, I'll just say it from memory. So basically the question was, you know, why BIF instead of other frameworks that perhaps already exist, right? And so I think the best way to think about this is kind of two axes. So one is what parts of the stack the framework focuses on. So if you envision, you know, backend and front end, BIF is primarily a backend framework with a little bit of code on the front end for syncing data. So BIF just handles like getting the client-side state in some atom, but after that, like BIF doesn't really do anything for you. So like the template app uses Rum, but you could easily use Reagent or anything else. So for example, one question that comes up sometimes is, could you use Reframe with BIF? And the answer is yes, you totally could. If you just take the client-side state that BIF gives you and then use that as your state atom for Reframe. I haven't done it, but again, if someone else wants to try it, you know, maybe send me a PR. The other thing is kind of the target audience. So BIF is specifically designed for myself, and I am a solo developer, right? And the needs, if you are, you know, working by yourself or maybe with one or two other people, you know, on small applications, trying to iterate very quickly because you're testing ideas and trying to find out what works, and your users are measured in the tens, hopefully, if you're doing really well. Whereas if you compare that to, you know, say you're leading an engineering organization and you're trying to keep, you know, a bunch of people working effectively together, the needs will be very different. So BIF is first and foremost focused on that solo developer use case, and just, you know, speed, flexibility in the beginning. I do also want it to be able to grow with you, but that's kind of I'll handle that when I get to that stage with my own startup.
All right. So we are approaching the next slot. I mean, you still have 10 minutes. Is there like any additional comments maybe from Robert or IC before we close? If not, we can take a small break before the keynote.
Just wanted to say that IC has been busy, and he did release the amplitude and refin as open source, and we can post it. I posted on the Discord, but we can.
Good to know.
It's basically an Omniway Labs. Omniway-Labs is the GitHub repo.
Thanks for the announcement. Another open sourcing live, I guess. If it wasn't before, I'm not sure.
So it's the he was probably working on it while he was probably working on it while we were doing the presentation.
Oh well. Anyway, if that was an incentive, then we're happy. That worked. Okay. All right. Thank you very much for your talks, for your answering questions, and stay with us. We are going soon into the last talk or the last keynote for the day before starting again tomorrow. All right. Thank you very much. See you in a bit.
Thank you. Bye-bye.
Hey, Dan, can you hear
Hi.
me? Hi, Dan. Let me check. I was just wondering if you have a way to turn your camera slightly down so your face is not going too low, because sometimes.
Okay, I'll try it. How's that?
Oh, that's much better. Like it's making you in the frame. Perfect.
I wish I had known about that sooner. Because I look like a midget in that picture.
Well, and now it's okay. So don't.
And I got the blackboard in too.
Yes, I
So
can see
we're all
that.
set. How do you like it? The picture.
The picture. Oh, yeah, the picture is fantastic. All these colors.
Yeah.
I brought my ones today, so I can.
I saw your your copies of the books.
Yeah,
Let me see what you got. Wow.
I got the basics, I would say, like
the little typer, right?
Typer, the schemer,
little schemer,
the seasoned schemer,
the
prover, and this. Oh wait,
that's two little schemers.
No, this is the little, and
schemer.
The other was the reasoned.
Oh, the reasoned.
Yes.
Do you have the yellow one or the purple one?
I have the yellow one.
Oh, good. It's the right one to have.
Good. Well, I didn't read all of them. I just started a few chapters here and there. But yeah, I'm allocating my time to do a good job in 2021.
Hi, Dan.
Hello. Who am I speaking with?
Jerry Sussman.
Oh, hi, Jerry. Hi, Julie.
Hi.
How you guys doing?
Fine.
Fine. Came to see you.
Do you like my cover?
Oh, yes. Well, I don't like the purple one.
The one you can't read.
Oh, the purple one was not our design. That's why we're now in the green and white one, which is the more modern one.
Yeah.
Yeah, what we don't like is things that where the contrast is
If you
too
can't
low.
read the title, it's a little problem.
Yeah, you can't read it at all. Actually, Alex sent newer versions, but I don't think they were used. Higher resolution versions, but they weren't used. But it's the same book, so it's okay. I just love the colors. The people at MIT Press really did wonderful colors for these. Yeah. David and I worked out the little typer just to give it a little bit of a different look, because it's about types. Yep. Really about types, as opposed to Little MLer, which is about ML. So, you know. Wow. Hi, Mitch. Can you hear me, Mitch?
I can hear you, but I can hear you many times over.
Is that too loud? Or is it repeating?
I'm hearing you at about a 2 or 3 second delay.
Oh, wow. I wonder why that is.
That's strange, because I don't think...
Hi, you just said hi, Mitch, again. Can you hear me, Mitch?
What can I do?
I'm going to mute myself, because this is Meshuggah.
Yeah, it's got to be. What can we do about this?
I'm thinking.
Renzo?
I'm thinking, because I don't have... I mean, I'm not sure anyone else is experiencing the problem, so it must be, I have to think about it. Because
I'm not hearing any echoes.
Yeah, exactly. So I'm in the same boat. I just hear fine. So I'm wondering what could be on Mitchell's side that could be like giving that kind of return. It might help. I don't know if Mitchell, if you have a pair of headphones, it might help to put them on and attach them to the laptop or computer if you have them, because sometimes that cuts the loop. That could be my suggestion. So we are about at time. We don't need to like we can delay a second or two if we need to prepare everyone for the chat. It's nice to see many faces showing up.
I will.
Hi, Dan. Hi, Mitch. Hi, Julie.
You
Hi,
recognize
Gary.
my blackboard? Do you
No.
recognize my blackboard?
No, where is it?
It's another screen.
Oh, there it is. Okay.
He's connected twice, I think.
Okay, I see dead Ann. Is that what it is? That the blackboard dead Ann? What does that mean?
No, there's no dead end. Oh, whoa.
DADANN.
No, it's all good. Dan, don't touch it.
I won't touch it. Trust me.
It's
I'm
just
not
labeled DADANN for some reason on my screen.
Yeah, I don't know why. What do you do when your phone screen is so big that you can't close it? I've never had this problem before. It's got a lock symbol on it, and it won't do anything except. Well, I'm going to have to take it out of the room then. That's it.
Yeah, that's a good option, I guess. It's a hardcore silent.
I don't know what's going on.
Okay, when Dan is back, Dan, I think. Do you think we can a little bit formally start it?
What time is it?
It's my 9 p.m. your 4 p.m. So
yes,
4:02.
then we should probably start.
So we should probably start. Okay, so my little intro is for those of you who maybe don't know Dan very well. I'm not going to do a monumental introduction to Dan. I'm just saying, I just want to say 2 words how this came around, because I think it's very nice to see I contacted Dan, and now magically there are so many other interesting people that I admire on the call, and that is the magic of inviting Dan, right? So it all started during a walk. I was listening to a podcast where Dan was in the podcast. It's a co-recursive, so maybe you might be interested in downloading those podcasts because they are quite good. And Dan was talking about the Little Typer book. He was introducing the book, and that is when I was thinking about potential people to invite to the conference, and the idea was who can I invite to give a broader view or a different perspective on the lispiness that we are all used in Clojure when we program in Clojure. And the reason why I invited Dan was because of his way off perspective on things, in the sense of being able to go back to the roots of our language and understand the basics and the roots of a few of the features that we are using every day in Clojure. And then I thought, how can I transmit this to the Clojure community, or the small community of people that are in this call today and on YouTube? And I thought maybe we should we should ask Dan a few questions and have him answer these questions regarding interesting concepts in functional programming and aspects of his research, and how he came about studying and inventing a few of those things that now they are they are implemented multiple times in different languages. Or those ideas at least are the seed of the implementation of many modern features in modern languages. So that is about it. In terms of Clojure, a couple of things I want to mention that they are going to introduce, then the official question I'm going to ask Dan first are things like laziness and the way we can use infinite sequences in Clojure. Has this deep root going back to some of the work that Dan did in the 70s. And I hope you can talk a little bit about that as well. And things like logic programming with core logic, a library that didn't make it into Clojure standard and into the Clojure standard library, but deeply inspired the Clojure community in other ways, such as Datalog, and Datalog made it into Crux, for example, or Datomic. So other products that we're used to are inspired by some of the working relational programming by Dan and Will. And I'm also interested in knowing how these things came around and how it comes that we get to know them today. So I'm going to start with the first question, but the idea is I have a few of them. Some of them came from the audience. Some of them will come from the audience. I'm pretty sure will diverge, and I don't want to follow the questions I have here. If I have to, I will, but I'm pretty sure we'll diverge in very interesting ways in any case. So I was saying that I found fascinating the story of the build-up of cons should not evaluate its arguments, which is the title of a paper that Dan wrote in 1976. And I'm fascinated by that story because it's essentially the story of discovering something simple and at the same time strange, why one should go about experimenting, creating infinite sequences and find something useful out of them. And it turned out that there are many things you can do when you do that. So I just wanted to start with asking Dan, how that idea came about and how it is that it got developed in so many interesting ways.
Well, if I can, before I answer your question, I want to thank the Clojure community for the way it welcomed Will Bird and I, basically giving us a giant hug when we went to the second, I think it was the second Clojure Conj in Raleigh. And I also want to mention that the stuff that's been coming out in terms of relational programming had a huge boost from a question by Stuart Holloway following our surprise talk for when we showed up at that Raleigh meeting. And also, I want to mention David Nolan, who built the system that we had developed. It was amazing. So I'm really happy to be visiting the Clojure world again. So thank you very much for your invitation. Now, as to your question, this is a book that most of you have never seen. Now, just tell me when you can read it, or if it's or not. Can you read the title?
Well, the big white title, yes, and then it's it's in French. Sous la direction de Robinet.
Yep.
Yeah. Well, programmation is definitely there.
Yes. So somewhere in this book, and I'm not going to go to the page because it's too much like work, but there's a paper that I wrote with David Wise that appeared in 1974. Okay, and I'm going to describe that, and then you'll get the idea of where the whole thing came together. Now, can you see me reasonably well? Would it be better? What happened? Would it be better to?
We can see you well, I think.
Okay, can you hear me well as well?
Yeah, all good.
Okay, so I just hit that button so I can see what I'm writing. So the idea was very simple, incredibly simple. Lisp had an operator called map, and you gave it a function. And we decided, well, we want to be able to give it a bunch of functions. Now, and then for each of these functions, though, we gave it a list. And the problem was when we ran this thing, so they're not paired up like that, but you get the idea. F on these, F2 on these, and so on. Now, these guys eventually ran out of values. They weren't always starting out at the smallest, at the largest size. So some of them were like this, and some of them were like that. Okay? Now, we invented a rule so that we could manage that. And the rule was called the guillotine rule. Okay, the guillotine rule said, everybody else loses their head when you end up running out of values. So is there any issue about that? Is that pretty obvious to everyone? Okay, let's say it is, hypothetically. So let's motivate why we ended up with this. We wanted something like currying. That tells you a little bit of how old it is. We wanted something like currying, so you could say lambda x map lambda x, let's say plus x3, okay? So lambda x plus x3 will give you whatever you're giving, and we're going to give it a value of 5. So that's standard, right? The whole answer is 8, and everybody's happy. But the reality is, I wanted this to be a bunch of 5s, right? Because we're in a map. And then if we had a bunch of 3s somewhere, maybe fewer, then when we applied this operator that we had, I think Guy Steele talked about this, by the way, in my 60th birthday party. But in any event, when we did the map here, we're going to need to use the guillotine rule. 1, 2, 3, 4, 5, and there's 4 here. So we have to use the guillotine rule. So the lists are going to come back with that, but the operator's plus. So we're going to end up with a bunch of 8s. Okay? Now, one day I was thinking to myself, wait a minute. Why is it I can only do these with 5s? I want to have bigger things than 5s, finite number of 5s, because I might have an infinite number of these lists, or an infinite number of elements in the list. But how am I going to get infinite numbers? Well, that's obvious how to do that. I want an infinite number of 5s. I know how to get that. Instead of an empty list, we'll just point back to it. Now we have an infinite number of 5s. Okay, so now we can have an infinite number of 5s and an infinite number of 4s. And eventually, we will know that somebody in here is going to run out of steam. Otherwise, we're in a lot of trouble. But eventually, we run out of steam, and therefore, we get some finite number of these things. As I said, the guillotine rule had a role. So you might just have a list like 1, 2, 3 here. So when we add them all up, we're going to end up with, well, you get the idea, right? It's pretty obvious at this point. This is 1974. We've learned a few tricks since then. So one day I was asking myself, well, heck, if I can have an infinite list of all the same number, why can't I have something like an infinite list of the multiples of 5? 5, 10, 15, and so on. What am I going to do? Well, as it turns out, David Wise and I, worked a long time with Will.
You're revising history here, Dan.
Yeah.
No,
So-
not many people know I actually invented streams, right? Yeah.
Yeah. So anyway, so this is what started it. That other relationship worked, and then we had been working on the result of having gotten a grant proposal. In fact, the two grant proposals came at the same time with both Mitch and David. So we were in business at that point. And then, so David and I were working on it. And our goal was to turn the processing of append to be imperative. Just take the definition, the recursive definition, and try to turn it into an imperative one. In other words, we wanted to use prog. But the reality was that in order to do that, we were building this thing up just a little bit at a time, going left to right on the append. It wasn't long till we submitted that we came up with Concha not evaluate its arguments. What many people probably don't know, however, is the title of our submission to the ICAL paper was on the constructors, the algebra of constructors. So we changed the title because we'd figured this thing out. And by the way, David came up with the memoizing idea. He said, you know what we can do? We can just put something in there, and then when we evaluate it, we can just plop in something into the car or the coder, wherever it came from. So David came up with that. It was really cool. I said, oh my God, that's brilliant. So anyway, let me just take a little moment here. So we were rolling. We got the thing to work. And how did we get it to work? And this is the God's honest truth. We had this thing called the Silent 700. We put the code into the Silent 700, which was both silent and extraordinarily old, and it used that rolled paper. Remember the rolled paper? And some of you do, I know you do. And then we took that and ran it. Now it was lazy, and we knew it was lazy, but we didn't know it was going to be lazy. And we're looking at the screen, and a parenthesis came out about like that, just a little tiny bit of a parenthesis. And we're looking at each other like, oh, darn, what happened? And then something else came out. And I have to tell you, that was one of the most exciting things I had ever felt. When some little other piece of information came out, I think we were doing like, I don't know, summing up a list of numbers. And then it came out, and I couldn't believe it. I absolutely could not believe it. And then it just floated along and then terminated. David looked at me, and I looked at him, and he said, wow. In any event, when it was all over, we changed it. We made a new title, and we called it, well, once we figured this out, we called the title Cons the Magnificent. But that's not the title of the paper. So one of us, and I won't say who because it wasn't me, came up with, let's call it something more academic. And I said, well, David, sure, let's do it. So it became Kant should not evaluate its arguments. And it was great. It was a wonderful thing. And I will say one other item about it, which is David and I went to first David had this brilliant idea to send a copy to James H. Morris and Peter Henderson. I don't know where Peter was, but I know that James H. was in at Xerox PARC at the time, so we sent it to him because they had a POPL paper in January. Our ICAL paper came out, I think it was in July. But David sent it ahead of time because I thought that they should know that we have basically had the similar result to their lazy evaluator paper in the second POPL. And we walk into the room and people are walking up to David and me and saying, Kant should not evaluate its arguments. It was a really great and emotionally wonderful experience. And then it turned out that James H. Morris spent most of the time during his talk on the lazy evaluator explaining what we had done. And thank you, James. Okay, did you have another question or no? Do you want me to just keep on going? Just keep rolling along?
Well, I always want to invite the audience to like feel free to raise their hands or like send them like a message to the channel, and when you like stop and ask for conversation, we'll relay maybe a couple of additional questions. So I don't see them at the moment, but as soon as I do, I'll
I just
see
added
one
a
that says
question.
from Will Bird to everyone.
Oh, okay. Yeah. Sorry. Go ahead, Bill. Will.
Well, since given who is in this call, I thought this would be a good time for a question. Dan, how did you learn about Scheme?
Well, in 1975, there was this remarkable little paper that Mitch Wand handed to me sometime in January, I think, of 76. He took it out of a satchel this big. I can't know if you can tell how big that is, and said, and he's going through all the papers he brought home from MIT, which is where he got his PhD, and he comes up to this paper and he says, Dan, I think you'll like this. The understatement of my life. Now, what Mitch didn't know at the time, that I had spent a whole hunk of time in CDC Lisp, and I was getting pretty good at it, but I didn't like it. It didn't have features that I thought should be there, and I didn't know what those features were. I know that sounds strange, but it's true. And I kept getting sort of upset that things weren't doing what I wanted them to do. The Lisp Lambda at the time had derived itself from the blue and white book, but decided they were smarter than McCarthy, etc. And they weren't, because they destroyed the evaluator with what they thought was cleverness. And the evaluator was itself the most clever thing ever. It had proper closures. Isn't that right, Jerry? Jerry? No? Okay. But it had proper closures.
I don't remember.
It does. Trust me. I actually ran the interpreter when I was at the University of Texas. And I put a trace in a member of like 3 elements in a list. And it came back, again, this I can't tell you, but it's approximately 1.5 inches of pages.
Mm-hmm.
And it had an error at the very back of it that said unbound variable T or F. I guess it was F. No, nil. It was unbound variable nil. And it was very interesting because 30 seconds later, I was running it again. Of course, it's overnight, because those were the days when you got to compute overnight. But I knew it would work because I just set up the initial environment with T gets T and nil gets nil. I'm pretty sure there were quotes on the second arguments, but I'm not positive. In any event, there's this statement in there that says, whenever you see a capitalized word, that means it's quoted. This is in M expression Lisp. That means it's quoted. So I didn't know that, and I didn't read it carefully enough. Typical way I read, and I spent a lot of money on paper. I didn't spend it. I just got a little bit of a lecture on wasting paper. And these are those big giant pages. You remember how those looked as well, I'm sure. Most of you do. Okay, so I think that's a good start. So where are we now?
It is a good start. So I'm going to ask
Like
another question. Yeah.
Wait, I forgot to tell you. So
yeah, what?
Jerry's and Guy's paper did it correctly. And I said, oh, this is incredible. I can now do lambdas. I tried to do it in my implementation of Snowball 4 while I was at the LBJ School of Public Affairs, which means it was in my last 2 years of being a professor. I'm sorry, being at the University of Texas. And it didn't work. So when I got it from Mitch, I knew I was in seventh heaven. And I've been there ever since. Okay.
So
Any
let me start. Yeah, I'll start with another question and see where we go with this one.
Okay.
So you told me that you never wrote like a line of Clojure.
Not a one.
The language. Yeah,
no.
That's fine. But for that matter, like you never wrote like a line of Prolog.
No, I never wrote a line of Prolog either.
Nonetheless,
I have books on Prolog, but
yeah,
not
just that. Not just that. And nonetheless, you implemented several like paths of different kind of Lisps or several paths of different kind of Prologs, and some of those Prologs became then Canron, Mini Canron, Core Logic, and so on.
Yes.
So, is it possible to write implementation of languages that you never write like a line of, except for
I did it all the time. I've done it.
Possible.
I've probably done it 30 or 40 times. Every time I read a paper that was in CAC, I'll give you an example real quickly. Jerome Feldman had a paper in CACM. Anybody remember the language name? It's not coming to me right now. In any event, it was all described in there beautifully. I said, well, let's just implement this, see what it does. So I implemented it in Lisp with the standard model that I always used, which is macros and functions and nothing else. And my macros, I think back then when Feldman's paper came out, but I'm not sure, but I think back then it was, conventional Lisp macros. But once I got my hands on Eugene's great work on hygienic macros, it was like a non-starter. It was just absolutely trivial to take any language and just translate it into it and run it. And I'm not talking about writing an interpreter for it. I love interpreters, don't misunderstand. But it's much more intellectually satisfying for me to write a small set of macros and a handful of functions. In fact, let me just tell you one little story. Dick Keyberts had a language called Marigold. And Marigold was using sort of a stream-like thing. And it had kind of other relationships in it. But he came to give a talk at IU. And when he spoke, he described what he was doing. This was a lot of years ago. And I said to him, you're staying at the Union, right? He said, yeah. I said, well, if you'd like to come to my house, we can implement your language tonight. Oh, that'd be great. I've never done it. And sure enough, we finished it. We got it implemented. But I have to say that I didn't do it perfectly because I couldn't think that fast. But the minute he left the house, well, actually, I took him back to the Union, it hit me what to do. And that was, in order to print all these streams that were coming out at the same time, the only way that we could have done it would have been by using engines. Well, at that time, we had already developed with Chris Haynes this notion of engines. So engines are basically machines like a car that you fill with gas. So one of my little stories that I tell people is, well, when you have an engine, you can fill it with gas and you can drive all the way to Martinsville. And then you have two choices because you're a functional programmer. You can fill it up with gas again, or you can get a new car and then fill it up with gas. So you can collect automobiles in that metaphor. Okay, and so what we said back then was that we wanted to have the ability to break up your computations into whatever size you want by designing a system that would give it to you. And that was a lot of fun, and there's a handful of papers, and it's in Racket, engines are in Racket, and they're fun to play with. But I needed them at the time, I didn't think of them at the time, and that would have allowed me to print exactly what he wanted for answers from all the streams that were coming out of Marigold. Okay, any other thoughts from anywhere?
Let's see, I'll just wait a second to see if anyone else wants to make a question. If not, I have a couple that came in by email. Okay, so I'll do one first because now I'm going to move slightly more into the future, like closer to where we are now. One is kind of a controversial question that I want to ask. And well, maybe it's not controversial, but it's provocative at least. So in today's world of corporate programming, we are mostly dominated by the imperative languages or the imperative paradigm. Some of us are lucky and they can work functionally, or they can work maybe with some good strain of object orientation, which is not easy to find. So I wanted to ask you, why does it matter today to understand some of the concepts we are talking about today here, such as recursion, infinite sequences, maybe suspensions, continuations? Why? Well, if you have to give us a message of why these things are important, what that would be.
Okay, so in very simple terms, if you don't understand what you're doing, being told what you're doing is wrong makes no sense. Okay? You have to have a start in thinking properly. And I remember when we decided in the scheme committees that we were going to require tail calls to be necessarily the way you implement tail calls that have no stack, basically. Okay, and all of a sudden you have all the imperative tools if you need them by just making a recursive call. Now that merges with higher order functions, continuations, engines, and a whole host of things that are sitting in Racket. And all of a sudden you have incredible powers. Not only that, you have incredible powers with macros. I mean, what the Racket community has added to macros is just extraordinary. It's not that I don't use them because I'm writing a little book, generally speaking. And when you're writing a little book, you are not teaching something that complicated as the current state, but the power of them is extraordinary. So when you have enormous amounts of power, and then with all the stuff that's already in Racket, you have an incredible, powerful tool. And not to know and understand that is just foolishness, as far as I'm concerned. And so when I think in terms of what goes on, I think to myself, it's a shame that these people don't realize that what they're doing is so much easier than what they're trying to do. That's my opinion. Anybody else have another one? I'm happy to hear it. Now, was that a two-part question? Am I missing that?
No, I think it was a single part question.
Okay, so I do want to go back to my statement about Clojure and I forgot what it was. Clojure and Prolog, of course. So Cynthia Brown was in the department, and she said to me one day, "You really ought to learn Prolog." And I thought to myself, okay, I'll do that. I'll get a book and read it. Or, oh, there was an article in CACM, I'll read that. Well, I couldn't make any sense out of it, because I always look for where's the lexical scope. Lexical scope to me is the most magic thing that's out there. And it was gone. It wasn't there. And I said, oh, I'll get around to this someday. Well, someday came, and I was able to take one other piece of information, which was had been invited to a workshop at Syracuse by Alan Robinson. And I didn't know why, but I decided I would go, and I went. And he took me over for about 3 or 4 minutes, 5 minutes, and said to me, "You should be using streams in logic programming." And I was so overwhelmed by the fact that I was talking to John Robinson that everything he was saying was like in another space, and I couldn't hear a word of it. I don't know if you can appreciate that, but if you knew me, you'd understand it in a second. But the reality is that it was quite a few years earlier when I went to Syracuse. And there's a little funny story I'd like to tell you. I was in a cab going from the airport to my hotel in Syracuse, and the radio was on, as people would do. And I heard the phrase, "Well, we hit 100 today, again." And I looked outside. This was in February. It wasn't the weather. Well, it was sort of the weather. They had reached 100 inches of snow that particular day. In any event, I didn't know anything about Prolog at that time. I didn't know what he was talking about. And I said, well, someday I'm going to have that chance. And someday came, and I decided I'm going to stop playing with logic languages as things that can do magic tricks, that super magic tricks. And I will work really hard on building a logic system that is super fast. Of course, I failed, but it was very clean and very elegant. And then I put this out on my class website, and when Oleg Kiselyov found out that I had written a relatively fast, it wasn't fast, but it was designed to be fast, system, I had written about 124 pages of notes, basically that I wanted my students to read, and Will actually was one of those suffering people. It wasn't well written. It was just getting all my ideas in one place. And so Oleg wrote me an email, and with about, 35 pages of email when I printed it. And it was quite a lot of information. So I got in touch with him. Well, I emailed him back, and then we started chatting. Not that kind of chatting, but, emailing back and forth. And I said to him, I'm not doing anything this summer. You want to join me in this quest, come up with a really elegant and simple logic system? And he said, sure. I said, okay. So next thing I know, we're on SourceForge, and he is writing programs that are from another planet based on my code, because he noticed that I was using the model where you have lists of values everywhere, and then you're unifying those lists against other lists in a more relational style. But what happened was that I was explaining this to Will one day, and let's just say he gave me a facial disdain like I'd never seen before. What he didn't know was that I was thinking of redesigning the whole system, because I had been starting to think that I could get by without these lists running around. And it wasn't that the lists were bothering me. What was bothering me was the 30 plus pages that Oleg had written. And to make it go fast, because that made it go fast. And I said to myself, after Will had given me this, I'll just call it a facial disdain, I'm not going into details. And I said, okay, tonight I'm going to throw away everything that is not relevant. And that didn't take minutes. And then I came to campus, and Will said, oh, let's call it Mini Canron. So Will actually named Mini Canron, and I love the name. I thought it was a very great idea. We used it, and I guess we're still using it. So those relationships have worked out very nicely. But in point of fact, I just love having people around me to work with, and somehow great things end up happening, fascinating changes. And you know about MediCanon, I'm sure most of you, and that's doing really, really well these days. And if you go to minicanron.org, you can see more things about what you can do with MiniCanron or with Clojures, with David Nolan stuff. Have yourself a ball. Any other questions?
Yeah, we have. Yes, we have one raised hand. I'll probably go with that because it's interactive. So Edward, if you want to make your question, and then I'll go with the chat.
Hi, I just wanted to start by saying thank you for this walk through the roots of Clojure. And my question was more sort of about the future. So one of the developments that we got out of Clojure was the sort of sequence abstraction and being able to treat all collections equally with map and filter and reduce and whatnot.
I love that stuff. It's beautiful stuff.
Yeah, it is really. And
I was actually at the talk by, help me, he's the one who started Clojure.
Richicki, yeah.
Richicki. Yeah, go ahead.
Well, I was just curious what your thoughts were about sort of what directions and developments we could and should be making in terms of how we structure our languages.
Well, you certainly can't go wrong if you look at the structures that are in Racket and in Haskell. Yeah. There are a whole category theory packages in Haskell. There's just nothing you can go wrong with that. But let me just sort of back up a little bit and talk a little bit about my philosophy of writing programs. Now, you know that they have to be little tiny programs. Otherwise, they don't fit in little tiny boxes. And I encourage everyone to try to understand the power of those really small boxes. And in fact, maybe we'll get a chance to talk to Anurag in the relatively near future. And we'll say a little bit more about that. But my attitude is basically map is complicated. Okay? Because I want to think about everything in the shower is the model I use. So if I'm writing a really complicated program, I want all the pieces in my head. I don't want to go running to a manual. Thank you very much, Jerry, for that. But I don't want to do that. I want to think really hard about certain aspects of things. And if you can do that, then you can mess around a little bit more. But everyone who has ever worked with me know that if you don't make them really simple, you're going to leave out way too many people from the table. And I don't want to do that. They simply don't. Okay. I don't know how to answer your question, though, really.
Yeah.
Can we use this moment to let me talk to Anurag at this point?
Sure. Is he on?
He's supposed to be.
I am here, yes.
Hi, Anurag. Anurag is one of my successful PhD students. Can I talk a little tiny bit about your little business?
Please.
Okay. This is not planned, trust me. I hate using that phrase anymore because it's lost a lot of credibility. But the Anurag got his doctorate, and then he had a startup. I won't go into the details of that, but then he started another startup. There's others in between, but called Paper Culture, which is a very cool thing. And you'll find that out when you go on the webpage. That's all I'm going to say. Okay, now, I would like for Anurag to explain the one book that was in that little table, if you saw it, that hasn't been finished yet. So go ahead, Anurag.
Okay. The book that Dan is referring to is called The Little Learner. Now, the title, hints at whatever it hints at. But I sort of want to tie it back to what Dan was just saying about having programs that you can think about in the shower. And, I sort of a few years ago jumped into machine learning and trying to understand sort of the new wave of deep learning and what's going on with it. And I don't know if others of you have attempted this task, but that whole field is monstrous. It's like hitting a wall of concepts that are so abstract, and the pedagogy around it is so weird that it is just, it's baffling how people even manage to understand what they're doing at the level that I think we understand how to work with programming languages. I sort of obviously went through it and, got deep into it. And then I meet up with Dan one day. We were at some event at IU.
We were at a real event.
At a real event. I was visiting IU after many years, and it was great to see Dan again. And I said to him, hey, I want to write a little book with you. And Dan said, yes, let's do it. And then he asks me, what is the book about? and then I explained to him how I felt that this whole field of machine learning and deep learning in particular is just a gigantic mess. And it is sort of impossible for people to understand it at this raw, intuitive level without putting years and years of work into it. And so we decided that we were going to write a little book for specifically for deep learning. And yeah, we're in the middle of that. The challenge of fitting everything into little boxes, the equivalent of a 5-line program that sort of builds it up, one function at a time, and really talks about how neural networks operate, how these monstrous systems actually work, but in a way that you can think about in the shower. Really. So that's sort of a current project.
Thank you very much, Anurag. I appreciate you explaining what I'm still learning.
Okay. That sounds amazing. And like when I heard about the idea, I said it's not possible that you're going to do the legal treatment to such a topic, but apparently you are succeeding in doing that.
So far it's looking good, I have to say, but we're not completely there yet. So
sure, I know Dan can be a little bit like sophisticated.
That's
Dan,
not the right word to use, but okay.
Dan, we are not seeing. I mean, it's becoming dark in your room, so you're going.
Should I turn on the light? I can turn on a light.
You can turn the light on. Yes.
Yeah,
so we can see you a little better. Yeah, that's much better.
There you go.
Okay, so I have a couple of other questions lined up.
Go for it.
Okay, so we are going into like teaching topic. What drove you? What drove your decision to go with the Socratic method of teaching? And was there a specific learning experience that impacted you in a positive way?
Yes, Lisp, first of all. Cond specifically. And there's this book, I'll just pull it out of the shelf here, that it's called The Little Lisper. I don't know if you can tell how thick something is from the screen. What happened? It's running late. Did I do something that scared it? Hello?
No, we can
How do I get my picture back? Oh, there we go. No? This is how thick it is. 64 pages long.
There you are.
When I was a professor of public policy, in 71 through 73, it was my job to teach them how to understand how to program, and I taught them Lisp and Fortran, and also know a little bit about operations research kinds of issues, and a little more things like that. And so we had to figure out ways to get people to understand. Well, some of the students in the class really loved the Lisp stuff. So basically they stayed another week. It was a summer class because I actually gave the first class at the LBJ school. But it was a summer week and we had a week off. And they said, can we sort of write a book about this? I said, yeah, let's do it. So we did it. Mary brought food. We worked probably till 10 o'clock or 12 o'clock at night, I'm not sure. And in 5 days, we had written the first Little Lisper. And in fact, if you'll permit me, I'd like to read the names off. I hope it's in here. Arthur Goldberg, Philip Blackerby, Robert King, David Walrath were involved in that particular week of work. And what I did was I would go from one blackboard to the next in the same room. They were separated by a rather long table, and write a question, and then I would go around and I would write the answer and just keep doing that. And one person, they took turns, would write notes, would write what I was writing. And the food, I couldn't tell you where it came from. I know that we'd started out with biblical characters, but decided that was too non-generic. But everybody in the world eats food. So we decided that would be a good data structure, a good whatever. And Khan became the obvious metaphor for the question and answers. But I'm not going to take full credit for that because I had a book on PERT, P-E-R-T. Don't even ask me what that stands for anymore, but it was done in a programmed style, but it would always send you to another page. It'd say, okay, you got it wrong, go to another page. And I thought that was, that's stupid. And then when I realized we were basically doing the left and right-hand sides of cons, it became obvious to me that we should be using con as the metaphor for each of the frames. Had a few mishaps along the way. When the book first came out, there were footnotes. There were only footnotes back then. But when it came out, the bottoms of the footnotes were at the middle of the page because SRA and I said, we want the cheapest book that the world has ever held in its hands, basically. And if you wanted to buy it at IU, I think it was like $3.50. But it had an interesting property that they had put the top page and the next page on the same page. That's what caused the footnote to be in the middle. Well, we got around that pretty quickly. And it turned out that the success, I'm sorry to use that word, but the success of this book had nothing to do with me. It had to do with the fact that you could open it and it would be a flat book. So when you were sitting at the key punch, which is what they were called, you didn't have to worry about it closing on you, which is what all the other books do. Anyway, so that's a little bit of the history of the Little Lisper. Now, one other little thing I want to tell you about is that once I'd gotten to Indiana, no, false. Once I arrived to Indiana as a person who was applying for a job, another person was there. His name was Ben Schneiderman. He had already done his interview, and I was about to have my interview the next day, but we were joined at the party. And Ben and I just chatted and chatted, and everybody left us alone. They didn't care that we were just chatting. And I think we chatted till around 3 or 4 o'clock in the morning. And we talked a little bit about the Little Lisper. And it was just, some typed up notes. And I handed it to him, and he ended up taking care of the rest of it. He named it. He went to publishers. He found SRA was very interested in it. I don't think he wrote the letters to the people, one of whom was John McCarthy, by the way. But he did basically everything. Next thing I know, I'm quite literally, very next thing I know is I'm holding a contract. I signed the contract, and then it arrives. And I was not happy, but turned out it worked out very well. Any other questions at all? I'm sorry if that sounds a little bit too, I don't know the right word, but I was trying to tell a story, so that's the story. Any other questions?
Yeah, and they are coming. So
okay.
Just a quick follow-up. When is... Sorry, just when is the when will be the sorry when
the arrival of the Little Learner?
Yes, exactly.
You're not asking the right person.
Okay, Anurag.
Are you still there, Anurag?
I'm still here. Yes. Soon. Sometime by next year, middle of next year.
Yeah, I'd say middle of next year is reasonable. Yeah. That's my gut feeling too.
Okay, that's okay. That was a big
but we
one.
do have 273 pages of PDF.
Okay.
Which means maybe what, 20 pages less. So we are moving along. These things take a lot of time. Each chapter takes quite a bit of time to make it simple. But that's our goal anyway.
Here's the next question.
Mm-hmm.
Are intellectual compromises and trade-offs positively necessary in languages for them to be good at solving real-world problems effectively, or are we just being soft on ourselves?
I want you to repeat it.
Yeah, this is interesting.
Okay. Yeah,
Our
repeat
intellectual,
it.
our intellectual compromises and trade-offs positively necessary in languages for them to be good at solving real-world problems effectively, or are we just being soft on ourselves? I think it's referring to something like Clojure, which is a pragmatic
Clojure is a great language. There's nothing wrong with Clojure. It's a great language. It allows you to do a lot of things.
And it's got this pragmatic approach, like, and maybe it's compromising on like a deep intellectual concepts to be pragmatic. So that I think the question is asking, is that a good thing, or should we like not compromise intellectually on our languages, programming languages?
Yeah, I understand the question a little bit now, but again, my philosophy is if you are trying to enter the head of your reader, which is all that I try to do, basically, with something deep and interesting, and that's sometimes debatable, but that's what you're trying to do, you have to do it with care. Okay, I know his question. And I think the same thing may be true of programming. You can, not everybody is going to be a category theorist no matter what. Okay, they're not going to take the time or whatever it happens to be. And then after they write their programs in category theory, there's even a smaller number of people who are going to be able to deal with it. So you have to find a compromise no matter what. Okay, that's my gut feeling, is you have to find a compromise in both the real world programming and the more mathematical world of programming. So you're not really being soft on anybody, as far as I can tell. I think that Clojure has picked a nice compromise. Being able to have the maps and stuff is really good. But if you're trying to write about them, it's a little harder. That's all I can tell you, because, for example, well, every language should have modules, but no book requires the modules unless the topic is modules. You can imagine writing a little book about modules, but that's a different story. So I don't know if I've answered it to your satisfaction, but that's as close as I can come.
May I say something?
Yeah, Mitch?
No, Jerry. This is Jerry's husband.
Oh, Jerry, hi. Yeah.
I think one thing to realize is the most important thing is that the programs get written for people.
I can't hear you. Can you speak up a little?
Oh, I'm sorry. Programs must be written for people to understand as much as for computers to execute.
That's a great
That's
quote.
the critical thing, is that programming is a mechanism for doing for doing communication. Okay. Is that better?
Yes.
No.
Speaking of communication and people, you guys have want to announce something that may be coming out soon?
Oh.
You mean Jerry?
You mean me?
I can hear you now, yeah.
You mean me, right? Okay.
I do.
Yeah,
well,
yeah.
you or Julie, I don't care.
Yeah, it's the same. We're one.
That's right. So it doesn't matter.
Chris Hansen and I have been putting together a book that's pretty much coming out in the spring from MIT Press. We've spent the last many years working on it, and it's a book about very advanced programming technique. Okay.
Julie, you have any comments?
We have actually a book cover, but I don't know how to show it to you.
Yes, you do.
Okay, but anyway, I've read the book and I think it's fabulous. So
Dan
read it,
you
buy it, whatever.
Why don't you put your copy?
Did I do something wrong?
No, I was just saying Dan Friedman has written an endorsement for the book, which is on the back cover, actually.
Let me get the book.
Oh, thank you. I'm happy. I'm very happy. Okay, so anything else?
I just put a link to the book in chat.
Oh, good. That's great. How did you do that?
It's on the MIT Press webpage. I just put in the link.
Can you hear me now?
So I
Can
don't
you
think
hear
you
me
can
now?
hear us.
Yes? I can hear you.
Oh, you can?
I
Yeah,
can.
so I
Can you hear me?
Yes, yes, it's working. All good.
Okay, excellent. Okay. Any other questions?
Let me check. Yes, there are a couple of questions.
Okay.
So these are coming from like before the beginning of the conference. A form was sent out. So there are two of them. Let me start from the first one. In 2008, a not entirely reliable commentator wrote, "The power that macros provide programmers is widely discussed, yet it is unfortunately still widely misunderstood. In
Still,
particular,
I missed the last two words.
It's unfortunately widely misunderstood.
Yes.
In particular, combinations of macros represented the most vast and fertile area of research in programming languages today. That was a few years after you came out with the reasoned schemer, running rings around Prolog. Did your view of schemes, metaprogramming facilities evolve during that project? Was the reasoned schemer genuinely purely about linking functional and relational programming, or was there also an element of pushing the limits, doing an amazing stunt?
Well, what was the first question? Because I have an answer to that one. So go ahead with the first question.
So the first one was, did your view of schemes, metaprogramming facilities evolved during that project, the reasoned schemer?
No, absolutely not. I've been implementing languages all over the place. The goal of putting those in, and I had a goal, was to enlighten the world about the magical nature of macros. Now, I didn't have any macro generating macros in there. And you get that also with the simplest model. But no, absolutely not. I have been a fan of macros since I picked up the book by Clark Weissman, which I could probably pull off the shelf, but I didn't think that I would have to pull it off. But it's a wonderful book on Lisp. Big pages, big print, beautiful, very easy to read. And he described macros at that time the way he did it. But once, as I said, once Eugene figured out this hygiene problem, it was, there was nothing that I wanted ever again. And that was quite a few years ago in terms of macros.
Dan, I remember when I started, you were working on a paper and a talk called Object-Oriented Style. And your discussion of macros after working on on the macros for that paper after a summer was a little bit different. I think you were
because it used syntax case.
Yeah.
Syntax case is like, it's hard for me. I don't like to have moving around useful information be merged with doing arithmetic. I don't like it because in general, I can do better usually. Jason Heeman actually showed me an example where I was totally wrong. just to be honest, I said, oh, I don't know what I can do about that. That's going to be very hard to do. So there's at least one counterexample to my principle that you can always do whatever you want with just plain old hygienic macros. Did you want me to say anything more about macros, Will?
No, I mean, you just had this at the time you were
Oh,
a
I
little
had
upset.
I gotten so baffled trying to
Well,
figure out what they were trying to do.
What the problem was, I think
was
you
dizzy.
thought there was something missing, right? So syntax rules is this nice sort of term rewriting, approach, and then syntax case has full procedural macros, and what you wanted was syntax rules with just a little bit more power.
Yes, just a tad of useful information
and
that you
to
could
my
do.
knowledge, you've never gotten that. You don't
No,
have that to this day. So it
but
seems
there
like
was
there's something
one
missing
macro,
that you want.
Yeah, it's something I wanted. I wanted a syntax rules with just a little bit more stuff in it, and I think that's in Racket though by now, surely. The syntax parse.
I don't think no, it's not in Racket. Syntax parse is like a front end for syntax case, so you can do better error messages and things like that. I don't think what you want still exists. It's an open problem that people should work on.
It would be nice. It would be nice, but it's because when we were doing something called A9, which is this homework assignment that Jeremy Seek and Ron Garcia didn't know was going to be a homework assignment, but they did such a good job of doing the homework assignment that we've been using it some version of it forever since, which was to turn an arbitrary scheme expression into a C program, all with correctness preserving transformations. And that was quite an undertaking as far as I was concerned. And we wanted to teach the students some C, but we didn't want to teach the students some C. We just wanted to get a sense of what it was about. And that worked into a very nice homework assignment. What was the number of passes we had in it? Anybody remember? Will, you remember?
Well, first of all, what was the name of the assignment? It had a great
A9.
name. No, parenthesis.
Oh, parenthesis. Oh, the title of the handout. Yeah. Parenthesis.
C, because
C,
you're going
yes.
from parenthesized scheme down to C.
That's right. You're right.
Yeah. Well, you did it different ways, different semesters, but you ended up, you had to take this interpreter, CPS it, as a store passing, environment passing interpreter, make it, defunctionalize it, make a representation independent with respect to closures and environments and all that stuff, and then CPS it, and then you ended up going to either register machines or whatever.
Yeah, depends where we were going.
Trampolining or register machines,
yeah.
right?
Oh, yeah.
Yeah, and
Weishi, you
so
there?
those are all the steps.
Yeah. Weishi, are you there?
Yeah, hi.
How many passes does it take today?
I guess 10 or so.
About 10?
Yeah.
Now it's in 3 parts now. We let them work each part separately instead of all was one homework assignment. I'm growing soft in my old age. What can I say? All right. Any other questions out there?
Yeah, let me unmute. Yes, there is another one, and so here it is. Whereas you have been illuminating computer science for the better part of a century, probing notions that did not figure anywhere in the conscious awareness of the great unwashed masses, now suddenly the thundering herd has noticed functional programming and is whacking it like a piñata to see what candy falls out. Have you noticed interesting effects of the cultural change in the post-schemist notion you find in the new students approaching university?
Well, my first time that I teach is in the junior level. Sam Tobin-Hochstadt has been teaching the freshman level. So by the time they get to me, they already know a lot about higher order functions and all the goodies of Racket. And we do use Racket as our language. It's just the books are always in Scheme because we want to make it smaller. But I haven't noticed a thing. In all honesty, I've either been writing books or chatting with students when they get to me, and they seem to know an awful lot. That's the main thing, and I can move a little faster. than I usually had to in the past. Does that answer the question adequately?
I think so. Yep.
Okay. It's a great
yeah,
question
yeah.
and beautifully phrased, by the way.
Yes,
I love the phrasing of it.
I'm not doing like a great job in reading it out loud, but I hope you understand that.
I love the like a piñata.
Like a piñata was a good one. Where there's the last part of the previous question, and was the reason its schemer genuinely purely about linking functional and relational programming, or was there an element of pushing the limits and doing an amazing stunt?
That's a great question. That is absolutely a great question. I wanted every expression that you could write, wherever you wrote it, to fit somehow into the logic system. That was the primary goal I had in writing it. That's one of the reasons I chose macros, because they're very forgiving in that regard. I didn't succeed completely. And over the years, it's actually been whittled down because people feel like, oh, that's too much power to give any human mind. And I don't mind that it's whittled down, but the metaphor was you could put expressions absolutely anywhere. So if you're familiar with run, you should be able to not just put a number in, and you don't have to, and you're not restricted like that. But you can put an arbitrary expression in there. You could say, give me the first 4 digits of pi. And then it would come up with 3.14 whatever. And now make sure that you drop any decimals because it has to be an integer. Okay, so it's the number 3. Or you could throw a random number. I want a random number of answers. Okay, so I wanted to keep it as flexible as humanly possible. But I saw that many people felt that was too much power, and so it's not that much power anymore. I guess it's one way of saying it. But yeah, that's my answer to that question.
Fantastic. So at this point, I think we arrived at the end of the questions that we had queued up. The time is pretty good. We've been like a 1 hour and 20 minutes in.
I could offer you something that you might like.
Yeah, go ahead.
You can say no, and I'm happy to listen to that. I would like for Weishi to show you how we go from knowing virtually nothing to producing the Ackermann's function. I use it in my first lecture in 311, and by the time it's over, I can't say it's today's reality, but by the time it's over, there are a lot of jaws on the floor because it's extraordinary that you can take something that was famous in the was known in the early 1930s, late 1929, and blow people's minds with it and have them believe it really is important to understand how to think about functional programming languages. It may take what, about 15 minutes or so, Weishi?
Or 5.
Or 5? You can do 5.
Oh yeah, I mean, fantastic. I'm looking forward to it.
I'd love for him to show you this. We do it every semester. Let's
put it on video.
What's that?
Let's put it on video.
Well, if we do it now, it'll be on video.
Yeah, exactly.
Okay.
Do you need to share the screen? What do you need to do?
Give me the access.
I'll also mention that I've put a number of links in chat, including to the parenthesis exercise, if you want to read that.
You're saying that other people watching should go to the place where we hide parentheses. That's fine. I don't have any problems with it. No, I don't have any problems with that, Will. I just wanted to know if that's what you were saying.
Yeah, there are links on chat to, Jerry's new book and all that stuff. So anyway.
Okay,
yeah, that's good. I'm gonna collect all of them. They're having like both chats, one here, one on Discord, and I want to make sure that all the links that were mentioned are in a place where they are attached to the talk. So I'm trying to understand how to give Wishy sharing capabilities if it doesn't. But Wishy, can you tell me your handle on Zoom, because I cannot find you?
Oh, it's mvc.au. Let me
NVC.
Yeah. Oh, it's not my name.
What is it?
MVC. Okay, I found you. So now you should be able to share your screen. Try.
Yeah, that works. Okay.
Cool.
This means I'm going to go sit down. I'll be back if you need me.
Yeah, so this is a magic trick that Dan shows to every 311 students every single semester. And since when did you start to do that?
You have to look at the manual that we hand out.
Okay. Yeah, but anyways, let's. I'm gonna do this in a sibling language. It's Racket, so there should be not too much difficulty to transcribe it to Clojure. So usually Dan starts with the plus function, because probably that's the most straightforward recursive function everyone can write. Takes two numbers, maybe an m. And now we can start asking questions when doing recursion. The first thing to do is to find the base case. Well, if n 0, then we return m. Otherwise, we do a, that's what Dan called a natural recursion, which is taking the strictly smaller part of one argument and keep the rest just unchanged. So,
sorry to interrupt. Is everyone else?
Now you got to clean it up.
Yeah, no, guys. So the other thing Dan called it maybe a wrapper around this natural recursion. That is, once you have the result, how do you make it the real result? In this case, you simply can add one to it. So now we have plus. And so the second thing Dan will do is maybe multiplication. Same. And the beauty of writing recursion is you can minimize your mind effort. That is, maybe in this editor, I can just copy the previous block of code, drop it here, and you'll find out maybe everything are virtually the same. So the base case is we ask the same question, and if n 0, well, but the result may be different. So if we're multiplying two numbers, that will be 0. I think I'm doing it right. Okay. And this natural recursive part, it doesn't change. The only thing that got to be changed is the wrapper. And here we can call plus of maybe n. Oops, it's my autocompleter trying to outsmart me, but failed. Yeah, all right. And okay, and another thing that Dan teaches in 311 is just test your program as frequent as you can. So maybe we can try to see if these two definitions are correct. If my Racket wakes up, yeah, it does.
Should this n after the plus there be an m?
I think you're right. That's why I'm doing the testing.
Yeah.
That's what I do. I do.
Yes, it's just my Racket, don't worry. Let's keep writing the next function. And so we have plus multiplication. Maybe next is explanation. We can use upper arrow and Thanks Unicode, we have this pretty arrow here. And following the pattern.
There are 80 people in the room right now. No.
If the base case, let's just return 1 because we know it's 1. And here we times n. The right-hand side is supposed to be my Racket repo, but it's a little bit lazy today.
You can watch it later. You'll watch it later, yeah.
All right. So
you need the up arrow. Where you need the up arrow? Yeah. Line 19.
I do. Yeah. Thank you. Okay. So just following this pattern, you can just create an arbitrary function, even if you don't know what you are doing. Maybe the 2-leg arrow. And it's kind of an intuition that you can replace this upper arrow here and this multiplication with, anyone want to take a guess? It's 1-leg arrow, yeah. So what this function, what does it do? We don't know. But it's a natural recursive function that follows this pattern. So we know it terminates, it's fine, and it's beautifully written. And so, then now it's Dan's turn to ask this question. What if I'm asking you to write a upper arrow with 100 legs? How long will it take? Well, so one way, the most naive way to do it is to write 99 other functions until you have a upper arrow with 100 legs. But we are programmers and we know better. We write programs to generate programs. So maybe we can write a function that takes a number, and this number is the index of the number of legs. So if it takes 100, then it will spit out a function that is the upper arrow with 100 legs. So let's call this big G for generating functions. It takes this index, and so that means G of 0 is our plus function. G of 1 is this multiplication, and that's G of 2 explanation, so on and so forth. So we can ask questions about this I here. The only thing we can do recursion on. So if it's 0, we're going to return the plus function. So it's sitting right there. Let me do some indentation. Okay, the only thing is, once we have this G, there's no need to keep all those names like plus, multiplication, 1 arrow and 2 arrow. So this thing should gone. So once it's gone, we have a replacement for it, that is G of 0. How about this one? So if I have a multiplication, we can drop it here. That's for the case when I is 1. So we don't have this star now. It's called G of 1. Star, we don't have this cross. It's called G of 0. Then, right? And for anything else, that is, when I is larger than 2, we all have the same pattern. So I think this one is good enough for the else case. Right? So what's this arrow here? It's G of I. And this one is G of sub 1 of I. And now we have created the Ackermann function. It's actually not the Ackermann function. It's an a variation of the Ackermann function. It grows really fast. I can show how fast it grows if my Emacs wakes up. Sorry, let me just restart it.
Save the file first.
Yeah. Okay. Okay, let me run this thing again. I don't mind being caught off guard, but looks like my Emacs doesn't like it. So,
I don't see any errors. So
yeah,
somewhat mood if you can. Oh, look at that. Look at that.
Oh,
Yes.
all right.
Great.
GF0 is what plus? Let's just do 42. That works. How about explanation 2, 3 to the 5th, or maybe 5 to the 3rd? Yep, working. And it's Ackermann, so if this index, this I is somehow large, maybe 3, does it return? It returns
1.
That's not a good sign.
That's not a good sign.
Yeah.
What happened?
It's time to debug.
Well, why don't you start at the top and work through all of them?
Yeah.
Where it tells you what went wrong. All of them.
Mm-hmm.
Every last one of them. Go to the top.
Yep.
Go to the top of the. There you go. Now start with the first one. Just work your way through it.
Well, plus seems to be working, and
yeah. Plus works.
3 times 5.
Yeah.
Oh, we have GF2 working. So.
Yeah. So it's got to be the arrow.
Yeah. Arrow 1.
Oh, they're both the same arrow. That can't be. They look like the same arrow on the arrow definition.
Yep.
It's got to be something smaller.
Yeah.
Or is that 2 arrows? Oh, it is 2 arrows. Never mind.
Right. Mm-hmm.
Yeah.
Let's see. GF same thing.
No. Are you missing an extra print somewhere?
Maybe.
No, it's not. Doesn't have to be curried, does it? No, it's not curried. Never mind. Homework assignment. This does work, okay? We've done it 100 times.
Maybe let me look at my cheat sheet.
Your definition at the bottom has to be a. No, it's a 1 always. Yeah. That's 0. Huh.
Okay. So here's a version that works. But it's being massaged, so never mind. Other ones.
Anyone dare to suggest?
Oh, no, the sub ones are right. Huh.
Is the 0 case?
Well, you have it in, you have a copy of it somewhere, Weishi.
I do. Let's see.
You can just pull it up. It may have 19 steps in it or something, but. What is that line between the 2 parentheses on the else clause? Is that anything? It looks like a cursor between the left and the 2 first left rounded left parentheses.
It is the cursor.
Oh, there's 2 cursors. Was that Robert?
Yes.
Thank you, Robert.
So
strange.
That's strange. Yeah.
Online demos are never very good because they always fail.
Wow.
Too much pressure.
Yeah.
There's a certain
no
level
pressure,
of pressure.
No.
Will's manage the pressure really well, I've noticed.
It's because that's how I write everything, is the same way as I get the online presentations. I found a PDF from 2005 from C311 where I wrote like a whole tutorial on exactly how to go through these steps based on C311, and I'll post a link to that also.
Oh, thank you, Will.
Sure.
Okay.
Well, I just can't believe this.
Me neither.
It didn't work. So
it always happens when you do.
Why don't we do this? There is one last question, which is a good closure. That will give us another 5 minutes, in which you can see if you can spot the problem, and then present it at the end. So we don't we remove the pressure of the entire audience.
Nobody's watching.
Nobody's watching.
You can relax.
At least for a second. And the last question is, and just something to close on the usual polemic note is, where is it? I just want to read it in the same way I saw it. Okay, but essentially is the same as a question for everyone here is Emacs or not Emacs for what do you use for your programming?
I have only used Emacs for both programming and book writing. That's my answer to that. Thank you, Jerry.
No controversy.
Thank you. Nothing controversy about that. Bye-bye.
No controversy.
And what's the license for the Emacs?
GPL.
The software license. GPL.
Oh, right. Yes. GPL. Yeah.
Everything I've ever written is GPL.
Yeah.
And if I look at my computer, I don't think I have anything on it that's not a free license.
That's a good that's the right attitude. There's no doubt about it. The host has spotlighted your video for everyone.
Yes,
what does that mean?
I'm just switching the camera on and off from who is talking.
Oh, I see.
So everyone,
okay, that's fine.
Everyone can see.
Yeah.
Anyone else wants to give their preference, like a controversial answer?
I have a question actually. Does Clojure have its own IDE?
Not really.
That's the better answer coming from someone else.
Yeah, I mean, it's well, it is like most of the Clojure community is using Emacs. If you mean like an IDE that is written in Clojure, for Clojure, there are a few, but they're not common. They're not commonly used because there are a very strong IDE in the Java world that is relatively easy to write Clojure plugins for, and they are all integrated. So those are also taking a big slice of the market. But most of the people are being they were introduced to Clojure using Emacs, and that is probably, we can trace that back all the way to Richie presenting Clojure. The very first times he presented it, it was on an Emacs terminal.
Yeah.
As far as I remember.
Yeah.
So no Clojure IDE written in Clojure,
So,
but there are many.
I mean, anything in the Java world sort of requires some sort of, IDE support to actually be productive in, because there's so much crap that you have to boilerplate around using their jars and things like that. So does the Emacs mode actually support all of that?
So are you asking me?
Yeah, I mean, generally, I am not a Clojure user, so I'm sort of curious about how the productivity in that environment works.
In Emacs?
Yeah.
Oh, like pretty good. It's I think there are. I mean, I'm not an expert, but if I have to compare like what you can do in Emacs compared to what you can do in a Lisp environment, in a pure Lisp environment, what Lisp can offer you more than what Clojure can do is all the like the advanced debugging capabilities and like the possibility to go like more at the deeper level with the step-by-step debugging. But like in practical terms, in Emacs or other environments with Clojure, you can do like pretty advanced stuff. Everything that you need in practical terms.
Okay.
If anyone else wants to like answer.
May I add something?
Best IDE I've ever used.
There's a question down there from Maurice Zabo.
Well, they're more discussing, so they're not all questions, unfortunately. So I'm not able.
Okay, that's fine. That's fine.
It's a list of all the Clojure IDEs that there are, and there are many.
Okay, not that I'm an IDE fan. I hate them all. So I use Emacs even for Scala, which is sort of pushing it a little bit, but I still manage to use it.
Okay, so we can go back to Wishi, who found the bug, and we can perhaps close on a good note, on a positive note.
Let's see it.
Yeah. So the problem is I was not using my normal keyboard and lost my memory. So, but there it is, HHKB. So, all right. I figure the way I define arrow is kind of unconventional. When we have arrow 3 file, we were thinking like 3 to the 5th, but actually it's the other way. So I just swapped the target of doing recursion. So I think it's gonna work.
NPM versus NPM.
So here.
All the way through, you changed the target. Yeah.
Yeah. Now if GFI and GF sub 1 of I. Line 50.
You need a lambda on your else.
I do.
Okay.
So let's see, GF. Let's try a larger thing. If it doesn't return, then it's an Ackermann function. Well, it returns. It's a okay. If this one doesn't return, then it's an Ackermann function. All right, we have it.
Hooray!
And by the way, there are other correctness preserving transformations that will allow you to turn this directly into the standard 3-line Ackermann function. And we leave that, I think, today for an exercise for the brave. And besides, I want to have a homework assignment I can give. Anyway, I've enjoyed this very much, and I appreciate everyone who's come. And I just hope you have a great weekend and enjoy yourselves and relax. And it's been a lot of fun. I thank you very much, Renzo, for the invitation. If I was a little bit too forward, I apologize, but I get extremely excited when I'm talking about my stuff. So please,
it was a pleasure to have you, Dan.
Pleasure.
Completely our pleasure to have you, Dan, and that everyone else tonight in this conversation. It was a lot of fun. I got to read a few of your papers and part of your books in preparation for this, and this was like my gift for the conference, your gift to me for the conference. So thank you very much. And so just a couple of additional words. Let me just spotlight on me. So the conference is not finished for who is still in the Zoom meeting and on YouTube. This is the first half. Tomorrow we are going to have the second day. We're going to start at 8:30 GMT in the morning. Like to have a different time zone for a different part of the world. So hopefully we're helping with that. And there's going to be another 8 talks and another keynote. So feel free to join us again tomorrow. We're refreshed, have a shower, have a dinner, have a nice end of the day wherever you are. Thank you very much, everyone. Good night.
Thank you.
Thank you.
Good.
Thank you so much. Really great. Thanks.
Great conference.
Thank you.
Nice to see you guys.
Thank you.
Bye-bye.